Hello and welcome to this course in Introduction to Linux, where my goals and my intentions are to take you through the fundamentals of Linux. Now, it is no secret that the adoption and the use of Linux has picked up steam over the past couple of years. Individual users, government agencies, healthcare industry, the financial sector, the automobile industry, quantum computing, artificial intelligence, machine learning, the space exploration, all these technologies, one way or the other, are running the Linux kernel. So the goal for this course is to take you through just the entry level of Linux. And what I have also done is I have aligned this course with the key concept of the LPI Linux Essential Certification. So if you're somebody who is preparing for this certification, this will be a great course to add to your list of resources studying for this certification. And even if you're not studying for the certification and you want to understand or jump into the Linux world, this will be a great course for you to get into it. It is going to cover the foundations of Linux operating systems. We'll look at the command line, itself, and the basic concept around the open source, community. So let us run through quickly the content of this course. We're going to start with the Linux community and a career in open source. And then we'll proceed into finding your way on a Linux system. And then we'll jump into the power of the command line and then cross over into the Linux operating system. And then finally, finish up with the security and files permission. So let's start with the first module, which is the Linux community and a career in open source. And the first one is going to be the Linux evolution and the popular OS. So let's look at the description of this Linux evolution and popular OS. Essentially, this is going to give us the knowledge of Linux development and the major distributions within the Linux fraternity. Some of the key areas that we'll cover or capture are going to be the history and the philosophy of Linux, the components of a Linux distribution, embedded operating systems, and then also Linux in the cloud. And you hear us talking about some of these terminologies or key terms throughout this particular subsection. So let's get into an operating system. It's just a software that manages the computing hardware, the software resources, and other functionalities. So if you take a closer look at this particular image here, we have the bottom here is a hardware level. This is where we have the motherboard, we have the CPU, we have the RAM, we have the input, output, the mouse, the keyboard, the microphone, printers. All these things are connected, which are the hardware. Okay. And then on top of that, we have the OS running. And what it will do is it manages communication between the hardware and then the software at the top here. We have the system software, which are usually baked into the OS itself. Other applications also running. And then, of course, you are the user interacting with all these applications, and the OS is managing all these between you and then the hardware. So these are some of the primary functions of an OS. File management, you are able to create files on your computer, able to create text file, Word document, and the likes. That is one of the primary functions of the OS, helping you or managing you doing those things. Memory management is, of course, each computer hardware will have a memory to it. But we do not have unlimited memory. We have limited. So when you have several applications or programs requesting memory to be able to function, It is the OS in the middle managing all these things, making sure that each application has the needed memory to function. The same way with processes, open and closing systems, they all whip up a new process, and the OS is the one that manages all these things. And of course, it handles the input and output. When you type in all these things on a command line or in your text message, in your Word document, whatever, the output is being managed, the input is being managed by the OS, and the output you see on your screen or the monitor is also being managed by the OS. And then, of course, we have additional peripherals such as the hard drives, printers, keyboard, wireless mouse, and all those things are also being managed by the OS. So these are the high-level functionalities that most OSs do provide when you run those. Linux is actually not an operating system. It is a kernel. Now, a software that contains the core components of the OS is what we call the kernel. Now, we have two kinds of mode that you hear a lot within the IT community, and that is at any point in time, one system has two types of mode that is operating. We have the kernel mode, we have the user mode. For most of us, everything that we do will be in a user mode. You may hear some things about the ring, which is beyond the scope of this discussion. Again, you may hear that as well, all right? Everything that runs within certain range within the ring is in a kernel mode, and others are outside in the user mode. The three most popular ones are Windows operating system, Linux, and then the Apple Mac OS X. So these are the three most well-known OSs out there. So now that we have understood what an OS is, now let's get into the history memory lane of how we got here with Linux. All right, so in the 1950s, operating systems evolved, but were only running as just a bash with no user interaction. So we'll just list up or just write up a whole bunch of things that needs to be done in a batch form, and then have the system run them sequentially with no human interaction. So in the 1960s, we upgraded ourselves over to an interactive operating system, also known as time-sharing OS. And that allowed multiple users to connect to one computer from different terminals and then execute functions simultaneously. All right, so we had one computer, and then we may have about 2, 3, or even 10 different users connected to this particular computer, and then give it instructions to execute. So that was the time-sharing operating system. And then between 1963 and 1969, some smart guys at MIT, GE, and Bell Labs developed the MULTIX, which is the Multiplex Information and Computing Service OS. All right. So with that, we had to, of course, upgrade ourselves a little bit more. But this particular image, as much as it doesn't look that fancy, gives you an overview of how a time sharing system looked like. So on this side is the actual host computer. We have the terminals that are connected, and then each individual user is just assigned to each of these terminals, and then they execute instructions, and then this machine will get all these and then begin to sort them out according to their needs. And that was what we call the time sharing. All these terminals are sharing the time from this one particular computer. So from the 1963 to 1969 was when we had the MULTIX. But then 1970, the smart guys at Bell Labs again went on their own way and then developed the Unix operating system. Now, of course, just like most of the things in open source, this came out as free and was adopted mostly by universities. But of course, over time, it became a mainstream OS being used by bigger organizations. And with bigger organizations, they had bigger money in their budget. And this was turned into a commercialized OS, and it became expensive. Not everyone could afford the Unix at the time. Unix is a trademark and it's not open source. Linux is not Unix. Linux is not certified. It's open source, but it is Unix-like. Unix is a trademark of the open group, all right? And any system must be certified to be called Unix. So in 1987, another smart guy came out called Andrew Tannenbaum, and he created Minix and then made it open source. So honestly, Andrew needs to be given much more credit, the same way that we give Linus Torvalds, because he opened up that space for Linus to also write up on that Minix and then created or developed Linux kernel, as we know now. So that was 1991 was when Linus Torvalds developed Linux. It was just like a hobby, but he got people supporting and contributing to Linux, and that was how it became such a successful project. So in 1992, Linux was licensed under the GPL by GNU, the General Public License, making Linux open source for all of us. So that was a quick history about Linux and how we got here. So now let's get back to what is Linux, all right? So like I mentioned, Linux is not operating system. Now, I am part of that people who always keep saying Linux operating system, right? But it's actually a kernel. The kernel is just like a glue or the brain that facilitates operation of all the programs within the system. So the kernel basically it's like a workhorse. You have your terminal open, you have your browser open, you have so many things running, and all of them are demanding resources from the computer or from the hardware. The kernel interfaces with the hardware devices such as adapters, hard drives, and the likes, and then it would allocate memory to each of the individual programs to make the system stable. It would always also allocate central processing unit times to each of the individual programs. It enables programs to interact with each other. So if anyone asks you again about Linux as an OS, you correct them and tell them Linux is actually a kernel, but it is when we combine the kernel with tools, programs, and applications is when we do get an operating system. Linux by itself is not OS, but when we combine different or various programs and tools with it to make it functional is when we get a fully functional OS. Linux is open source, and that means freedom to use Linux for any purpose, freedom to change Linux to meet your needs, and then also freedom to share your changes with anyone. The community is so vibrant that periodically they do release newer versions of Linux. Again, no licensing cost to users, and anyone can modify the code to meet their personal needs. All right, so the kernel of the OS will manage all the application processes on the system, okay? So again, talking about the different kinds of mode or the two types of mode, right? So this picture perfectly shows you the modes that we're dealing with here and where, the kernel sits. We have the kernel space and the user space on the typical system. And then we have the hardware. This whole is the hardware. And then we have the architecture dependent, code. Now we have the kernel and then the system call interface, which interfaces with the libraries and then applications for you as a user to use that. So the kernel handles memory allocations to programs, Programs life cycle, which is when we open and then close a program. So for instance, if let's say you open a terminal, that starts a process, and the kernel is in charge of handling that particular process all the way until you click the X button to close it out. So let's say again, if we have two applications to use the same resource, let's say you have a browser, you have your Chrome browser open, and then let's say you have a terminal open. Both of these applications need resources such as RAM or part of the CPU to run their processes. The kernel would decide which one runs and in which one gets this amount of RAM or CPU time versus the other. And that is the job of the kernel. Few more terms applicable to kernel is the fact that a kernel implements multitasking. Like I said, it's a workhorse. So it's taking so many requests from everywhere and then just multitasking, assigning resources, hardware, CPU time, RAM time to this and that and that. And that is how it manages so the system doesn't hang up. Some of you may be familiar with how sometimes you run a program and then you see that annoying warning saying not responding, right? That is when there is not enough resource to run that particular program. The kernel is the one doing all these things for you. It will handle the switching of multiple applications through what we call the preemptive multitasking. Okay, so then when you push the button on a computer, what happens is, of course, when you run in a Linux machine, you see some lines of code running through the screen before you get to a point where you can actually log in, right? Well, that is what we call the bootloader. The bootloader is a piece of code that loads when a system starts. It will load, first of all, the kernel, the Linux kernel, so that the system can run programs such as your web server and other services. And we'll look at that and the structure, the sequence upon which the bootloader works in the subsequent slides. Linux started off as just as a hobby, and then the source code was made freely available to everyone in the IT community to review and then modify. But what is a source code? Well, a source code is basically when a human writes instructions and then wants a computer to run that particular instruction. Because humans speak different language, in our case, human readable form, A, B, C, D, all the way through Z, computers read different form of language and they read in zeros and ones. So we write in source code, program it in any programming language, such as a C, which is what Linux is written in, C++ or C#. These are all various or types of programming languages that can be used to write a code. And that is what we call the source code. When the source code is made available for anyone to see the instructions you wrote as a human, that is what we call open source. Okay. Now, you ask yourself, well, if the humans, we speak in a language or we write our code in a language that computers do not understand, how do we get computers to actually execute our instructions? Well, that comes in compilers. Compilers would normally take the code and then transform that into a machine code, such as a Linux kernel, to be run on a system. So if we have open source, definitely we're going to have closed source, right? So closed source is a complete opposite of open source. Closed source is when the source code is not made available to anyone. The only thing made available to users is a machine code, but we do not speak the machine code, so it doesn't even make sense to us. But there are some people who may be able to reverse engineer. That means they can transform the machine code back to human code and then understand what the writers did or the instructions. Of course, the closed source prohibit or is against reverse engineering because they believe that they need to be paid for their work. And if you want to have my code, than just use it and not understand what I wrote in it, right? All right, so open source, if you have the source code, you can make changes and see how it works. Open source means you can inspect and modify the source code to your liking. And of course, just when you thought it's open source and it's open source, but we have different kinds of open source here, my friends, and we're going to look into that in the future slides. But first is what we call the free open source software. But we'll look at some of the various types of open source during the course of this session. So we don't necessarily have Linux OS. We have Linux distributions. And if you recall back to what we talked about, the open source is when we can take a source code and then modify. But what happened in the community, in the Linux community, was because people were able to take the Linux kernel, combine that with components such as software, programs, application packages, they were able to distribute once they have all this new package, taking kernel, adding in my own sprinkles of software, application, programming packages. Now I can distribute that to the community and then have people use it. So that is how we came about the Linux distribution. Is we don't have Linux OS itself, but we have distributions. When people distribute their work to the public for us to enjoy benefit and even add in our additional enhancement. So the three major players in the Linux distribution families are the Red Hat, Debian, and SUSE. Red Hat has mainly been commercial, and then it branched and then got into also community version. So Fedora is one of the well-known, free version. CentOS and Scientific Linux are also part of the Fedora distribution or family. For Debian, Ubuntu is very, very well known, which we'll see in our upcoming demos. We'll use Ubuntu a lot for most of our demos. And then we have Linux Mint. SUSE, the open source version, is open source. So now let's get into a little bit of all, these three various families. So start with Red Hat. So the Red Hat uses for the management of this platform. And when I say management, I mean administration, installing, updating, upgrading, removing applications from the system. It uses what we call the package manager. And in this case, Red Hat uses YARN. Red Hat is commercial in nature. It's actually used a lot by the government entities and some of the big players in the industry, the financial industry, and then the big data industry as well. Fedora, of course, they want to also cater to the industry or to the community. So Fedora is a community version of Red Hat Enterprise Linux. And we'll be taking a look at Fedora as well in our upcoming demo sessions. Next one is the Debian. Debian is pure open source effort. That means we don't have any commercial version of Debian. Ubuntu is the most well-known derived distribution within the Debian community. It uses the apt advanced package tool for managing software or applications on the Debian-based distribution. So managing means installing, updating, upgrading, and also removing packages on a system. Ubuntu can be used as either a desktop or a server. The third one is the SUSE Linux Enterprise. It contains proprietary code and is sold as a server product. As I mentioned, the open source version of it or the community version is an open source one. It uses two kinds of packages for managing this the platform. We have the zipper, can be used for installation, updating, upgrading, and removing or deleting packages on a system, and also has the yet another setup tool for additional system administration. Open source is a desktop based and available to the general public. So you can see that even the ones that have commercial aspect, which is in the source, and then so Red Hat, they also still have the open source version that you can use whether as an organization or even as an enterprise. Okay, so the next is what makes Linux so powerful or well-known or popular nowadays globally? Well, can you imagine that about 75% of the stock exchange platforms run Linux? All right, so we're talking about New York Stock Exchange, and some of these big stock exchange servers are running Linux. All right, so that tells you how powerful and how well supported this particular OS is. And I think it's because of the open source nature of it. Some of the bigger players such as Dell, HP, IBM are all running most of their enterprise servers on Linux. Even most users are now making Linux distribution, whether it's Ubuntu or some other flavors, as now their personal or their number one OS running on either their desktop or their laptop. Some of you who may have heard about single board devices such as Raspberry Pi, all these run Linux. Embedded devices, we have routers. Most of your routers are all running Linux. Phones, Android is one of the major players in the mobile devices in the world, and that is Linux. We have some custom hardware such as TiVo, which is in the media industry, that has Linux running. We have most of our cloud computing services, all of them behind the scenes or underneath it, they are running Linux distributions. IoT, Internet of Service devices are all, or most of them are running Linux. And of course, the internet, most of the devices or systems running the online or the internet are running Linux. And for some of you driving most of these smart vehicles that have this nice info entertainment dashboards for you to use a touch screen and have them even provide you with a Wi-Fi, beneath them are all running Linux. So sometimes I have come across people who get scared a bit when it comes to Linux. They don't want to even deal with it at all. And some of them comes down to some of our terminologies that we use. Sometimes can be very confusing and intimidating. So we're just going to use this particular slide to just capture one or two terminologies that you may have heard or even haven't heard before. And this might be something that you may, like to know. All right. So meet Kernel. Again, we talked about Kernel. It's a program that connects the hardware and application in a Linux. An example is a Linux kernel. Now, the reason why this is an example is kernel doesn't mean only Linux. Linux kernel is one type of kernel. All right. So that's why we have that as an example, right? Distribution, as I said, is a collection of programs, applications, utilities combined with a Linux kernel to make up the Linux-based OS. All right. Bootloader, again, we mentioned that. So a program that boosts on the operating system when a computer is powered on. We have a service or a daemon. So a program that runs as a background process on a system is called a service or a daemon. An example is SSHD, which will run the SSH service, so you to have a remote connection to a system. You may have FTPD, which is a file transfer protocol daemon, which will run the FTP service on your system to facilitate the file and the transfer and sharing of files on a system. We may have HTTPD, which will provide you with a hypertext protocol daemon for web access on a system. So when you hear about service or daemon, that is what it means. A program that runs in the background on a system to provide services to users or other service or systems. Additional terminologies, you will hear about a file system. It's a method for storing and organizing files in system. Example is NTFS, FAT, EXT, and HFS. We have the X Windows system, also known as X11 or just X. It's a graphical subsystem that provides us with the basic GUI. So when you see a dashboard, when you see the desktop on your computer running, let's say Ubuntu or any sort of Linux-based distribution, the X11 or the X Windows system provides you with that desktop. The desktop environment is a graphical user interface programs that runs on top of the Linux-based operating system. An example is GNOME or KDE or XFCE. Command line is a software program that interfaces OS for typing commands on a system, and will do a lot on a command line. All right, so it provides it with access to be able to type in a command, so we talk back to the operating system. The shell is a command line interpreter that interfaces with the OS, takes program input, and then execute on the OS. And we'll talk about this as well in our upcoming demos. That was the first subsection of our module. The next one is we are now going to talk about the major open source applications. We briefly touched on that. Now we're going to dip deeper into some of the open source applications. So the brief description about this sub module is to get an awareness of the major applications as well as the use cases and development. And some of the key areas that we'll cover in this particular sub module is desktop applications, server applications, mobile applications, package management tools and repositories, internet applications such as browsers, email programs, office productivity such as the LibreOffice, development tools such as compilers and debuggers. And these are some of the terms that you will hear or see within this sub module. So let's start with some of the Linux roles. The Linux kernel runs countless number of software applications across many hardware platforms. And some of the services or the roles that you may see Linux providing are servers, and sometimes you may hear them as headless OS. It basically provides you with a command line only system that runs program without providing graphical user interface. And we'll see one, we'll look at an Ubuntu server versus an Ubuntu desktop when it comes to logging in. They run services to serve information to other computers, usually called clients. So we have the server and we have the client. If you remember, during our terminologies, we made mention about services or daemons, right? So the servers would normally run daemons or services, and they provide service to clients. So for instance, they may run file server or web server or mail server, and those are meant to serve the request from clients. Clients can be desktop clients, they can be your mobile phone, it can be anything that requests a resource from a server. The Linux can also play the role of just a desktop as well, or as a client. So the desktop or the client runs or provides the graphical user interface and interactivity to you as an end user. So when you sit on a computer and you are browsing, you're using the text editor, you're using a command line, playing the music, whatever, you are now acting as a client on your desktop and then requesting resources from a server. Another role that Linux can also play is mobile devices. As I made mention, Android runs Linux, okay? And it's one of the most biggest player in the world. Some of the things that you see nowadays, smart devices such as fridges and washers and dryers, all of these, most of them are all running Linux as the kernel. For development, so for users who want to program or develop some code and things like that, Linux provides that functionality to be able to use IDE. We'll talk about that in a minute. to write your programs. And of course, we talked about embedded devices such as your TVs, your IoTs, your refrigerators. All these are systems that are running the Linux kernel. So let's look at some of the major services or roles that Linux provides. One of them is, of course, web server. And the reason why Linux is used a lot by the web servers is the reliability and efficiency. Compared to other OS, Linux tends to use less resources than other OSs because you can cut back on the extra services that you don't need. And those are the ones that normally, use a lot of your computing resources. So Linux allows you to cut back and then just disable some services that you don't need compared to other OSs, what you just have in some pre-installed software, and all this just eat up some of your CPUs or your memory. All right, so one of them is a web server, as I mentioned. So a web server hosts content for web pages and serves them through the HTTP or HTTPS, which is a secure version. So when it comes to web services or content, we have two types. When we first started off with a web application or the website, things were all in static page. The static page is just a flat page that is delivered to you user exactly as it is stored on a disk. You just browse to a page and there's no interactivity. You just see what it is and you just request it and you see that. No way to navigate and then see some things changing, blinking flags and all that. You don't see that. But then eventually the needs of users went beyond just static pages. We want to be able to make some purchases. We want to be able to play some videos, be able to make some modifications to our pictures and all those things. And that needed us to be able to be dynamic. So we had to make the web page to be much more dynamic so we can upload videos, pictures, media, stuff like that, right? So a dynamic page is when we use additional technologies such as PHP, Java, Ruby to make the page a bit more dynamic and much more interactive. An example is WordPress. The two major players that provide web server services are Apache and Nginx. And these two combined are the most popular web servers in the world. The next service that you would also find Linux providing is mail services, sending, receiving, and reading your messages over the internet. Some of the systems providing these services are running the Linux distributions. Let's see the different components or the moving parts that happen when it comes to mail exchanges. So the first service is the mail transfer agent, the MTA. So this server determines which server needs to receive the email. So it uses what we call the SMTP protocol, the simple mail transfer protocol, to route emails to their destination mail servers. So for instance, an organization, with several MTAs, of course, yes, you can have more than one MTAs. Emails will run through several hubs or several systems or servers before it gets to its final destination. And some of the most popular protocols you see handling or providing the MTA services are SendMail and Postfix. The next technology is the mail delivery agent, also known as a local delivery agent. Now, this one, once the mail comes into your organization's infrastructure or your network, this server is responsible for the storage and delivery of your email to your mailbox. And it would normally invoke from the final MTA because we have several MTAs serving as a hub, right? From the source, it will go through or route through different MTAs, and the final MTA is where your mail will get to, and then the MDA will obtain that mail from that, the last MTA server, and then host it locally and then deliver into your mailbox. An example of an MDA is the proc mail. The final or the third one is the post office protocol or the internet message access protocol, PAP or IMAP. And those are the two kinds of protocols that will retrieve your stored email from the remote server into your client or your browser so you can read. The two examples are Dovecote and then also Cyrus. The next role that you may also find within an organization is Linux providing a file services. When you want to share files locally on your local network, you may have a server that provides such services for you. So let's say an organization of, let's say, 5 people. You may have a central server to help you share files as opposed to each individual sending files to each one of you. That is going to be too much work. Now, for 5 people, it may not seem like a much work, but imagine having 10,000 employees and they want to read just one file, right? So you may want a server that would host that file and then make it readily available to be shared organization-wide. And that is what we call file servers. And Linux is well known for providing such a role within an organization. An example is Network File System. It's a native Unix file sharing protocol, allowing a system to share their directories and then files with others over a network. It performs much more faster and uses less CPU operation than when it comes to Samba. So Samba is another type of file sharing protocol. It's a collection of tools for accessing networked server message block shares. It's compatible with other operating systems, and that is what Samba is much more popular than the previous one because it's compatible with Windows operating system. So if you have a Linux machine running Samba, it's able to communicate or talk to Windows OS. And then when it comes to the Apple side, NataTalk is the protocol that allows the sharing of files in the Apple's computing environment. When it comes to networking communication, there are several services that need to be implemented to allow communication between and among systems. One of them is domain name search system. So DNS is when the system able to resolve a domain name into an IP address. So back to systems and human communication. As people, we are able to read things when we have them written down. So for instance, we have google.com. It's easy for us to read that, but computers are not able to translate that to what we're thinking. They need google.com in a number form. So google.com may have an IP address assigned as, there's an example, 8.8.8.8. But as humans, we are not able to memorize these numbers easily. It's easier for us to know example.com, google.com, yahoo.com, ibm.com than memorizing some numbers. So the domain name system, the DNS server, is able to have a database, so to speak, of domain names mapped to IP addresses. So when we type in www.example.com, the DNS server is able to translate that into an IP address and then request that particular resource for us. And that is what a domain name system does. And most of the DNS servers out there in the world run on Linux. The next one is Lightweight Directory Access Control Protocol, LDAP. It's a service for managing objects within an enterprise or within an organization's domain infrastructure. So if we want to be able to pull up users, employees within an organization, the computers, the printers, and all these resources, the protocol that facilitates giving such information is called LDAP. OpenLDAP is an open source version of LDAP. Let's say you work in an organization and you work in the first time you're issued a laptop. You open up your laptop, you boot it up, and then log in. And then within few seconds, you are assigned access to, let's say, the internal network or to the internet. Well, to be able to communicate with resources, you need an IP address. But have you asked yourself, how did I get an IP address? How was I issued an IP address magically? Well, that is a role of the dynamic host configuration protocol server. It's a server that runs a service that issue an IP address to new or existing hosts on a network based on leasing. So when you log into your first time to your computer on a network, what your system does behind the scenes is it broadcasts and then asks for an IP address from the local or the nearest DHCP server, and the DHCP server will offer an IP address to your system if you accept it or not. And then once it has accepted, it will give that IP address to your system so that it can use that within, most of the time, within 8 hours. So we have most of these DHCP services running on Linux machines. So that is how Linux also plays a part when it comes to network infrastructure services. So the next one is databases. Database servers do store data for easy processing, such as retrieving and querying information. And the two most popular ones within the Linux community are the MySQL and PostgreSQL. And then the language which they use to query data is called a structured SQL language. And this is an example of how to make a request of all users from the student's database. And a lot of the database servers in the world are running Linux kernel. So Linux providing such a service or such a role. So let's run through a quick demo on MySQL. We are going to start up an Ubuntu desktop. So you can see a quick process as the kernel is being loaded before we are prompted as a user to log in with our username and password. And then we'll try to demonstrate how we can turn this desktop to run a database service as a role for us. Things are happening behind the scenes. So now we are prompted to log in with our username and password. So we are presented with the Ubuntu desktop. So we are going to open up a terminal, right click on the desktop, or we can go through the applications and then look for the terminal. Because this is a fresh Ubuntu instance, we may need to install a Docker application on the system. And as you recall, we did mention about apt as the package manager for the Debian distribution family. So in this case, we're using sudo apt and then install, and it's going to be docker.io, and hit enter. And I'll type Y to continue. So Docker is installed, and don't worry if these commands look a bit foreign to you. We'll cover these extensively in our upcoming slides. So now that we have Docker installed, the next thing is we are going to pull the MySQL Docker image. So let me clear the screen, and that is going to be sudo docker and then pull MySQL. So what is happening here is we are pulling up an image of MySQL, and we are going to eventually turn this desktop to run a MySQL database management service. So recall that we talked about the several roles that Linux can play. In this case, we are installing a service for MySQL database, which can be used to interact with an application. We can use that to create user, update user, or even remove a user. All right, so now we have this image downloaded. The next thing is we are going to connect to, we're going to start it up and then connect to this Docker instance. And an example command for that is going to be this. So we run in Docker, we're running that, and we're going to provide a name of test MySQL, and then the password for the MySQL user, root user, is password 123, and it is going to run the daemon, which is going to be the service at the background, and it's going to pull up the most recent or latest MySQL. Right, so we hit enter, and that is running. Now that we have this Docker running, next is we're going to list Docker containers. To confirm, yes, and this is running. We have a container ID. And when we're done, we're going to connect to this container through a shell. This can be the container ID or the name. Let's try this with a container ID first. And we are in. So right now we are within the MySQL instance of Docker. So now we are going to try to connect to the MySQL service itself. So we'll type in MySQL and -u, the username is root, and the P, the password is password 123. And now we are in the MySQL database. The next is we want to show databases. So show databases. And that will show us the existing databases on this MySQL. If we want to interact with any one of the databases, we can use a command use. And then in this case, let's say we want to interact with the MySQL database. And that will change that or switch it over to the MySQL database. So now if we want to show the tables from this database, we can just do show tables. And that will give us all the tables in this particular database. Okay, let's say we want to dump the information on a particular table. We can just use select, and then this is going to select all the information saved up in this database, and in this case from the user table. Remember, these are all tables, so we are interested in this one here. So we're saying that select everything that we have within this user table, and I hit enter, and that will give us all the users. So we have 5 rows, and it doesn't look that appealing, but essentially what we have here is the host, user, the select priv, and all these are individual columns, attributes within this database. And then we'll begin to list out the users in this database. So for instance, we have the root as a user, and then we have the privilege and all these, and then the password hash as well. All right, so what happened here was we have been able to turn this Ubuntu desktop into MySQL database, which is one of the roles that we've talked about that Linux can provide for us. The only thing here left out is we can have a front-end application and then have it talk back to the database and create users, and then be able to interact with information saved up in this database. So let's continue with the roles that Linux does provide for us. We've captured the major services that most of Linux servers would normally provide for us. So let's get into the user side. Even though we use the Ubuntu desktop, we're able to still have it function as a server running MySQL database. Well, there are some instances where you and I as regular users can even use Ubuntu as our primary operating system, doing the same things that other OSs such as Microsoft, Windows operating system will do for us. So one of the roles that users find very useful is a graphical desktop. So Linux systems can pack with a lot of client applications such as games, productivity applications, multimedia players, and a whole bunch of things that you may not even be aware of that you're doing on your Windows OS, but can also be done on your Ubuntu or Linux distribution. So a Linux user normally have two options when it comes to using the Linux system. You can either use it, most of the things, through a command line interface, which is what you saw me doing through the terminal, or the graphical user interface, which again is what you saw me logging in into the Ubuntu desktop. So using the graphical user interface is much more appealing to most users that I've come across, because honestly, most people are intimidated by Linux itself. So they are used to just, the graphical interface because of the nature of how much we are exposed to the Windows OS in most of our lives. So again, we touched briefly on what actually helps us to have this graphical interface in Linux. One of them is the Windows system, or the X11. So the X Windows system is loaded as one of the final steps in Linux boot process. And you notice that, right? When I booted up the Ubuntu, it went through, you saw some gibberish stuff going up, on the screen, and then eventually presented us with a user login, page. That is the final phase in the booting process, and that is provided by the X11 system or the X Windows. So the X Windows system is old, but it's still being used. But again, with some newer versions of Linux distributions, we are now getting more into what we call the Wayland. And this has been adopted by Fedora as a default display system. And we get to see Fedora in a minute, because I'm running both Ubuntu, desktop, and server, and also Fedora. So you can have a feel of both, these two major distributions. Another part of, service that helps us in being able to move around or use the graphical desktop on Linux is the window managers. So the window manager controls the placement and the movement of windows on your Ubuntu or your Linux system, such as dragging around and then moving, titles. As you saw me expand in a terminal, that is the works of the Windows Manager. So let's look at some examples of desktop environments. So on the left side here is a little bit of an older Ubuntu desktop. And then you also see that on the far right here, you see we have Fedora right here as well. So the desktop environment will normally consist of Session Manager, which stores and maintains the components of the graphical session. And there are several Windows managers and tools that you can come across. In fact, these are all changeable and customizable to your taste. So some people like NOM, others like KDE, others like XFCE. So it depends on what you like. But we have some default ones which normally come out when you boot up your particular distribution. And for instance, Debian, the default is normally a NOM. So another role that Linux plays, which most end users may not be aware of, is being able to use Linux for most of your daily stuff that you are used to when it comes to Windows operating system. So within Windows, we have Word document, Excel, PowerPoint, Access. We have equivalent of these within the Linux families. So how do we get those? Well, most Linux distributions offer an open source office called LibreOffice from the folks at openoffice.org, but it has a bit of a history to it. The original name was Star Office by the original makers of this particular product until the company was acquired by Sun Microsystems in 1996. So what happened was when Sun Microsystems acquired this product, they rebranded the name to Open Office and then open sourced it. So initially it was a closed source, talking about open source and closed source, right? So fast forward in 2010, Oracle bought Sun Microsystems and then handed over this Open Office project to the Apache Foundation. So OpenOffice projects was later forked to become the LibreOffice. So if you want to know what is included in this particular product, it has a writer, which is the word processing. It has Calc, which is spreadsheet. It has Impress, which is presentation, and then Draw, which is create and edit graphics and diagrams. So the LibreOffice components are also compatible with Microsoft Office Suite. So that means if you do anything on a Linux distribution and say write an essay or a resume using, let's say, Writer, which is the word process equivalent of Windows, of Linux, you'll be able to have it open up and it should work on a Windows system, even though you use a Linux system to write up your essay or your resume. Another thing that you can also see, of course, is when I open up the applications is internet services, right? You can browse. The typical things you can do with on Windows machine can be done on Linux, such as browsing the internet, watching videos, doing any research that you can do, or even sending emails back and forth. So some of the things that you see when it comes to internet applications are web browsers, email client, streaming media applications, IRCs, and even conferencing software. All these are now available within most of the popular Linux distributions, example being Ubuntu. All right, so again, let's keep rolling with the internet applications. So Linux offers a wide variety of web browsers in both graphical and text-based, such as Firefox, Google Chrome, and Chromium. So email applications, which do facilitate the sending and receiving and reading of messages over the internet, are all can be done within your Linux distribution. Linux email clients can either be graphical or text-based. That is one thing about Linux is you can do things in several ways. One thing can be done in either graphical way or a command line. So for instance, a graphical client email such as Evolution and Clause can be used on Linux, providing you with a graphical interface. On the other hand, if you're somebody who likes to do things more on a command line, you can use Mat as a command line email client to send and receive or manage emails. All web browsers such as Google Chrome can be used to access emails. So the email client, of course, uses POP, which we talked about, or IMAP to retrieve email. Other internet applications that you can use within Linux is FileZilla for file transfer, sharing files through either FTP or secure FTP, Pigeon, and also HexChat. So these are just examples. All right, so let's look at how we can, take advantage or browse around some of these applications or use applications that we can find useful in our daily activities. So with our Ubuntu app, we can see that on the left side, we already have some favorite applications already pinned on this side. So for instance, we have Firefox browser here. We have Thunderbird mail here, which is equivalent to the Microsoft Outlook. So once you have that up and running, it is going to ask you to set it up. You can input your regular email address and then your password, and you should be good to go. So this is how you go about it. And once you log in with your full name, your email address and password, just like a regular thing you do on a browser. All right, so let me close that. And the next is we can also, this is for listening to music. And then this is the LibreOffice Writer, equivalent to Microsoft Word. So let's click on that and see what we can do here with it. And the good thing is it will give you some tips the first time you run it. So it will guide you through how to use it. But as you can see, it looks almost the same as your regular Microsoft Word. So this is a test. All right. And then once you're done, you can see at the top here has everything that you are used to when it comes to Microsoft Office, right? So let's say we want to change our font. We can come down here and then change it. We want to maybe bold in it, italize, maybe underline it. All these are things that, let's say, we want to change our font color to red. So these are all the options, that the things that you can do with your Microsoft Office Word document. You can use the LibreOffice Writer to do that, and you don't have to pay a dime for it because it's open source. Once you're done, you can just go to File and then just save, and you can find any location. So this is going to be on document. Let's say I go to the desktop, and then I'll just name it and then just save. And you look at the bottom here, it is going to save this as .dt. If you want to change it, you can always scroll down and then save it as, let's say, Word document to make it much more compatible. So let's say we save it as this. So click on save. All right, so we use this format, and then we can close out. All right, and you can see that it's here. And if you take this over to anyone running on Windows operating system, they are able to open this without a problem. All right, so we can also go into show applications and click on that, and we'll see additional things that we can use to do our daily activities. We have the Libre Impress, which is equivalent to PowerPoint, and it would even give you some templates that you can work with. So let's scroll down, and let's pick Candy and open. All right, there we go. And we can create our PowerPoint slides or presentation. And then once we're done, go to save and come down here. And again, see if we have an option to save as, PowerPoint slide. And let's say you are looking for an application that cannot be found with a default installation of Ubuntu or Linux distribution. You can always go into the Ubuntu software. All right, so this is being opened for the first time, so it might take some time to download and catalog everything for you. So it's pulling up the most up-to-date versions of all the applications. So yes, that is going to take some time. So once you have the Ubuntu software running, these are all the various applications you can install. We have Spotify here, we have MailSpring, we have Audacity. So these are all available, and you can even see them in categories, right? So if you want to get into development or entertainment, let's say development, we can click on that and then see some of the applications that are within the development category, and install those as well on our system. So these are all the available development applications that you can pick and install. We'll get back here in a minute and then maybe do some installations for a couple of these so we can use them to do some code writing and stuff like that. So that is a quick demo on how you can actually utilize Ubuntu for almost anything that you'll be using or you have used your Windows OS for. All right, so now that we have covered some of the roles that Linux does play for us, both as a service and also for end user, let's look into some of the components within Linux that some of us may find useful. Those in the development or much more advanced can find Linux useful when it comes to either doing things on a command line or going beyond just basic usage of Linux. So the Linux OS is quite popular when it comes to the cybersecurity industry. All right. So if you're somebody who is also trying to already in the cybersecurity, it is always important that you get to use Linux for most of your work. And one of the reasons why this is due to the fact that it is very flexible, for us to interact with through what we call the shell, which, allow us to remotely or even attach a keyboard to a system and then remotely be able to interact with systems remotely. What also facilitates that is the terminal. And you saw that I opened that on the Ubuntu desktop. So the terminal provides the user the command line interface to perform tasks such as installing application or even using that to connect to system, like you saw, connecting from the Ubuntu system to the MySQL Docker instance. All right. So that when terminal is open, it will show the current user and the name of the host system. And if you didn't notice that, you notice it when we go back to the demo, that the first time you open the terminal would always give you the name and the system that you're connected to. So in this case, you can see this particular image here. We have John at Doe. Of course, these are all customizable, and we'll even do that one of our customizations in the course of this class. All right, so let's keep moving. Again, the command line is a text input that lets a user type and execute tasks. The user gets immediate access to a console when we log in through the text mode, which is the non-graphical mode. And we're able to access the command line through the terminal. So some of the benefits of the command line is, of course, because there is no GUI, most of the time we're doing this through, let's say, a server, which wouldn't have a graphical user interface. It reduces the overhead on a Linux system because the GUI, all of these are being whipped up. When you boot up the system, it will load up the kernel, and then the kernel will begin to call up all these other applications, such as the desktop managers and all those. And these are all using resources on the Linux system. But the server or the command line version of the desktop doesn't have to load up all these services, hence reduces the overhead on the system. So of course, most tasks can be executed from a command line without needing to use the desktop. And we can create a script and run from a command line. Of course, we'll get into scripting in the upcoming sessions on these slides. It allows for easy remote access to a system from anywhere on the internet through SSH, FTP, and other services that allow remote connection. We can start the graphical applications also from a command line. Another terminology or component of Linux is a shell. The shell is a utility for interacting with the Linux system. So when we open up a terminal and then we begin to type in something, we are interacting with the Linux system through a shell. So the shell would take commands from us, the user, as we type in, and then pass them to the Linux kernel for execution. And there are some examples of shell that you see a lot. The most well-known ones are the Bourne shell, the C shell, and the Corn shell. The one that is by default on most of Linux systems is the Bourne Again shell or the Bash. And the shell prompt ending with a $sign means it's running with unprivileged user. So that means you've logged in with a user that doesn't have a root or an admin level on the system. And so for most of the advanced users on Linux systems, they may like to write their own script or edit configuration file or write a code for programming language such as C or Java. Now, before the advent of IDE or the development programs, text editors were used a lot for editing and also writing code or scripting. So text editors are so important when it comes to Linux machines, Linux systems, and we have several of them. We have Nano, we have gedit, we have Pico, we have VI or Vim or Emacs. The use of each is based on preference. So the Nano one is a basic, terminal text editor. For those who are getting into Linux, that is the most easiest way to get into text editing, to write your script or change configuration. The syntax on using the Nano is Nano and the name of the file, and then press enter. And then you can begin to type in your command or your instructions. Okay, so we talked briefly on development tools, which we'll get back in a minute. So Linux offers tools and applications, including compilers and debuggers. So as you remember, we talked about compilers, which take a human readable code and then compile them into machine readable, right? Well, sometimes a code doesn't go the way you want it to function or work, right? So sometimes when you write your code and then run it, once you're done writing your code and then run it, you may run into problems. And that is where debuggers come in. The debuggers may help you to debug or find out the problems within your code and then fix them. Now, computer language makes it possible for a programmer to write instructions in a human readable format and have them translated into a computer readable format, as we explained in our previous slides. So language can either be compiled or interpreted. Okay, so when somebody writes a code and they want to have it understood by a computer, one of them is interpreted and one of them is compiled. Compiled code, the code is completely compiled together into, let's say, .exe and then run. Whereas interpreted code is being translated as and when it's been executed. So something .py, which is Python, and then once you click run or type enter or whatever, then it begins to interpret as and when the code is being executed. Libraries combine tasks into manageable packages to reduce the amount of code needed. So sometimes you write up your program and you may need to borrow a piece of code and not all of it. And that is when library comes in. So let's say you're running a code and you need to use OpenSSL in that code. So you can call up that library into your program. Debuggers such as GDB and IDS. You've heard me talking about IDS, stands for Integrated Development Environment, such as Eclipse or even Visual Studio, which we'll get into that in a minute, have additional capabilities to make us write code or even scripts. Done a lot of talking, so let's jump quickly into a demo. So first, let's start off and use the text editor, Nano. So we can just type in Nano. Let's first list our directory. We don't have anything here. Let's change directory into desktop. And then we are just going to create text.txt. That's it. And that will drop us into that particular text. So we'll just type, and then once we're done, we'll just do control. So if you look at the bottom here, it will show us how to exit out. So these are all options on how to use this editor. So we'll do Control X, and it's going to ask us if we want to save this document. So we'll type in Y for yes, N for no, and then C for cancel. So we'll type in Y, and then it wants us to name it, but it already has a name called test.txt. So we don't need to change anything. We'll just hit enter, and then that's it. And we can see that the text has been created. So we can click and drag it, bring it up here, double click on this to open it. We'll see that our text is here. So this is just a basic way of using Nano to create a file. So now let's go back and then try to install the Visual Studio. We can do that from a command line or from the Ubuntu software. So let's click on that, go to development. So it's here, it's called code. So we click on that, and we can see it will give us brief description. So Visual Studio Code is a new choice of tool that combines the simplicity of code editor with what developers need for the core edit, build, debug cycle. So we'll click on install. And because this requires privileged access, it's going to prompt us for a password. And that is going to install the Visual Studio. We have the Visual Studio installed. In fact, Visual Studio is really powerful, and it's a Microsoft Windows tool, but we can run it, as you can see, on Linux and also on Apple Mac OS X. It has extensions for other code or interpreters, development tools such as Java, JavaScript, Python, even PowerShell. So to call it out, we can go to either show applications, and its Visual Studio is here. Or we can go to Terminal, and then let's clear the screen, and we can just type code, COD like that, hit enter, and that should bring up the Visual Studio. So we get it running. So it takes us to the Get Started, and you can always open a terminal at the bottom here. We'll use that in the future for some of our work, our command line scripting work. Let's move on to the next sub-module, open source software and licensing. Most people don't pay attention to this particular topic, but I think it will pay you dividend to understand some of these concepts when it comes to open source. Because if you want to get into Linux, you have to understand the whole concept around open source. So in this particular sub-module, we are going to look at the open communities and the licensing open source software for businesses. Some of the areas we'll discuss or cover are open source philosophy, open source licensing, the Free Software Foundation, the Open Source Initiative, and then the various software licenses and their differences. All right, so software licenses. All right, so software licensing is one of the most complicated topics or elements when it comes to the IT community, because most people don't like to talk about it or don't want to even understand, because quite honestly, it can be a little bit scary and even boring going through all these things. But having a general understanding of how software licensing works can help you answer a few questions, which would include where can a software program be installed. So if you obtain a software, what are the licensing guidelines, requirements, and limitations as to where can you install this application or this software? How many times can you install or reinstall the application? So for instance, is the application licensed to only one person or unlimited? And if it's licensed to one person or unlimited, can you reinstall it on another system? So licensing will help you understand those questions. Are you allowed to copy, modify, or redistribute the software program? Can you reverse engineer the underlying source code? Who owns the intellectual property of the software program? So understanding or having basic understanding of how software licensing works will help you answer some of these questions. So generally, a person or a company that created a software owns the right to the software, unless otherwise. So they own the right to the software, and they can determine how the licensing works. So the creator usually has a power to grant a software license to others to use the software. So let's look at the software licensing is what determines whether the program becomes open source or closed source. So the owner of the creator of the application or the software can say, I would want this software to be open source. Anyone can pick it apart, make changes or modifications, and redistribute to their own likings. Or I don't want this code to be reverse engineered. I want this to be closed source. So the licensing will determine whether it's an open source or it's going to be a closed source. So an example we've said previously is Microsoft Windows is a closed source. So that requires an end user license agreement. The GNU General Public License or the GNU GPL, or simply the GPL, is a series of widely used free software licenses that guarantee the end user the full freedom to run, study, share, and modify a software. So that is the four freedoms: run, share, study, and modify the software. So Linux, of course, is open source under the GNU Public License version 2. Yes, we have version 2 and then version 3. All right, so the version 2 says you must put your changes under the same license for others to benefit. So if you obtain a version 2 of GPL, you have to, once you've made your changes, everything, it has to be under the same license that your original one was. Only charge for your actual cost of distributing the changes. So let's say you made some changes, and as you were doing all these things, you were doing this on a cloud computer, or you were paying for all these modifications and then have to host it, and hosting costs you money. So version 2 is saying that this cost you can charge for that, but not the actual code or the modifications that you did. The software licensing can be broken into commercial. So the software developer sells the software for profit, such as Microsoft OS, right? The software is kept proprietary and secret. Redistribution of software is illegal. And we also have a shareware, which is similar to the commercial. It's copyrighted, and the developer expects payment. The software is provided as trial, and after trial period, you are required to pay. So sometimes they want you to test out the application or their software and then see if you like it. If you do like it, now once the trial period is over, you can purchase the software so you can contribute to them covering up the expenses or their costs. We also have a freeware. The software is available for free, but usually they have a light version compared to the commercial version. So maybe the person wants to cater to people who may not need a software for bigger things. They will just want it for lightweight stuff. So they'll have a stripped down version of the software to cater to, small individual people for free. But if you are, let's say, an enterprise or a business that need additional features, then they'll sell you the commercial version of the software to you. And then we have the actual free one, the open source. Free as in free, no cost. The source code is available to the public. You can make modifications to the code and then also redistribute. So let's get into some of the open source community. So we have the free and open source software. First, the creator of the software gives up the right to tell how the software is used and or redistributed. All right, so that is a whole concept about FOSS. Simply, you have the program for free, you have the source code, you have the freedom to modify it, and you are free to distribute. An example is, even though Linus Torvalds was the creator of Linux, he cannot tell you how you modify, how you make some changes, or even how you distribute once you made your changes. All right, so he gave out the right to tell anyone where to install or use Linux under the GPL version 2 licenses, and that is what the FOSS operate or created under. Let's look at the open source leadership, because over time we saw people rising up and then advocating for free software distribution. So given the complexity of the nature of this licensing game, there were two major and influential entities leading the open source campaign, which are the Free Software Foundation and the Open Source Initiative. So the Free Software Foundation was founded by Richard Stallman in 1985, and it promotes free software, means freedom to review, study, and modify the code. And it was, of course, opposed to closed software ideology. There was one particular concept that this particular community was advocating, and that was copyleft. You should be required to share your modifications if you make changes to the free software. So basically, if you pick up and make modifications to a free software, you should be, or you are required to share your modification to the general public. And that is what the concept of copyleft is, as opposed to copyright. So it advocates against patents and standards organization. They developed the GPL version 2, version 3, and what we call the lesser GPL licenses versions 2 and 3. So LGPL version 2 and LGPL version 3. So the GPL version 2 and 3 licenses allow you to modify and redistribute the software. The version 2 does not permit redistribution of software that uses a closed source library. So for instance, a hardware driver, but the LGPL versions allow that. So again, confusion here, right? The GPL version 2 does not permit you to redistribute a software that use, let's say, a closed source library, but the lesser one allows you to do that. TiVo uses an open source software, but they built their own hardware and then run it and then run the software on top of that. So even though the software is open source, the hardware is not. Okay, so they sell in their business model, they are selling you the hardware and not the software, because the software is open source. But you cannot just use the hardware without anything. You need the software to get it to run, right? So they are just their business model is we're using open source software, but we're paying to build the hardware, and that is what we're charging you for. So that's a concept when it comes to TiVo. The second one is the Open Source Initiative, the OSI, and this was founded in 1998 by Bruce Perens and Eric Raymond. So this came about because they did not agree with the copyleft ideology. If we go back to the copyleft ideology, it says you should be required to share your modifications if you make changes to a free software. And these guys said, no, we don't agree with that. They believe software source code should be freely available and also no restrictions on the use of the software, regardless of its intended use. So these guys are preaching free, no restrictions on how you go about it. Another difference between the OSI and then the FSF is that these guys did not create their own licenses, but only endorse them. So open source software is a software that conforms to the open source licenses. So we have a family of BSD and even MIT. The open source initiative does support or approve the licenses coming from the Free Software Foundation. But because the OSI doesn't necessarily have their own licenses, and even if they do, they are not necessarily approved by the FSF group. FSF licenses such as GPL version 2 are also open source licenses. However, BSD and MIT do not contain the copyleft provisions and are thus not acceptable to FSF. So these are the two major licenses that come under the OSI, the BSD family and MIT. But because these are not copyleft licenses, they are not approved or accepted by the FSF because these guys support the copyleft ideology. So now let's keep moving. There are some other licensing terms that you might also get yourself familiar with. We have the free or the libre and open source software, the community term used for both FSF and OSI software. So some people came together and they decided, you know what, we like both FSF and then OSI. So they formed the Force of Flaws, and they are using both the terms, they're using the licenses and ideology from both the OSI and FSF community. They are saying software can be free as in no cost or free as in no restrictions. Using Force software means you don't have to pay for it, and you can redistribute it as you wish. And then we also have some other licenses that do not pertain to software. We have the non-software licensing, and those are the ones that are applicable to, let's say, art and written materials, which are licensed under what we call the Creative Commons licenses, or the CC licenses. Under the CC license, a copyright holder can restrict the commercial use of the product license. So let's look into some of the licenses under the Creative Commons license, founded by Lawrence Lessig And it aims at the multimedia, which is the video and audio recording and literature properties. So we have several of these, and this can be confusing, but I'll try my best to go through these, so it doesn't create too much confusion. So the types of the CC licenses are as follows. We have the attribution, or the CC BY, free to use, but must give credit to the copyright holder. So we can download a movie or download an audio or an art. That is CC BY or attribution, but you have to give credit to the creator or the holder of that particular asset or media. The next one is attribution share alike, CC BY-SA. So modified content must be shared under the same license similar to the free software ideology. Again, this goes back to the FSF, copyleft. So if we make any modification, so let's say you took a song or an audio or video, whatever, and they made some modifications to it, you have to share that new modified version according to the original terms or the licenses that particular asset was under. So the next one is attribution, no derivatives. So CC BY-ND, you should not make changes to the contents when redistributing. So again, this one has much more restrictions. If you pick up this asset or this particular audio or video, do not make any changes when you are redistributing. Redistribute as it was originally when you got it. All right. And then we have the attribution, non-commercial, CC BY-NC, no commercial use of the content. That is very easy to explain. If you obtain it, you can still share it or whatever, but do not make money off of it. And then we have attribution, non-commercial, share alike, CC BY-NC SA. Modifications should be shared under the same license, but no commercial use of the content. You can make modification, share it under the same license agreement, but don't make money off of it. Attribution, non-commercial, no derivatives, CC BY-NC ND. The content should neither be used for commercial purpose nor changes made to the content. Just use it, obtain it, don't do anything at all to it, all right? Don't make any changes to the content, neither should you sell it. And then the final one is no rights reserved, CC 0, that the author just disposes of all his or her rights to this particular item or asset. So that means you can pick it apart and do whatever you want to it, aka public domain. So there is no need for you to seek permission, give credit or whatever when the product or the item or the asset you are obtaining has the no rights reserved. The author relinquishes all rights. All right. So these are the types of the Creative Commons licenses that you may come across. We've talked about open source a lot, but what is the business model? The people who create all these things and then distribute for free for us. For instance, Ubuntu, is free, but we have hundreds of people who are working daily for this product, so you and I can have and then use them for free. But how do they make money? How do they pay for their bills, expenses, employee, all those things, right? So let's look at some of the approaches that is, open source organizations or people use to generate revenue or income. One of them is working as a consultant to provide support to the software through installation and troubleshooting. So the software can be free, but the creator of it can provide you with consulting services and say, listen, you can have my software for free, but if you need help with installation and troubleshooting, then I'll charge you, I'll provide consultation, and then charge you for my service for that. So some people or organizations make money through that. You can also have income from the service subscription for the software. So an example is Ubuntu support subscription. So let's say you're an organization that installs Ubuntu and you want support throughout the life of the Ubuntu server. Well, you can subscribe to that from Ubuntu, and then you pay them money, and then they'll periodically support you, assist you whenever you need help or assistance with the platform or the software. The next one is also install the free software on a custom hardware and then sell the product. I gave an example of TiVo. All right, so TiVo is a media house. They sell TV services to customers, but they're running with Linux, which is open source. But the hardware is custom built by the company. So they don't sell the software, but they sell the hardware service. Even though it also contains the open source software on it, they're charging you for the cost of building the hardware. And that is how some companies make money from open source initiatives. We can also work on feature enhancement in exchange for money. So sometimes the vanilla open source application or software may not meet your standard and it may miss some features. So the maker or the creator of that can also build features that are paid for. So you can have the vanilla, and if you want to upgrade or have additional features, then you can pay for those enhancements. And that is how they make money. Some also build plugins, paid plugins and modules to also, again, add more enhancement to the software. And some also go through with donation. So sometimes you go to some sites and then you have somebody saying, buy me a coffee. They will have like a code on, let's say, GitHub, and then or their website, and you use the software, or you try to download, and it will have a link saying buy me a coffee. That means they're asking for donation. For the work they put in for that particular software. So these are all several ways that the open source business do work and make money. So let's take a closer look at some of these licenses as you're browsing around trying to obtain copies of some software or art or audio or video of that nature. So the first license type we're going to look for is, we'll head over to google.com, and I am going to search for GNU public license. We'll hit enter, and that should bring us here. All right, so the next one is, let's click on the images. And then once we click here, we'll have all these options that we can use this image. But you have to remember that some of these are under some type of licenses that we may not be able to freely use them on our presentations or things that we're working on. So to get into finding images which are free to use, as in free in beer, we'll go to tools, click on that, and then we'll come down to the usage right, and we'll click on that. And now we'll see that we have the Creative Commons licenses and then commercial and other licenses. So we can go into Creative Commons and click on that, and that will give us the images that are now under the Creative Commons license and may be free for us to use without any penalization. So the next one is, let's get to YouTube, and the same thing here on YouTube. We'll paste in the same search and search for it. And we have all these results for the GNU public license version 2. Again, these may have different kinds of licenses that we may not be able to use or may have restrictions. So to narrow down our search to only the Creative Commons, we can go to filter and then all the way down to features, and we'll go all the way down and we should see Creative Commons. Now look at how the list becomes a little bit smaller once we select the Creative Commons, similar to what we got from google.com. All right, so some of them have vanished because they may have restrictions on the licenses when it comes to using the GPL version 2 information here, in video on youtube.com. All right, the last one that I want to go to is GitHub. GitHub is a very well-known platform for obtaining and using open source software. So on GitHub, the first thing you may even see is once you get to the website, there is an option here to select on the open source drop down. And you might even see some, like we talked about how to support the open source community, right? So found open source developers, okay? So we can click on the GitHub sponsors and we'll see a team of sponsors who are helping the open source community by donating either money or some other means to the developers on GitHub. All right, so if you scroll the way down, we'll begin to see all this information on how you can even donate to a developer on GitHub. So let's go back and let's search for a tool. So we can search for this particular tool called Sliver. And it's developed by Bishop Fox. And just right to get to this point, you see that it is actually GPL version 3. All right, and most of these are the same. This person may have made a modification and they have to submit that under the same license because this is your original creators of the server, and someone provided a Docker version of it and has to provide it under the same license right here. But let's click on the original tool. And on the left side, we should see again that they've specified GPL version 3.0 license, and we can click on that and then read more on this particular license. So this license will give us the permissions that we have once we obtain this tool and our limitations and other conditions. All right, so these are all the permissions. Commercial use, so that means you can have this tool, make some modifications, and then sell it if you want to. You can modify, you can distribute, even add paid and use, and even private use as well. Good. Next in our submodule is ICT skills and working in Linux. This part is going to actually get more into the Linux boot process. So the description for this subsection is basic information and communication technology skills, ICT skills, and also working in Linux. Some of these might be a bit of repetition from our previous slides, but the main areas we're going to focus are going to be the desktop skills, the command line, and also the industry's use of Linux for cloud computing and also virtualization. So this is going to focus again more on the moment you push the power button on a Linux system, what happens. Most of the things happen very, very fast, so you can't catch up with, but a lot goes on. Some stages have to go on through the process before you, the user, is prompted to log in with your username and your password. And the first stage of the booting process is the basic input output system, or the BIOS. This is the first stage in the booting process. And what it will normally do is it will initialize the post process, which is basically testing out some of the hardware to ensure they are functioning properly. So some of them are checking to see the screen, your screen and the keyboard are functioning, the main memory or the other components that form the computer are working properly. So it's what we call the power on self-test process, the post. All right, so the BIOS software is stored on a ROM chip on a motherboard. And after this stage, the rest of the booting process is controlled by the operating system itself. And you can see that this is a simplistic process of what happens when you turn on or hit a reset on a system. First is the system startup or hardware initialization, which is kicked off by the BIOS or the system start. The next is going to be two-phase of the booting process is going to be the bootloader stage 1 and the bootloader stage 2. And then the kernel is loaded up or is called out, and the first process is kicked in, and then the user is prompted to either provide the username or password, either from the command line or the terminal or from a GUI. So let's go into details of the rest of the stages in the next slide. So once the BIOS is kicked off, now we get into the master boot record and the bootloader. So the system control passes the BIOS to the bootloader. So remember, this is the first stage, and then the system will now pass on the BIOS to the bootloader. The bootloader can be found on a system's hard disk, either in the boot sector, either within the BIOS or the master boot record system, or the EFI partition, the Unified Extensible Firmware Interface, or EFI or UEFI system. So that is where the bootloader can be found. It can be found in any one of these locations. Now the bootloader will now load the kernel image and the initial RAM disk or file system into memory. Example of a bootloader is a GRUB. So it stands for the Grand Unified Bootloader. We have another one called ISO Linux for booting from the removable media. Sometimes you may want to plug in a USB flash drive and then have a system boot from that particular flash drive. And that one may have a bootloader of ISO Linux. And we also have -u-boot for booting on embedded devices or appliances. So for instance, a refrigerator or washer and dryer, these are embedded devices, and those use the -u-boot bootloader. The bootloader has two stages here. So the first one is the bootloader resides in the master boot record, and the first stage bootloader finds a partition table and finds a bootable partition from that table. From that going, the second bootloader resides in the /boot, which will show you when it comes to the file system where that resides. The second bootloader finds and loads the GRUB into random access memory, responsible for displaying the splash on the screen for a user to choose an OS to boot from. What this means is sometimes you may have different kinds of kernel versions that when you get to the second stage from the bootloader, you are prompted to choose which kernel you want to choose from or select from. So on the far right side here, you see the kernel number, but sometimes if you were to click on advanced option for Kali Linux, it will give you maybe one or two, it will give you 2 or 3 different kinds of kernel to choose from, so you can select which OS to boot from. The bootloader loads the kernel of the selected OS into RAM and then passes the control to the kernel. Again, back to our diagram or to our picture. So the second one will now load the OS that we have chosen and then pass it over to the kernel. All right, so now that is passed over to the kernel. Then we go to, from the kernel, it begins to do its own thing. So the kernel will load both the kernel and the initial RAM-based file system into memory. The kernel will now begin to configure the system memory and then all the attached hard drive in it. All this stands for is initial random disk. It contains the programs and binary files that perform all the actions needed to mount the proper root file system. This also contains the necessary drivers to access the hard drive partitions and other hardware components. And this will kick in the first program, which is the sbin/init program, and that becomes the first system. So if you go back again to our diagram, now from the kernel, it is now going to start up the first program and the init, or the first process, okay? And that can be found within the sbin/init program. So the init and services will start the initial process. Init becomes the parent process, to most of the processes that are started up after the init. Now, gradually, we are phasing out init to systemd or system daemon, which is now becoming much more available as an option than the init. And the reason that is because it is a little bit much more faster than the init method, and that the systemd takes over the init process, which will now point the init, so sbin init, to the lib systemd, and then systemd, and then systemd. So if you want to now, let's say after the system is booted up, you want to start up any additional service, you can always use a systemctl, which is a syntax for using a systemd to either start, stop, or restart a program or a service. So this is a syntax you can use to call out systemd to manipulate whether to start, to stop, or restart a service. So now once this is completed, this is where now you are the user, you are going to see a prompt, which is the final stage in the boot process or the boot sequence. So near the end of the boot process, the init starts a number of prompts for the user to take the necessary actions. One of these prompts is login prompt for the user to type username and password and then press enter to get a command shell. As you can see in this particular screen here, after the whole thing is completed, the final stage is the user prompt where we type in the username and password and then we are logged in. So before we get into the Linux environment, let's take a closer look at an example of when we boot up, let's say, a Linux Ubuntu server. So this is an Ubuntu server. So we are going to simulate powering up an Ubuntu server for the first time. And then let's see the sequence of events that goes through with what we just described. So it's powered on. Now it's going to do the post, which is going to be the power on self-test to see that the hardware, the necessary hardware are connected and functioning properly, such as the screen, the keyboard, the memory, the CPUs, and stuff like that. All right, so these are happening very, very fast. So everything that we described is happening behind the scenes very, very fast. Checking, USB stuff, PCI stuff, and making sure that they are all properly working. Checking out, the hard disk, and getting OKs here. Mounting stuff. All right, all these you can see grub failed boot detection is going to, yep. So now it was very, very quick. So this is the final stage. The final stage, it's still doing things. It's not done yet. So it was just in a quick break and it's still loading up some services. You can see that it's starting some services, snap application, finished executing cloud user / final scripts, reach target cloud init. So these are all services that are being spun up as you boot up the system. All right. So now we have the prompt for us to log in as a user. So type in user and then password, and then we are logged in. All right. So this completes the booting process, and we gain access to a shell or to a terminal right away. And you can see the difference between this as a server, because we talked about the fact that the terminal or the shell gives us one of the benefits of a command line is less overhead, right? Because it doesn't give us graphical user interface. This is a server, so we don't have all those splashy dash desktop here. All we have here is just this prompt, and that is all. So the Linux environments, and I think we can run through this quickly because we have done this already. As we mentioned, we can run Linux in either graphical mode, which we have seen already with our Ubuntu desktop, or non-graphical mode, which we just saw with our Ubuntu server. So the non-graphical mode this is something that you see. And one of the unique things you see about the non-graphical mode or the terminal is going to be the message of the day. You can customize that. So in this case, I have this one customized. Once you log in, it will give you information about the environment, and that is what we mean by MOTD. So even though the Ubuntu server, which is running the non-graphical mode, gives us direct access to a shell, the Ubuntu workstation terminal that we have been working with, which is the graphical desktop terminal, is not actually a full-blown terminal. It is just going through what we call the emulator. We access the terminal through the terminal emulator. That behaves as if we are right on the server, or as if the user is logged into the system in purely non-graphical mode. So if you take a look at the screenshots we have here, this is an example of a terminal emulator from Fedora, and then we have this console for Ubuntu. Of course, we have several examples, or we have several types of emulators that you can have to run your terminal. So we have the norm terminal, we have the Xterm, we have the RxVT console, and then Terminator. Now, depending on the version of the Linux distribution that you run in with, you need a key combination to get into the virtual terminal. So on Ubuntu, during the course of I'm preparing for this course, at the time, the key combination that worked for me was Alt Control F3, and that would drop you into a non-graphical virtual terminal interface, and you can get out of it with Alt Control F1. But these key combinations do change depending on the console type that you you're logged in with. So typically, the numbers range from F1 through F6, and you can use F7 to exit out. Again, these are subject to how it functions on your side. So let's bring up our Ubuntu and let's try some key combinations and see which one of these would work. But in the meantime, let's bring up the terminal again and show that we can open up several of these by using this tab. All right, so you can have many of these terminals. And let's try if we can have the virtual terminal that would drop us into a non-graphical mode. So I am going to try key combinations, Control plus F, and then let me try F4. Yep, there we go. So F4 actually did work to drop me into the virtual terminal. And now I can just log in with the username and password, and this will drop me in as if I am logging as the directly on a non-graphical mode. So this is what we call virtual terminal. We can type in TTY, and then we'll see that we're using TTY4, which is a virtual terminal 4. And we can do everything else like we would have done from the server that we did with Ubuntu server. We can just do Control D to log out if we want to log out of this terminal, and that will log us out. We can just still log in again. All right, and if you want to log out, this is a little bit challenging. Again, it falls down to key combinations, but if it doesn't work, we can just always reboot this computer completely. All right, so if we do key combination, let's say Control Alt, and let's try F7 and see that didn't work. 5, 6, none of these are working. But then again, like I said, it's a key combination thing. You have to find out which one works best for you. If it doesn't work, you can always just log out and then just reboot. A key combination to get this thing to reboot is actually very simple. It's Control Alt Delete. So we'll just do Control Alt Delete, and that will reboot for us. And again, this is because some of the key combinations were not working for me, and I don't want to spend too much time here. let's look into another aspect of Linux, which makes it very, useful and great for most people. And one of the concepts is the multi-user concept. So Linux system is a multi-user operating system. By design, it allows or facilitates multiple use by different users connected at the same time. Of course, depending on the processing power of the computer, such as the CPU and the RAM and stuff like that, the more simultaneous use of the system, the more the impact it will have on performance. But the bottom line is Linux is well known for being a multi-user system. Everyone can run as an unprivileged user within their own space on a system. The next philosophy is virtualization. All right, because of how powerful Linux is, we are able to run virtualization, on that. And virtualization basically is you have one computer, which is the host, and then that runs multiple guest systems. You can see that in this demo, I'm using VMware Workstation. That is facilitating virtualization, whereby I have the actual host of my system running Windows 11 operating system, but I'm able to run additional OSs on this same machine running as guest systems. So Linux, like the Linux kernel, the host uses what we call the hypervisor software that runs and manages the guest. So my Windows 10 laptop is running the hypervisor software and enabling that to run multiple OSs on it. Again, the host uses its available and idle resources such as the CPU, the disk space, RAM to make these guest systems run. So I'm running, aside from my other OS that I'm running on this virtual machine, on this Windows 11, I'm running Ubuntu server, Ubuntu desktop, and also Fedora at the same time. We can run different types of OSs on a virtual environment, and that reduces the number of physical servers you need to run your system. Because if you can spin up, let's say, about 10 separate systems on one machine, that is great to save space for physical servers. Easy to spin up. We can create snapshots of each of the OSs or our system. So in case anything goes wrong, we can always revert to the original instance that we need. All right. So in addition to virtualization is cloud computing. Cloud computing is basically people's computer sitting somewhere that you have no physical access to, but you're able to run several virtual machines without even you needing to see the physical nature of those servers. It can run an OS, it can run application, software, storage, database, network, you name it. Some of the well-known players in the cloud computing area are AWS by Amazon. We have Azure by Microsoft. We have Bluemix by IBM. And then we have Google Cloud Platform. These are the major players. And mostly this is pay as you go or pay as you use kind of services where you pay per minute or so or per day or whatever. So again, cloud computing, most of them are running on Linux server because of the powerful nature of Linux kernel. So with all these things and using Linux, there are some few things that you may also want to take consideration with, because every system is a potential room for vulnerability and also being used against you. So you need to find a way to secure your system, and some of the basic things that you want to take advantage of or you want to be aware of when you're using Linux is using a password. All right, on average, regular users have, on average, regular users have 20 passwords to remember. All right, so one way that people normally keep their password and not have to remember all the 20 passwords is using password managers such as keypacks. These are all part of the packages that you can find within Linux as an open source. And when it comes to choosing passwords, some recommendations are, 10 or more characters, a mixture of uppercase and lowercase, and then adding symbols or characters to your password. Another way to protect yourself against attacks is also using Firewall. Linux uses its own native firewall utility to control inbound and outbound connection to your system. For instance, Ubuntu has the GUI firewall, solution that it's a graphical interface firewall that you can use to control the connections to and from your computer. For those who are much more advanced, you can use IP table, which is a command line, backend for the firewall. So if you want to use a command line, you can use IP table to set up some firewall rules on your system. And again, always keep your system up to date by periodically running system updates. All right, so let's take a quick look at how you can access the this feature from a command line on Ubuntu. So on Ubuntu, we can bring up the GUFW up from a command line. And as you can see, it looks like we don't have the firewall turned on. So it's as simple as just dragging to the right, and that should turn on firewall, and you should be good to go. Of course, there are many ways that you can program. I mean, you can set up some rules for firewalls, but that is beyond the scope of this class. Just wanted to show you how you can turn on and off firewall on your Ubuntu. Let's proceed with the second module, finding your way on a Linux system. And the first sub-module is command line basics, which is going to cover just the basics of using the Linux command line. And some of the key areas we'll cover are the basic shell, command line syntax, variables, coding, and also globing. So just again, a quick recap. Most users are familiar or comfortable using the graphical user interface on the Linux system. And this goes back to the ages where we all grew up with Microsoft operating system. And that always offered graphical user interface. So we are much more comfortable with using that. However, when it comes to people who use Linux on daily basis, such as system admins, they most likely like to use the command line prompt because it has some key features. It is a preferred way of interacting with Unix systems before the advent of graphical user interface. It relies solely on a keyboard, which dates back to the time sharing scenario where we connect our keyboard to a remote system and all we have access to is just a terminal. The command line interface, which helps us in with a command line prompt, also is a text-based environment. As you had seen in one of our previous demo using the Ubuntu server, we were only dropped into a text-based environment. It also helps us to easily automate some of our tasks through creation of script, which we'll dive into that in the course of this course. We gain access to the command line through a terminal, and commands from a terminal are passed to a shell, which you can see as an example here. We have the username and then the system upon which this user is connected to. And this is a screenshot showing a terminal on a Fedora system. There are ways that we can access the terminal. You have seen that again in our previous demo. It's either through the application system and then we can find the terminal, or we can right click on the desktop and then access the terminal. The shell. So the shell basically takes input from a user and then execute the operation that we tell it to do. Most input lines entered at a shell prompt have three basic elements. We have the command itself. In this case, we have history that we typed in here, and then that gave us the last 10 commands we have issued on the system. But also, we can also provide options to modify how the command behaves. And even in addition to the switches or the options, we can even add in arguments depending on the type of command. Because some commands may not need arguments, others may need arguments, provide additional information to fine-tune the execution. The most commonly used shell for Linux, as we had mentioned previously, is a bash shell. Some of the features with a bash shell are we are able to recall previous commands using the history command. We are able to automate some of our commands with scripting. We are able to create nicknames for commands that we use most often, and also able to create variables that we can save in some information for future reuse. So let's just do a quick demo and show you again how the desktop look like on Ubuntu and how we can access the terminal. Access that by right-clicking on the desktop and then open terminal. And let's say we want to find out the previous commands I have issued before. I will just type in history and hit enter. And so far, we have 28 commands that I have issued. Let's move on with the command line itself. The command line has a format, and in this case, most commands by default have no options, no arguments. Of course, some commands also may require additional options or switches and or arguments. The syntax you will normally use for command line is the command itself, additional options that are needed, and then also any argument you want to add into the command to fine-tune the execution. As much as Linux is very, very easy to use, it provides you with the tab completion and all those convenience. It will also punish you if you don't use the right case. So if you type in, for instance, you're trying to switch over to the documents folder, which begins with the uppercase D, and you type in with the lowercase d, that is not going to find it. So be very, very careful and then try to stick with the case sensitivity when it comes to Linux. With the command line options, we can use the switches or the options with a command to alter the command's results. Some commands may not have any option at all. Others may have additional options. For a command that accepts an older option, you specify a single letter preceded by a single dash. So in this case, we can just do an ls dash just a, and that will be fine. But many single letter options can also be combined. You want to provide an option for dash a, dash b, and dash c. Instead of providing them individually, you can just use a one dash and then add in the a, b, c as the options. For command that accepts newer GNU options, you specify a full word preceded by two dashes. So in this case, we can use dash dash help. These are based on the type of command that you're using, because some commands may still be using the older and others may be using the newer versions. So we continue with the command line option. As you can see, we are using the list command to list the directory of the etc. And you can see that instead of specifying dash L, dash H, and dash A, we combining all of them just using one dash to list or to provide the full list of the etc directory. So the command line history, as I mentioned to you, is just a matter of just typing the typing in history, and will give you all the list of commands that you have previously issued. History information is stored in your home bash underscore history. So this is tilde. Tilde would always take you back to your home, regardless of wherever you are on a command line. And then the dot bash underscore history is where all of your history configurations are stored. If you want to re-execute a previous command, you can use the exclamation mark and then the number, and then that will reissue the command for you. So if you take a look at this command, we have history, and then we want to reissue the ifconfig. So instead of retyping this entire ifconfig, we can just use exclamation mark and then the number associated with ifconfig, and that will issue that for us. So it serves as a shortcut to reissue a previous command without retyping everything. So these are some additional options that you can use with the history command. Before we get into the other command types, let's do a quick demo about history and play around with some of these options. All right, so the first one was if we were to use the exclamation mark and a string, it would execute the most recent command that begins with that string. So let's use clear because I think we've used that a lot. So if we do that, it is going to issue the most recent clear that we had used. So if we were to use, say, code, for instance, exclamation mark, code, and that is going to issue the Visual Studio application, which we had issued in our previous demo. The next one is if we want to issue this ls number 8, we'll type in exclamation mark 8, and that will issue the ls for us. Let's do ls. All right, it does it. It kicks off the last list command. So you have the convenience of typing commands on a command line, but sometimes it is hard for us to know where the shell is finding the command or which version it is using. So a command that we can use to find the complete path or the full path of a command is called the which command. You type in which and then the name of the command, and it will give us a full path. So you can see as an example, we type in which hostname. The hostname will normally give you the name of the computer. And then if we want to find out the path of which this command is, if we type in which and the hostname, it will give us the information that this can be found within the bin folder, which is a binary. The same thing with the same way with the ls. If we type in ls, it will give us a full path that it can be found here. So when we type in hostname, it goes into this directory or this path and then finds hostname and then execute. The same way with date and the rest of the commands that you want to find out the path. The next command is sometimes we also want to find out or search for one or more directory trees of a file system where a particular file or command is located. So with the find command, if we give no arguments, the find will list all the files in the current directory and all of its subdirectories. So to search for files and directories, name, let's say nc, which stands for netcat from the user directory, this command would help us out to find. So we'll just type in find and then provide the path of the directory where we want the name nc to be found. If we provide nothing, it will just look at the current directory that we're logged in. To search for a directory only, its name called nc from the root directory, we have to provide the type D. And if we want to be case insensitive or ignore any case, we'll provide a dash, we'll provide an I before the name. So we'll just tell the find command, find everything for us that has the name nc in it, regardless of whether it's an uppercase or lowercase. To search for only regular files, name nc from the current directory, we can also specify just the type F to look for files. The find command can go beyond just finding files or directories. We can even execute commands once it finds that particular file, especially if it's an executable file. So one of the advanced features of find command is running a command on a file that matches the search criteria. So let's say we have a file that has a name ending with .blah. We'll just use a find command and say, look for this file. And then once you find it, remove it. So execute this command. rm is the remove. So what would happen is in this example, we created a file here, and then we use a command, find command. First of all, we use it to find it that it does exist, and then using the find dash name, find the file that ends with a dash, that ends with a .blah, and then execute this command, remove. And then this is going to be a placeholder for this file. So every file that ends with a blah will be placed in here, and then this command will be executed to remove it. And then once that is successful, We try to find the file again, and no longer does exist. So the type command is used to determine the information about the various commands. So it would display if a command is an alias, shell command, shell built-in, disk file, or shell reserved word. And the syntax is just type and then options. So we can use the A switch or the A option to reveal the path of another command and a -T to look up multiple commands. So in this case, we want to find out what an echo is. Is echo just a shell function, an alias, shell built-in, disk file, or shell reserved word? And then we provide a -A as an option. And this tells us that the echo is a shell built-in and even gives us the full path of the echo command. If we do the same command, but this time just specify the -T and then provide even more than one command. So in this case, we're using the type command with a -T against the ID command, echo command, and then ls. And it will tell us that they are file, built-in, and alias. So ID is a file, echo is built-in, and ls is an alias. So this is how we can find more information about a particular command or a group of commands. An alias defines nicknames or shortcuts. So sometimes you may find yourself that you are continuously or repeatedly typing longer commands. For instance, maybe you go to work every single Friday, you run an update on your Linux system. And this is something that is both an update and also an upgrade. It's a long command. What you can do is you can create an alias, just one word that will map up to that long command, and then just type that particular alias, and then that will execute all the command for you. So these aliases are placed in the user's bash rc file. You just type alias with no arguments, and that will list all the defined alias on your system. If you want to create a new alias, it's just you first type the command alias, the name of it, and then put the command you want to map to that particular alias name in quotation mark. Note here, there should be no space on either side of the equation, equal sign. So here, once you type in the name of your alias, there should be no space in between here. Otherwise, it would not work. The alias definition needs to be placed within either a single or double quotes if it contains any space. So if you want to remove also an alias, it's just a matter of just using an alias and the name of the alias name. So these are examples of alias when we type it in from our command line. To make an alias permanent, we have to place it within the bash rc. When we create an alias on a command line, it only exists in that particular session. Once you close out the terminal, it no longer does exist. So if you want to make it permanent, you have to place that within your bash rc folder and then reboot or restart a new terminal, and the alias will take effect. Okay. Another concept which you see a lot when it comes to either writing a script or programming is variables. Variables are used to store data that can be used later by the shell. So if there's something that you want to keep, store somewhere and then call it out later on, either on a command line or in a script, you can put that within a variable. We have two types of variables. We have the environmental variable and local variable. The environmental variable are the ones which are preset in a system. They are pre-created as and when you create your new Linux machine. The local variable are the ones that are set by you as a user. So you can create as many variables as you want. Maybe you have something that you want to call out eventually later on within your system or within your script. You can create your own local variable and then call it out later on. The environmental variable can be overridden by the user, but it's not advisable. Most of them are normally in upper cases and they begin with a $sign. So example of the variables which are pre-built into Linux systems are the home, shell, and a path. So similar to the alias, the variables that are created on a command line are just stored temporarily. They are not permanent. So if you want to make a variable permanent in your shell, you have to again update your bash rc file and then make that variable permanent. So if you want to find out the currently set variables on a system, we can use a set, env, or export from the command line, and that will give you the list of all the variables you have in your system. So to set up a local variable, this is how it looks like. We provide the name of the variable and then again the name of the variable. This looks similar to how the alias is, all right? And then to call it out, we provide a $sign and the name of the variable. An example here is we created a new variable called variable1 and we set it up to blah. To call out this particular variable, you don't just type in echo and a variable name. You start it up with a $sign so that you tell a system you are calling out a variable, and then the value set to that particular variable will display. So unlike the local variable, we have to use the command export when it comes to environmental variable to set a new variable. Again, if you look here, the syntax down here is just export, the name of the variable, and the value. An example here is we're using an export and then the variable number 2 and blah, blah. And then this time we're using the command env to list all the variables on a system. And then we're looking for this particular one. Do not worry about the command here called grep. We'll talk about that in our upcoming sessions. But we're saying that display all the content of the variables on a system. I mean the environmental variable, but then look for only the variable 2 using grep. And it showed us that we have variable 2 set to blah, blah. We did mention that when we set variables or even alias on a command line, they are not permanent. The moment you close out the terminal, they are gone. To make them permanent, we have to edit the bash rc of the user and then add these to that particular file. An example here is how to add a variable to the bash file, to the bash rc permanently. So we can use any text editor such as nano, and then add the command line export and the name of the variable and then the value anywhere in the file. Usually it's advisable to add it at the bottom of the file, so it's a lot easier for you to know where your created variables are. Once you're done, you can just type in source and then bash rc to source it out, or you can use the dot and then tilde bash rc, or start a new shell by typing bash, and then that will take effect with your new variable. If you want to remove a variable, it's as simple as using the onset command to do that. To display the content of an environment with an echo command, we can just use the echo and then capitalize that particular variable. And you can see that at the bottom here, we tried to do that with the home variable, but because that was not right, it gave us nothing. But when we type in with the uppercase, it gave us the output for this particular user. So to display the value of an environment variable, we place a $sign before the character and then capitalize the variable's name. Okay, so one more thing that we can do when it comes to variable is modifying our command prompt. You have seen that some of my command prompts here are all modified, and that is part of variable. Most importantly, it's called prompt statement or PS1. That stores the character strings that is displayed at the command line prompt. So in this case, the system at UB with a $sign. The $sign means the command prompt is not, the command prompt that we're working from right now is not a privileged user or not a root user. Each time you log into a Linux system, there are two types of users that you will see according to the terminal that you are logged in with. You will see a $sign or this hashtag sign. The $sign means the account or the terminal is up working with the unprivileged user. If we switch over to a root account, it will turn out to be this. and that tells you that you are working from a root privilege account. The command line prompt can be customized. As I said, we can modify the PS file, and again, we can put that within the bash file and modify that, or we can add it to our bash underscore prime profile, and we'll do a quick demo on how to customize our prompt. So we've done a lot of talking, so let's get into some demonstrations on how to use some of these concepts from a command line. So let's go back to our home directory, and I'll use the ls command, and this will list or display the directory's content. And if we do ls-alh, that is going to display this in a different way. And what this is doing is it's actually giving us human readable format. So the A means display all hidden files. Sometimes there are some hidden files within Linux machine, and those are the ones that begin with a dot. So anything that you see with a dot is a hidden file. So if you can compare from our first command, this is what we had. But when we added the -a, it gave us everything that begins with a dash, with a dot, and those are hidden files. And then the H is giving us human readable form. That means it's going to give us the files in their sizes as well. So if I was to remove the H, we can see that these are just in numbers, but we don't have the -k, all right, which is like kilobytes, right? So that's the difference between the H and then without the H. The H is to give us the human readable form, whether the file is kilobyte or gigabyte with a G. Let's use a which command, and let's say we want to find out something about hostname. All right, so when we execute the hostname command, so in this case, when we do this, and it tells us Ubuntu-desktop, where are we getting this command from? So the terminal or the shell is calling out hostname from this path, user, bin, and then it's calling out hostname. Let's say if we do which ifconfig, or ifconfig is not installed, let's say nc. So nc is netcat, that can be found within the user, bin, and command. Let's do netstat. So which netstat, if we do, let's say which cow, that is not installed neither. If we do date, this should be there, okay? Date is also within the user bin. So we want to find out where these commands are located, or where the shell is pulling them from when we type the command. So if we type in date, date is not installed. All right, so we'll go back later on and then install that. Oh no, sorry, that's data. Okay, so today's date is here. Okay, so that is the which command. If let's say we want to use the find command, so if we do find, we say nc. This will not find it because by default, find command is going to search from this directory, which is if we do pwd, that will list our current directory. And find is not here. nc is not here. But if we want to say use find and then search from the root directory, which again we'll talk about the file system in the course of this class, but just bear with me here. So in this case, we are using the file structure. It's going to go all the way to the top and then begin to look for begin to look for nc for us. And you can see that it's picking up everything that has nc in it, which is not good at all, right? Because it will keep going, because it is going to go through the top of the file structure and then search for every instance of nc. So we'll do Control-C to end this. If we want to find, let's say, nc from, let's say, the user directory, so we'll do find and then user, and then we want to just provide name nc, and then let's see if it finds it. So we found it, right? So at least now we specifying that it should start a search from only this particular directory, and it's still going through that. Even though it found it, it is still going to go through until is over, or it has gone through all the entire, it's going to keep looking. So you can see that it started off with user, it went into share, and then bash completion, and then found another NC over there, right? If we were to change this to, let's say, a directory with a type D, let's say dash type D, and case insensitive, oops, it will not find it because NC is executable, is a file, and it's not a directory. All right, so let's go back and then change this to an F and try again, and that works. Now let's try and use a find command and then execute some command once it finds it. So we'll begin by, first of all, creating a file. So we'll do ls, and we have our test.txt here. All right, we can do ls and even grep it, find everything.txt, and it found one for us. Now we use find and then -n. We know, and we're saying that find every file that ends with a .txt. And then once you find that file, execute this command called remove, but use this as a placeholder. To remove it. So what would happen is find will kick in first. Each time it finds a file that has an extension of .txt, it will place that file in this placeholder and then execute the command remove to remove that file. Okay, so we execute, and now if we do ls, the file is gone. So two things happen here. Find first and then remove. Let's do the type too. Let's use type. And first do echo. Echo is a shell built in. If we use an option -a, and it will give us everything about this file. It will give us even the location. So I think the -a is much more better because it gives us extra information. So shell is a built-in, it's a shell built, echo is a shell built in, and then it will give us a path where this echo file can. If you recall, if we do which echo, it is the same thing here, right? At the bottom here. And let us provide that with just a T, and then let's call out ID, who am I, command. And then so it will tell us that echo is built in, ID is a file, who am I is also a file. Next will be an alias. Let's list out an aliases on this system first of all. So these are the alias we have on this system. So let's say we want to create our own alias where we run an update on Ubuntu. So we can just type in, let me clear the screen, alias, and then we'll call it update. And it is going to have the command sudo like that. So this is how we create an alias. So we can see now we have an alias update, and that is sudo apt update. So now if we call out that alias, prompt for our password because it's a sudo, there you go. It is just going to run an update on the server or the system for us. Now this would have been us typing an entire command of sudo apt update. But in this case, we just type in one command, which is the alias, and it did all of this for us. And that is done. But remember, this is just active in our current session. If we were to close out this command, this terminal, and open up, this alias would not exist. So let me show you. So we open up a new terminal, and then we type in alias, and we can see that our alias is no longer here. Let's make this alias permanent nano, and then tilde, which is going to be our home, and then /.bash rc, like this. And we can go all the way down. Okay, actually, let's go all the way up here because this is where we have all the aliases. And let's add ours here. All right, so then we'll just control. Okay, so now that we're done, we can now source it, or we can just close the terminal and then open it, and that should work for us. So let's go ahead and source this out. So we just do source, the call out tilde bash rc. That will source it out for us. And let's close out a terminal and bring it up. Now we have our alias here. Fantastic. And I also did mention that when the user is logged in as an unprivileged user, the terminal will have a $sign. So that is the reason why when we do anything that requires privileged access, it would prompt us for a password. So let's switch over to a root so you can see the difference. So now you can see that we are now root, and now our command prompt has changed into this hashtag, symbol. All right, so we can just exit out and then get back to the regular user. All right, next, let's use the echo to display our current working directory by calling out an environmental variable. So echo and the $, uppercase PW, and that will tell us that we are within the home user directory. We are now going to also edit our PS1 so we can change our prompt, nano, and then get back into our bash rc folder. And I have created a prompt which I'm going to add in here at the bottom by using the export. So I'm using the export and I'm creating a PS1 variable which is going to change my terminal prompt. Okay, and I had to use a website to get all these numbers. So this is a website that I use to create all this. It's a step-by-step. The first one is you can pick whatever you want, whether a username or whatever. And the second one is it will show up here. And then you can, take a look at how it will look like. You can add some modifications to it. These are all options you can add, and as and when you add in, it will show you how it will look like. You can drag and drop, you can remove some stuff like that. All right, and this is going to add all these things. And then once you're done, you can just copy and then paste them within your bash rc file. Okay, all right, so let me go back and then I'll do Control X and then save it. And then I'm going to source it. All right, and as you can see, now my prompt has changed. So if I was to close out and then bring out my terminal, now I have a different type of prompt. So now we have a nicely looking terminal. And that is because we have updated our PS1 variable. So on a Linux machine, everything is a file. And each file can be located or found somewhere in a directory. When you issue a command, what happens is the command or the shell is going to go through a list of directories looking for that particular command. And then once it finds it, it will execute it. You see that when we use the which command or even the type with a -a, it showed us the path of where those commands are located. Well, what happens is it will go through what we call the path variable. The path variable is where you have all the list of all your directories on your system where each individual command can be found. So when you type in, let's say ID, it will go through a list of all these these directories, and then find out where NC or ID is located, and then execute it. If it doesn't find it, it's going to give you command not found. And each of the directories are separated by the column. So in this case, this particular user, sysadmin, when you issue the path variable, the same way that we did with the PWD, it will give you all these paths. The first one is when you type in ID, for instance, it will go through this home, sysadmin, local, bin, and find out if it has ID command in it, executable. If it doesn't find it, it will now go to the next folder or directory, which is the home, sysadmin, and then bin. If it's not found, it will go to home, sysadmin, local, bin, and then it will go through all of these until it hits the last folder or directory and says, I give up, I didn't find this command, and command not found. So a path variable will now host all of these. Of course, we can modify that. We can create our own command and then create our own folder and then add it to a path variable. Those are normal things that you see some sysadmins or even programmers of in Linux do that. So the bash shell displays a command not found. Error sends a black command is not found in any directories within the path variable in this example. But we can modify and then create our own by adding this to the path. So this is how you add your own path to the path variable by issuing path and then the name of the location where you want your command to be called from. If now we do echo path, we can see that ours has been added. So the next time we issue a command that has a blah in it, it is going to call out from this particular directory. So let's do a quick demo and show how this works. If we do pwd, we are in the user desktop, but let's change into the temp folder. So we'll just use cd change directory /tmp, and then we'll get into the temp folder. Let me maximize this. And I'm going to create a new file called just file. So nano and then file. And I'm going to add in some text. So this file is going to contain this particular string. So we'll do Control X and get out. And if we do cat file, that should display this content for us. Now let's make this file executable. If we do file, permission denied. So let's make it executable. So change mod X, and don't worry about this. We'll go over this in our subsequent sessions. So now it's executable. If I do ls, I should have it here. And now let's add this to our path variable. So this command will add the temp folder to our path variable. Now if we do echo, see, talking about case sensitivity in Linux, right? So now we can see that the temp folder has been added to our path now. So now if I was to execute a file, there you go, it runs. We don't get any errors because we have added it to the file. So sometimes you may want to specify some patterns to match a particular file or a directory or a folder. An easy way to do that is a term called wildcards or globing. So wildcards has special meaning to the shell. You can use a glob characters with any command. Some of the examples or the most common ones are the asterisk, which you have seen me using. Basically, it says match any character or a string of character. So you saw me using the asterisk .txt. What that meant was find everything that has an ending of a .txt. All right, so if you have files that have abc.txt, nice.txt, good.txt, it will find all those files for you. So that is the whole purpose of using the asterisk to find something for you or match a pattern. We can use a question mark to find exactly one character. So if you're looking for, let's say, 3 characters from our search, we have to specify 3 question marks. We'll use this, the square brackets matches characters within the enclosed square. So if we have, let's say, ABC, we'll say, look for all these files that have the characters ABC in them. So this is a perfect example. We have this ADF will match any occurrence of A, D, or F from our search. The exclamation mark is used to negate or as just negative. So in this case, we are using this example and say, find everything that does not match ABC in our characters. So these are examples of wildcard that you can come across or use a lot when it comes to fine-tuning your search. In this case, we're using the ls command, and within the etc folder, we are saying that find all the files that begin with an M. So anything that starts with an M will be found and displayed. So you can see the outcome here. All of them begin with an M. The question mark will count every single occurrence of it and then find that for us. In this case, if you look at an example, we use the echo to display the etc content, but only find all the files that begin with an A and then has 3 characters after that. So this one found only one file for us, begins with an A, and then we have 1, 2, 3. If it has any 4, it would not show up. If it has 2, it would not show. So we'll find exactly files that begins with an A and then has 3 additional characters. In this case, you have we're looking for everything that has just basically 4 characters that begin with an A. The brackets match each single character enclosed within the brackets, within the square brackets. So this will display any file that begins with either an A or a B, if you want to disclose that, but also ends with a .conf within the etc folder. So we're using ls, get into the etc folder, and then find all the files that have either A or B in them, and then ends with the .conf. So that is what is going to work. We can perform a range as well. So we want a range of between N and O. So we'll pick up every file that begins with an O and then also begins with an N and then an O as well, and then in between that. All right, so in this case, it's finding us this file that all these begin with an N, and we have an O here, N here as well. The next one is quoting. The quoting comes in 2 forms. We have the double quotes and the single quotes, and each one of them would have their own different outcomes depending on how you use them. So the double quote is used to disable the shell from interpreting some characters such as the globe character. Sometimes you may have a character that may have a globe in it. To escape that, we need to use that within double quotes so it doesn't interpret that as a globe character. So when a character such as an asterisk is placed within double quotes, the shell would see that as just an asterisk. Otherwise, if you don't put that in a double quote, it is going to see that as a globe and then do something according to that. The same way with a single quote. So the single quote also disables the shell from interpreting all characters such as the globe character. So it will prevent the shell from interpreting special characters, and we call that escaping. So look at this example. Echo, the phone cost is the $sign, but look at the outcome here. It broke it because we did not escape the $sign. So what happens was the shell actually did interpret this as a globe and only produced the the rest of the zeros after the 1. But if we want to escape that, we can put it in a single quote, and then we'll treat this as just a $sign and not a special character. So this will give us the actual output that we're looking for. And then the next one is also back quotes. The back quote is what is also used within the command substitution. You saw us using this previously with the home and the host name environmental variable. If we go back into the back quotes, it's used to execute a command from within another command. So sometimes if we want to, let's say, execute date within our command, so we type date and we see the today's date on it. And then we want to write, let's say, echo, today is this date. But because we did not provide anything to tell it that to execute this as a command itself, it just wrote the date itself as a string. If we want this shell or the echo to execute this command within this command, we have to put this in this back quote or the back tick. So when we hit enter, the shell will type in today is, but then it will see this and then we'll create a substitution and say, you know what, this is supposed to be executed as a command on its own within this command, and then it will give us today's date. So if we want to execute a command within a command, we use the back quote. The next concept which we also have to deal with is when it comes to executing multiple commands on a command line. We have several ways, but these are the 3 most popular way of executing a chain of command, and it creates convenience. Sometimes you want to run an update and then run an upgrade and even distribution upgrade at the same time on one command. All right. So each one of these would help you do that, but each have their own unique capabilities and the outcome they will produce based on how you use them. So we can separate various commands by using a semicolon character. An example here is a command 1, semicolon, command 2, semicolon, and then subsequent ones as well. So this will run multiple commands, one after the other, each separate by a semicolon. Each command runs independently. So even if this is a wrong command, this will still execute regardless of this. If this is still wrong, this will still execute regardless of this one as well. So with no regards to whichever outcome from the previous command, the next one would still execute. Of course, it has its own downside with that. Now, if we use the logical AND or the double ampersand, the second command only executes if the first command does succeed. This is basically a good thing because sometimes you may want a command depends on a previous one. So the previous one doesn't work properly, you want to terminate your command. You don't want to continue with that. And that is where the double ampersand comes in. The logical OR says if the first command runs successfully, the second command is skipped. So it's going to be the first or the second. If the first one works successfully, forget about the second one. If the first doesn't work, then go to the next one. So we use double pipe for that one. So the first command, either this one execute or that or that. So let's get into some demonstrations on how to use these concepts. Let's run a command to display the user currently logged into this computer or this system. So use the who am I command, and it says it is the user, just user logged in. Let's use uname -a to display the system's kernel. So this information tells us the kernel number that we're using or this Ubuntu is running. Let's use a which command to see if we have any command called cal like this, and we don't have any. Let's try that with date. Yeah, we did date. So date does exist. let's use the ls command to display everything within this directory. So we are in the temp folder, and it will display everything for us. And let's go back to the user's home directory by using the tilde. So cd and tilde, and that will take us down here to our home directory. And let's use the ls command again with asterisk to show us everything. Let's change directory into the etc folder. And let's use the ls command again, and that will show us that. Let's try again with the asterisk and see if anything changes. And that orders it in a different way. So let's assume that we want to list every file within the etc folder or directory that ends with the letter T. So we can use ls and then just call out etc. And we are going to use the asterisk and then just T. So this is going to give us every single file that ends with the letter T, or a folder for that matter. So all of these are ending with a T. Let's combine the asterisk with the question mark to display files that has at least 7 characters long and end with the letter S in the etc directory. So let's do ls and etc, and let's use 1, 2, 3, 4, 5, 6, 7, and asterisk, and then S, and let's see if we find any. So we found a lot of those. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then ends with an S. So what is happening here is we are saying minimum find files that have a minimum length of 1, 2, 3, 4, 5, 6, 7 and above. So everything that we find here, the directories or files are going to have a minimum length of 7 characters, and they will end with the letter S. All right, so that's how it is. If we were to increase that, let's make that an 8 and see if we find any. So minimum 8. Let's try that with minimum of 10. Yes, we're still finding. And let's bump it up to minimum of 12. So now we have very little amount of files coming out. So these are the ones that have a minimum of 10 characters and they end with the letter S. So from the home directory, we are going to display the files with the characters that begin with a D. So, and also end with a P. So we can just do echo, use the square brackets, and just uppercase D and uppercase P and this. So what this is going to do is it is going to display our home directory, the files or with the characters between D, the letters D and P. Hit enter, and yep, we only have these, anything between D and P. So M is between D and P, N is between D and P, and then of course P is part of the P as well. Now let's do the same thing, but display files or information in folders or directories that do not have between D and P. So we'll just use an exclamation mark, which is negating, and it'll show us everything that doesn't have a D or P on it. In it. And of course, we're doing this from our etc directory. If let's say we go back to our home directory, let's display files that begin with a D or with a P or anything in between that. And we only have desktop, documents, downloads, music, pictures, and public. If we want to display files that do not contain any one of these letters as a first letter, that will show us snap, templates, and videos. So now let's try to also execute command substitution by calling out the date command. So we'll just do echo today is date, and it will just type that. But if we want to execute date as a command, we'll just use the tick, and now it is going to execute this command and then also execute this as a command within this entire command. So if we do enter, now it's going to tell us today is this date. We can also use bracket and then starting that with a $, and that would also accomplish the same goal. Let's use the ampersand call out multiple commands. So let's say we do ls etc pass wd. That will list out this file for us. If we want to do that and at the same time also do echo success if the file does exist, it will say yes, the file exists because it will give an echo. If we're to do the same thing and then do ls etc and call out blah, this file doesn't exist. So let's add the ampersand and then give a success if it does exist or not. So if we do success, you see that it doesn't show, all right, because it wasn't successful. Let's use the logical OR, which is it will execute the first command or the second command depending on whichever one is successful. So first we'll do ls etc pass wd. This file does exist, so yes, it will succeed. Let's use a double pipe and then echo failed. Because this file does exist, it is not going to kick out the second command. It will still execute the first command. If we were to execute xc fluffy, this file doesn't exist. Let's use the double pipe and then echo failed. Now, because this doesn't exist, it went ahead and then called out the second command. So either execute this or that, and went ahead and then executed the second command because the first one was a failure. Okay, now let's use the column, the semicolon, if we want to run multiple commands. So we can do sudo apt update and then add in our semicolon, and then at the same time do sudo apt upgrade and then provide an S to false a yes prompt. Now what is going to happen is it is still going to execute these commands independent of each other. Even if this one did not succeed, it will still execute this command as well regardless. You hit enter, it is going to prompt for a password. It is going to run the update command, and then once it's done, it's going to go ahead and also run the upgrade command. So finish running the update. It's now doing an upgrade. So let's try out some commands with the quoting character, both the double and a single. So in this case, we're using the echo command to display these glob characters. And let's try the substitution command again, this time using the environmental variable. So echo the host name is, and then we'll call out host name variable, and that would execute it. If we were to do that without the $, and we'll just literally just type it out, because this is just going to treat this as just a regular text. Now let's also try to escape Because we did not escape the $sign or the glob character, the shell is treating that as a glob character. If we were to add, let's say, / to it, this is going to escape this particular character and tell the shell to just run the $sign as a regular text. Or if we were to put these into single quotes, the same thing, we're telling the shell to run this command and then execute a $sign as just a regular character. We move on with the second sub module using the command line to get help. And this module is going to focus on how we can run help commands and also navigate the various help systems on a Linux system. Some of the key areas we'll be looking at would be the man pages and then also the info pages. So we have said this several times. One of the most powerful features about Linux system is the command line environment because it helps us to automate things without needing to use the GUI. And it also does reduce the overhead because it doesn't depend so much on the GUI features. However, there are thousands of command lines, and whether you are a veteran or you are an inexperienced Linux user, one way or the other, you may find yourself that there's a particular command or a file that you may not remember how to execute or use that. And that is why the developers of tools within this Linux community have built in various ways to support users by providing helps to navigate through some of these humongous commands and utilities. The Linux systems, of course, come with so much of these various documentation and utilities that would make the usage of the Unix distribution a lot easier for people who are trying to use this beautiful platform and those who have already been using it but need sometimes a way for a quick reference or help. So some of the ways that we can obtain help within the Linux distributions are the man pages, the info pages, the help command, and even the -- help for any command that supports that option. So we proceed with the man pages, and the man stands for manual. And this was first introduced in the early versions of Unix. It provides documentation of many programs and utilities such as commands, files, kernels, and the likes. And it is available locally on your machine. The syntax in running the man command is just a man and then the command that you want to get more help from or want to obtain manual from. On the right side, you see an example of a man screen for the command date. And you see some of these things. We'll walk through some of these options within the man page for a command that you want to obtain manuals for. Now, an output from a command and from the man command is piped through pager programs such as less or more. And we'll go through some of these commands, less or more, tail, head, all of these in our subsequent slides. And these are viewed page by page. So we can call that as, let's say, pagination. So each of the help goes through page by page by using the space on your keyboard to navigate. Now, the good thing about the man page of a particular command or file is it even gives you more options to navigate. So at the bottom here, you can see that even if we go back to the previous slide, you can see that it gives us an additional information on how to navigate. So at the bottom, it says manual pages date, line 1, press help for help or Q for quit. So even within the man page itself, we can even obtain more help. So on a man page of a program, we can type the letter H, which stands for help, to view additional commands to navigate on a page. So once we click on the H, that will drop us into something like this. And to navigate, we can either hit a space bar in our keyboard and that will move us forward to the next page. or if we want to search for a particular word or string whilst we're in the help phase, page, we can type / and the term that we want to search and then hit enter, and then that would give us the outcome. If we want to move to the next search, we can just type the letter N, the number 1 and uppercase G will jump to the beginning of the man page. Uppercase G will jump to the end of the man page. And then, of course, the letter Q will quit the page. We have two kinds of sections when it comes to the man page. We have the headings and then also the chapters or categorization. And we'll go briefly into this as well on the next few slides. But the first part is what we call the headings. And the headings are these ones here. Basically, the name of the program or the command that you are obtaining the man page on. In this case, you see that we have the name here, and the name is date. And it will just give you a brief statement of that particular command that says print or set the system date and time. And we have the synopsis. The synopsis gives you a brief information about what options to use when you type the command. So in this case, we can see that we have the date here, and then we have options on how to use it and even a format. So that is the synopsis. The description will give you detailed description of that particular command. So for date, it will say display the current date, and all of these are part of the description of the date command. And then comes in the various options that we can apply with this particular command. Remember, I told you we covered some of these things previously on how we can provide options to command to fine-tune its execution and output. And then we have any additional files will be provided within the manual. And then the author of that particular command would also provide their information, either their name, the email address, and other information. In the course of using the command, if you come across any problem, any bug or whatever, we have a way that you can report any bug that you have discovered in that command. And that is also provided in the manual. And then we talked about the various licenses of programs and tools and artwork. So the command would also have the copyright information about that particular command. And if there are any additional information that you need to follow up with that particular command, we'll have that under the C also. So this is similar to you going to buy a product, and a product comes with a manual on how to use it, and it provides you various information on how to contact the author or how to report any problem should you come across any defect on the product. So let's continue with the searching within the man page. Once you have dropped into a man page for a particular tool, to search for an item, you type in the / and then the name of the item, and then press the enter. If you want to view the next item match, so for instance, we type in and then we have several matches for that particular string, you can type in the letter N and we'll go to the next found match. To view the previous match, you use the uppercase N to go back to the previous match. If the search item is not found, or when we reach the end of the matches, then the program will report the pattern not found. Press enter. So if you look at this particular screenshot here, we use the / and then we're searching for the word blah. Of course, this term or word would not exist within the date manual, and we are expecting to see the pattern not found outcome. All right, so we talked about the two types of sections within a man page. We have the headings and then also the chapters or categorization. So any Linux system has thousands of man pages for configuration files, which will be the system files, and then commands as well. So user commands, systems command. Now, sometimes one particular command may have several categorization. It may be just a file, an executable, a system call, whatever. So within Linux distribution, we have 9 different kinds of categorization called chapters. Let's say a command such as passwd. The passwd could be an executable program or a shell command, user command. It could be system calls or functions provided by the kernel. It could be library calls, functions within the program libraries. It could be a special file, usually found within the dev directory. It could be file format or conventions such as etc, passwd, game or screensavers, or just miscellaneous, which would include macro packages and conventions such as man and then bracket 7, or system administration commands or procedures, which are usually run by the root or the admin on the Linux systems, or even just a kernel routine. So one command may have more than one categorization or more than one chapters. And depending on which one you want to use, you have to know which categorization or chapter you are using from that particular command. And we'll see an example, a situation where one command may have more than one chapter. So we'll continue with the categorization. So when a user executes a man command, what would happen is it will set through each of the 9 chapters. So go through all the 9 chapters from the first through the 9th. You can see that on a man page for a file or a command, the chapter number will be enclosed in parentheses. So here from this screenshot, we have the passwd, and this is displaying the first chapter, which if we go back will be executable. So this is going to have it as number 1, saying that it's executable. And that is typically the default for the man page. So as I said, sometimes a given file or command may have multiple chapters. An example is a passwd. But by default, once you type in the man and then the command that you're searching for, the man page will display the first chapter from the hierarchy, which is from the 1 through to 9. And if it finds a first chapter, then we'll display that. If you want to list all the chapters for a particular command, you can add in the -f option with the man page and then a command, and that will produce all, it will give you the list of all the available chapters. The syntax is the man-f and then the name of the file or the command. Now this will do the same thing as the what is. So from the screenshot, we did type in the man-f for the ifconfig, but because this has only one chapter or categorization, it produced only one of them. And you can see that the associated number is in a bracket. So if we go back, number 8 will be system administration commands or procedure, which is usually used by the root. And that is right, because it's only the root user who should be able to configure the network interface. So that is why the ifconfig is categorization number 8, or it uses the chapter number 8. However, when we use the same command, but this time use a passwd, we get more than one chapter or categorization. We have the first one, and then we actually have one with SSL, and then we have the 5th one. So now the first one says change user password. So this is the typical passwd file that most of us are used to if we want to change a user's password. And then we have the compute password hashes. And the next one, which is the 5th one, is a password file. This will typically contain the list of users on a Linux system, and we'll cover that as well in our subsequent slides. So if you go back to the categorization, the 5th one says the file formats or convention. So passwd has more than one categorization. It has 3 of them. One is the change user password. The next one is computing the password hash, and the 3rd one is a password file. So if you don't remember the exact file or keyword or the command you want to search for, well, man page has a very good or nice way to actually make your life a lot easier by using the -k option, which will search through all the descriptions section for the keyword. The syntax is man-k and then the keyword that you want to search for, and that will produce the same output as a propose. In the previous slide, we did mention that when we type in a man for a command, what would happen is you go through a hierarchy of the chapter numbers 1 through 9, and I will pick up the first one. An example was the passwd. Because it has more than one chapters, the first one it came across was the number 1, and by default, the man page will produce that. However, maybe you don't need the pass WD with a character number 1, but want a different number or a different chapter. You can force that with the man command. It's as simple as using the executing the man and then the associated number for that particular chapter, and then force the man page to produce you the manual for that particular character, for that particular chapter. So in this case, we know that we have more than one chapters for the man page. We have chapter 1 with SSL, and then chapter 5. But let's assume that we don't want the manual for the chapter 1, but we want that for the chapter 5. So in that case, we can force the manual page to display the 5th one than the first one. So we just type in man, number 5, and then pass WD. And that would give us, it will skip over the chapters 1 and SSL, and then produce us the information for the chapter 5. So this will give us information, again, the name, the description, the options, and others, stating that the pass WD is the password file. All right, so let's get into demo time with the man page from the concept we have covered so far. So from the command line terminal, let's bring up the man page for the man itself. So we'll type in man, and then hit enter. And this will display the manual for the man page. So let's recap again and then look at what we have gone through from the slides. So we're looking at the first category or the first chapter for this man command. The name is man, and just one sentence describing what this command is, which is an interface to the system references manuals. And you can take a look that from within under the synopsis, it shows us several other options that we can run with the man command, and even some of the alternative commands that we can run with. So a prepos is another command that can be used if we do not want to use the man dash lowercase k, or if we want to use what is, it's equivalent to the man dash f. But we see that we have additional options that we can use when we're using the man command, and that is under the synopsis. The description gives us detailed description of that command as well. And then we get into the various chapters we covered. This is what we went through in a slide, which is the various chapters or categorizations that a particular command or file may have. We briefly touched on some of these well-known ones or the conventional ones. This actually has more than what we went through. So the name, the synopsis, configuration, you see we have the bug here, and even examples on how you can use this command for performing manual searches, and even the authors, and also see the also. So I would say take your time to go through the man page for the man command itself, and even look at some of the examples here for you to kickstart. So if we want to display the manual page for the command ls, it's just as simple as man and then the ls command. And we talked about forcing the man page to use a particular chapter. So we have 2 options, or even more than that. We have actually 3 options. We have the man command, the name of the particular command that we're looking, and then dot the chapter number. This is an alternative spelling of the man number and then the command itself, which is the man. The same way that we can also do the man and then in brackets, open and close for that particular chapter number. So these are examples of how you can use the man. Okay, so we can scroll all the way through and you can see that we are on line 247. So that is allowed to go through. So with this overview, let's go ahead and try some of the ways that you can navigate on this manual page. And one of them is searching for something. And if we need more help, we can just type the letter H as it says at the bottom here. So I am going to press the H key, and this will drop me into, it will bring me here to the summary of the less commands. And if I want to search for anything, I'm going to use the / symbol like that. And then let's say I want to search for help within this manual. So I'll just type in HELP and then hit enter. And then it will get me to the first item it discovered, within this, manual. If I say, okay, I want to go forward and then look for additional, occurrence of this search string, I will just type in the lowercase n and will take me to the next found, help item. And then I will just type in another n to go to the next, and to go to the next. And as you can see, because we have hit the end of the search, we are now seeing the pattern not found, and we can hit enter. Okay, and then Q or more to keep moving forward. So let's say we have hit the end, but we want to jump to the first page of this help. We can just type in number 1 and then uppercase G, and it will take us back to the first page. All right. So if we want to go back to the bottom or the last page, we'll just type in uppercase G, and that will take us to the end. So you can see that we're now at the end here. Let's say I want to search for a word or a string which doesn't exist. We'll just type in fluffy like that, and then hit enter, and we should have immediately pattern not found. So let's hit enter, and then we can type in Q to get out of the help page. And then if we want to quit this manual entirely, we'll just type in Q to quit. So this is the brief highlight on how we can read a manual for a particular command or a file. Let's say we want to use some additional options with this command man. So we'll type in, let's say, man, and then provide the -F and then the man itself, so we can see the various or the available chapters that this man command has. And we can see that we have 2 of them. We have the man 7, and then we have the 1. So as I said, by default, it would always drop us into the number 1, because if we do man again, we'll see that it will pick up from the hierarchy. Because the first chapter does exist, it will just pick up the first chapter. But let's say we are not interested in the first chapter, but we are interested in the 7th one, which is the macros to format a page. So to force that, we can just type in man number 7 and then man itself, and we can see that it will drop us into the 7, and that will have a different structure and description for us to use. So let's do the same thing, but let's try out, let's say, a command called nestat. So we'll type in man and then say -F and then nestat like that. And this only has 1 chapter, which is the chapter number 8. And I think that is for administration. And again, nestat is a command that we can use to display network connections from a computer, local to remote, and vice versa. But sometimes to run some of the switches or the options, we may need an admin level to do those things. So that is why this one has the chapter number 8. So we can type in man for nestat, so we can read more on nestat. So the name is print network connection, as I was saying, and even more routing tables, interface statistics, masquerade connections, and multicast membership. And we have a lot of synopsis. So I think by now you should understand that each command would have its own amount of information, because even this has synopsis, and that is even a lot compared to what we found from the man command. But on top of that, it has the note as well before the description. So each command would have its own manual structure, just similar to any product you buy that would have or come with its own particular type of manual. So let's proceed with the info command. And this is also similar to the man command, but it's a GNU project standard documentation format. The syntax is the same as how man looks like. You just type in the info and then the topic name that we're looking for. But there are some few characteristics of the info command which sets it apart from how the man operates. And one of them is topics are connected using what we call a hyperlink or just links. And it also provides information in a more logical organizational structure than how man works. And you have to remember, because man was it was first introduced in the older Unix. So anything that follows or any tool that comes after that is going to look much more polished than previous tools. So that is why the info may have much more appealing to more users, because it was designed more recent than how the man command is. Now, this will display the man pages as a fallback if info documentation doesn't exist for a particular file or command. So let's say we type in info for a command, but it doesn't have an information or documentation for that particular command, then the Linux system will fall back on using the man page to display the information or the manual. The info command output can be viewed through either a command line interface, a graphical help utility, in a printed or even in online format. You just type in the info command with no arguments, and that will display all the available topics you can use to get information about a particular command or a particular topic. One of the good things about the info command is you can browse through the topic just using the regular key movement on your keyboard, using the right arrow, the left arrow, the page up, and then also the page down. The info documentation is structured into different levels, and the node in the info command is a topic you view in the info page. So as you are going through an info for a particular command or a topic, you see that you come across some asterisk for a particular underlined topic or string. Those are actually browsable. So that means in this particular screenshot, if let's say the also C option, which is the note common, if we were to click on this is going to actually open up a browser so we can do further reading on this particular topic or command that we're using the info command for, which I think is very, very nice compared to the man page. It gives you an option to do even online browsing as well to get further information. So similar to the manual command or the man command, whilst you are within the man and the info command for a particular topic or file or command, you can type the uppercase H to get help on the list of movement commands. Remember, with the man command, we had to use the lowercase to get into help. But for the info, we had to use the uppercase. These are some of the nuances that you come across a lot when using Linux, because each tool have its own way of using. One option might be useful for another tool or command. Others, it may not be. It may have a different way of using it. So an info pages provide what we call the free-form documentation output for easy readability. And another command that is also similar to the info command is the pinfo, which is much more colorful and easier to use version of the info command. So you can see that this is how a pinfo would typically look like. And we have some things which are much more in a color form for easy readability and appealing to most users. So sometimes there are some commands that come with just a quick description about what options to use, and that is where the help option comes in. So various commands and tools within Linux come with that default. Some of them, once you type in the command and provide no option or argument, it will give you or will drop you into the help to give you all the options that you can use with a particular command. Or sometimes you can just type the command and a dash dash help, or the dash H to give you the short description about that particular command. So in this example, we have the info space dash dash help, and that is giving us how to use the info command with the options and other menu items. And these are the available options that you can use with the info command. From within your Ubuntu or Debian system, you can type in the normie-help, and that will produce the online documentation of help on how to use, let's say, the Ubuntu desktop. So all Linux desktop systems have a graphical help applications which usually contain the custom help for the desktop itself and some of its applications. So in this case, by default, it will pull up for Ubuntu. If you are on a different Debian system, it will pull up the help for that particular system. Now, this graphical help can be accessed from the menu or from the terminal or a command prompt. And we'll continue with other sources. So within even the system itself, what we call the package documentation, most Linux systems software have their associated documentation that may be found under the user doc or the user share doc directory, depending on the type of distribution. Now, these directories may also have subdirectories, which may also have the README files and other additional documentation. So an example, on this Ubuntu system, we're able to navigate into the user share doc and then list all the available help for some of these commands. So Anacron, all these are the help files that you can find for the associated commands. So we have the add user, and then once you get into that subdirectory, you have all the associated documentation on how to use a command add user. And also, if you want to proceed on online resources, there are countless resources on the internet that provide help resources for Linux system. Each of the distribution also have their own online documentation. This is just example of some of them. So we have the Ubuntu documentation. I have a link for all these: CentOS, OpenSource, Gentoo, and Fedora. And on the right side, we have CentOS page on how to get help online. So additional help, which we have covered, or some of them, or we've come across some of them on the man manual. One of them is whereis. So the whereis command looks for commands and man pages in a broader range of system directories, as well as its sources and documentation if available. So from this command, we're using the whereis against the ps command, which shows the processes running on a system, and is giving us the path location where we can find all the help for this particular command. So we have the user bin ps, user share man 1p, and then that, and then this as well. So these are all the locations that we can find information about the ps command. And the what is, again, referring back to the man page, is equivalent to the man-f. It will tell us which command section a man page is stored in. So when we use the what is ps, it's equivalent to using man-f ps, because it will tell us what chapters or categorization we have for this particular command. So in this case, we have two of them. They are all chapter 1, but variations. The first one is report process status, and then the one itself is report a snapshot of the current process. One additional command which I find very useful on a Linux machine is the locate command, and this can be used to find files or directories on a system. So this searches for files and directories from a system database files and directories. One thing though is, before or for you to get the best outcome from the locate command, you need to update the database, because the locate is using the database within the system itself locally. But to pull up the most up-to-date information and location of files, you can run the update db to update the database of information. So you can use that. It comes with a couple of options. One of them is a -B option, which will search for a base search. So in this case, we're looking for the pass WD. We can use a locate space -B and then the keyword that we're looking for. Or we can place the / character in front of our search term to limit the output further. So sometimes when we type in just a pass WD, it may give you information or some things that we may not be interested in. If we want to limit the output, we can use the / character to limit the output or the outcome. We can use a -C option to provide a count of the number of matches the file found. So just locate -C and a pass WD will give us the how many output we got. If we look on the right side, we can see example on how we're using the locate -B and a pass WD compared to using that without the /. Okay, so you can see that this is limiting the output to the pass WD, but when we use the -B without that option, it's giving us everything. So everything that contains pass WD is being produced. So even this, which is pass WD qc-conf is coming out, which may not be useful to you. You only want the string that has the pass WD only, and that is where the the / pass WD becomes much more useful. So you just weed out all the noise. So it's time for a demo, and we are going to do extra help searches. So we'll start by issuing the command cal, which is the calendar on a Linux system, and that will produce us the calendar. So we are in December 2022. But what if we want to know more options or get help in using that command? So we can type in the cal and then --help like that and hit enter. And that will produce additional option on how to use it. Use a command cal. So we have the usage, cal, and the general options that we can use with cal. So for instance, we can even use any cal as well. And the general options are in this format. So for instance, if we are interested in finding out, let's say, the month of February in 2010 using the cal command, we can just type in cal and then -m. As you can see, we provide the option M and then the month. So we type in Feb, for instance, and then the year. Let's go for 2010 calendar. And by using the help menu, that was successful. It gave us a way for us to display just the month of February in 2010. So that is how we can use the help command or the help option for a particular command. Next, let's list the directory content for the dock on this Ubuntu system. So if we use the ls command and then get into user, share, and dock, we can find the list of all the files, and each may have their own associated help to use such a file or command. So for instance, if we were to say get into that directory, and let's list and then grep for add user. Okay, so that exists, so we can change directory into add user. And we can even see that now we can find out the copyright for this particular command, which is an additional help feature that you may be interested in. So if we were to do less and then copyright, so we can see the copyright statement for this particular command. Let's attempt to use the locate command to find the command ifconfig. So ifconfig like that. And this will provide us with all the information about ifconfig. Let's attempt to also update our locate database. So it's sudo update db. Once that is complete, let's bring back our command. And this time, let's fine tune. Let's hit enter again. And let's use other options with locate. So the -B, and that is almost the same. Whew, yeah, that's a lot. And then let's use the -C and count. So that's 179. Next, let's use the whereas command against the ping utility. And that will give us these as the locations where this command and additional information can be found. And I think we also found this as well. So let's use the apropos. And that gave us a lot, similar to how the man command works. So it gave us the associated chapter for each of these commands that has the ping utility in them. From some of our demonstrations, we have already been using the Linux file and directories. However, with this third sub-module using directories and listing files, we are going to look much more detail into how we can navigate the home and system directories and also listing files in various locations within your Linux system. Some of the key areas we're going to touch on are going to be the file system, files and directories, hidden files and directories, home directories, and also the absolute and relative path within a Linux distribution or system. So you as a Linux user, when it comes to file manipulation and how to navigate around the structure, that is going to be a skills that you are going to need as a necessary tool to have with you. Because depending on the type of Linux distribution, files can be managed in several ways, either through the user graphical interface or from the command line. Now, while the command line may be a bit intimidating to most of the first-time Linux users, it contains lots of features to manage files. As you can see on the right side, we're using the ls command to list a directory which we'll be able to manipulate. There is one key concept that you will hear from a lot of Linux enthusiasts, and that is everything on Linux is a file. And this is how a typical file structure looks like in a Linux system. Now, files can either be a user file, which are created by you as a user, as and when you're using your Linux system, or some files come pre-installed on your Linux system. So we have either a user or system files. Files are categorized or organized in what we call the tree form, also known as the file system. So at the top of the file system is the root directory, and that is depicted with the / symbol. And this is equivalent to the My Computer on a Windows OS, for those of us who are much more familiar with the Windows operating system. Now, there's one thing that confusion that you should get out of the way is the root directory is not the same as a root user. So we have the directory as the root itself, and then we also have a user, the highest privileged user on a Linux machine, called the root. Root is equivalent to an admin on your Windows machine or system on a Windows machine. The file system hierarchy standard was created to define the recommended ways to organize the directory structure and also directory contents on a Linux distribution. So we wanted to have one uniform way of having directories or the file structure organized in a Linux system, and this is guided by the FHS. So to view the directory, the root directory or the high level of a system, we use the ls and then just a /, and that will give us the directory listing from the root or the top. So in this image, we can see that we are typing the ls / and these are all the various subdirectories within the Linux distribution or from the Linux root directory. And this is equivalent to, if you go back to this image right here, they may not be the same, but some of the essentials are the same. So for instance, the bin, etc, home, opt, temp, the user, and then var are the regular or the typical files you find from the root directory. And you can see that some of them are here: bin, etc, lib for library, the boot, where the boot information are located, the home for all the users on the homes on the Linux system, and then also the opt. So these are the typical ones that you find on the Linux machine per the file system hierarchy standard. Now let's get into Linux partition. So partitions helps in organizing contents on a hard disk. It's essentially a way of dividing a system based on the needs, or dividing hard disk. So there could be more than one partition on a hard disk. Dividing hard disk into partition helps in grouping and also separating data on a disk. Now, sometimes you may have heard about dual booting. Sometimes you may have one system. Before the advent of virtualization or VMs, we would have to sometimes boot or have more than one OS on one system. So for some of us back in maybe 15 years ago, sometimes you may have, let's say, separate boot for Windows machine and also Linux. So you divide your hard disk into separate partition and then have different OSs installed on each of the partitions. So you can boot your Windows and then it will house its own data. And then also you can switch over and then boot from a Linux machine or Linux OS, which will have its own data. That creates security and also robustness. So each file system on a Linux system occupies a partition. So if you take a look at this particular image right here, which we are using the gparted, which can be used to display a partition on your Linux system, we can see that we have all these various partitions down here. And the labels actually do tell you which how these partitions are being used, and also their sizes, and how much has been used, and how much are still free to be used, and their mounting point, and also the file type or the file system. And we'll talk briefly about what a mount is. But essentially, the labels do indicate that we have these several partitions. One of them is running the Windows 8.1. This is just, back others. This is Zorin OS, X Ubuntu, Ubuntu. Some of them are saving just your movies, study materials, and also software. So partition is a way for you to divide your hard disk based on some based on grouping and also separating some stuff from others. Let's continue the partition. So we have two major partition types. We have the data partition and also swap partition. The data one is Linux, is just a normal Linux system data, which includes the root partition, and that contains all the data to start your system and also run it. Once that is going on, we have the second partition, which is the swap partition. That one is just an extension of your computer's physical memory, just providing extra memory on your hard disk. Now, aside from these two partition types, we have various other types of partition that are supported within your Linux system. And some of them are JFS, NFS, FAT, XX. That means we have FAT 16 and then FAT 32, EXT4, Squash FS, and the rest of them. Again, this will also depend on the type of OS, whether it's Windows, is Linux system, or Mac OS X. The tool or utility available on most Linux machine that can be used to set your partition is fdisk. So you can see from this image that we're using the -help again, talking about getting help from commands. When we type in the fdisk -help, it will give us all the options that we can use on the Linux machine to manage a partition. So we mentioned mounting point. So all partitions are attached to a system through what we call a mount point. Hence, to be able to start using a system, a file system partition, you need to have a mounting point. A mounting point is just basically a directory. It can have something in it already, or it can be empty, where the file system can be attached to. Now, if the directory does not exist, you need to create one before you can mount a file system to that. We can use a command such as df, disk4, or disk3 command to show information about partitions and their mounting point. We can just type in the df-h, will give us information about the various file system, the size, use available, usage percentage, and the mounting point. This is equivalent to the gparted we just saw here, but this is from a command line, which is giving us where these files are being mounted at. So if we take a look at all these file systems, this udev is mounted at a dev, mounting point. And let's say this particular one, the SDA, which is the main disk, actually where the OS is installed, has 20 gig of space. We've used almost 7 gig. We have 12 gig available, and it's mounted to the root. Again, talking about the main disk, right? So this is where the actual disk or the system is running from, or where the OS is running from. So we continue with the mount point. The mount command is used to attach a file system or partition locally or over the network to a system. So to mount a particular file system to a partition, the syntax is sudo mount command and then the device node or the disk label or the UUID and then the mount point. So if you go back to the df command, we essentially have this particular file system or udev, and then we are pointing it to this particular mounting point. And that is what this command is about, is where we want to mount this particular device, node, or file system to. An example is we want to mount the dev SDB1 at, let's say, MNT as a mounting point. So this would attach this particular node to this particular directory. All right. So the dev SDB1 is a device node. MNT is the mounting point. In the image below, I had attached a USB to the virtual machine, and to list the attached virtual machine, I had to use the attached USB. Using the command ls USB will display that particular device. And of course, we can use the ls dev and then SD, and it will give us a mounting point of this particular node. If we want to unmount a file or a node, we can use the umount command to unmount a file system partition. And the syntax is similar to the previous one, but just the mounting point. So in this case, sudo umount and then a mounting point, and that will free up that particular mounting point. An example is the sudo umount, and we are freeing up this particular mounting point. So the mounting point is this entire path. So the mount and umount commands need to be run with administrative privilege. And that is why you see these commands, all of them using the sudo command. The file system etc fstab or fstab, which is a file system table, defines what partitions are mounted automatically during the system startup. So if we take a look again back to our screenshot, we can see that we're using the mount command. We're mounting this particular node to the M and T. And because we didn't have that existing, we didn't have the M and T, no such file or directory, we had to first create this before we can mount this particular node to the mount point. And once that is done, we are now able to list it, and it will show us that we have this node pointing to the home sysadmin M and T. And we can unmount it by using the umount and then home sysadmin M and T. So the next is the files and directories within Linux. Now, files are what we call the flat files. They contain normal data such as text files, executables, or programs, input or output from a program, graphics, all of that. So that is what we describe as just the flat files. Directories, on the other hand, are folders. These contain a list of other files or directories, providing a hierarchical order structure. Now, special files are the mechanisms used for input and output. Most of them are found within the dev directory. Now, unlike your Windows OS where we have, drive, within Linux, you will not find C drive or D drive or A drive. In Linux, everything is within a directory. So the next topic is directory path. So a path within the context of a Linux file system provides a file's location on a system. Now, there are two ways that we can identify this path. We have the absolute path and then the relative path. Now, the absolute path is just a complete path to a directory or a file, which starts from the root directory. The first character, which is the / character, represent the root directory, whilst each other / represent a character used to separate the directory's name. So this is an example. We are just changing directory into the user bin. So we provide the entire or the full path of where we are getting into. Relative, on the other hand, is provided from the current directory. So the same command or the same objective is for us to change from our current directory into the bin directory. For relative, we use the // and then the user and then the bin. So again, absolute provides a full path, whilst relative provides a path from our current directory. And we'll see some practical examples in our upcoming demos. So we go back again to the Linux file systems and talking about the user's current directory. It's usually your current terminal within which you are working from. And if you want to find out where you're located on a terminal, you want to find out your working directory, you can always use a command pwd, which will display your current directory from which you're working from. And if you remember, I made mention of the fact that wherever you find yourself on a Linux terminal, if you want to go back to your user's directory from anywhere, you can always use a tilde, and that will take you back to the user's original home directory. So the tilde character from a terminal prompt indicates the user's home directory. CD, which is a change directory command, is used to move from one directory to another, and a CD command with no arguments or with a tilde character will take you right to your home directory. So you can see from this screenshot that we are within a directory, but we're trying to use the absolute path to navigate to the netcf directory. So we use a CD, user, share, and then get into this directory. But we want to display and confirm that we are within that particular directory. So we can use a command pwd, and that would confirm that we are in the user, share, netcf directory. So we find ourselves in this directory, but we want to move back to our own home. And instead of using, let's say, an absolute path or relative path to move into a directory, we can just type in the cd tilde, and that will take us right into our home directory. In this case, this is a user we are logging with, the sysadmin, and this took us right back into this user's home directory. So talking about some of the essential directories within the hierarchy that you find on most Linux systems, these are the typical ones. Of course, you find additional ones based on a specific distribution, but the regular file structure or directories you find on Linux machine are these ones. So you know this already. This is the root directory that contains all the other directories. The / home is a directory for each user on the system. So if you have, let's say, sysadmin, you have / home. /sysadmin. Let's say you have a user called Fluffy. You have /home/Fluffy. So each user would have their own private home directory within this directory. The etc contains most important configuration files on a system, such as the passwd. So Linux runs and operates with a lot or a bunch of configuration files, and those can be found within the etc directory. Also, when you are issuing commands, or applications such as ls, cat, move, copy, those or id, most of them are coming from either the bin, which is the binary file, directory, or the sbin. So remember that we use the whereas or some other command to locate the path of some commands. Well, you saw that most of them were pointing to the user bin. So that is where most of these files are, most of these programs are located. The var/var contains files that do change often or are variable. So files such as logs can be found within the var folder, because those are files that do change, or they do make modifications to those files periodically, or they do vary periodically. The temp folder contains files that are destroyed after system reboot. So any file that you don't need to persist on a system after reboot can be placed within the temp folder. And the boot folder contains the startup files and a kernel needed to boot your system. And then the dev contains the device nodes, hardware, and the software devices, such as the hard disk. So again, these are the typical folders that you come across on the normal Linux systems. But don't quote me on that, because there are some systems that would have extra compared to other systems based on the distribution being created. So it's demo time, and let's look at the Linux file system. All right, so let's start off by looking at my current directory, and it looks like I am in my home directory, which is the user. Let's start off by going to the root of this Ubuntu, and we'll just do cd and a /, and that will take us to the root directory. Now, if we do pwd, that should tell us that we are right at the top of the file system. Let's go back again to our home directory by tilde, and then pwd. Again, we are now back to our home directory. If we do list our directory by using ls, and these are the other subdirectories we have within our home. If I do ls-l for long, and then show me hidden files, and then human readable, this will give us this output, showing us some files which are hidden, and also displaying the size of the file in a human readable form. We can also go back to root, but this time, instead of using tilde to go back to our home, let's use cd and then home and tab complete, and that will take us back to our home as well. So now we're in the home directory, and if we do ls, we have the user as the only user on the system, and now we can get into that user's directory. Now let's get into the etc directory, and you see that sometimes when I type, some of these will autocomplete, and it's because I'm using the tab key or the tab key on my keyboard to autocomplete for you. So I'm in the etc directory. If I do pwd, I am in the etc directory. Now we can use let me clear the screen. If I do ls within the etc, we'll see all these configuration files right here. And all these are flat files. If I wanted to say display the content of the passwd, first let me list it and show you where that is. The pass.wd is a file that contains the list of all users on a Linux system. So this is a file here. And the ones in the blue are also additional subfolders. So let's display the pass.wd. I'll use a cat command, which will be calling out from either bin or sbin. So if I do pass.wd, that will display all the users on the system. And my user is here as well. Now, displaying the content of the pass.wd doesn't require any privileges. Any unprivileged user can display that. However, if we want to display the shadow file, which contains the password hashes of all the users on a Linux system, that of course will require a privileged user. So if I do cat and then type in shadow to display, I'm going to have a permission denied. But if I add in sudo, which will run with the higher privileged user, that would display the content of the shadow. And these are the password hashes for users on the system. And for now, because mine is the only active user, mine is the only one that has hashes, password hash. So let's go again back to the root and let's do ls so you can see the root. So as I said, these are the regular ones. We have the bin, we have the etc, we have the lib library for both 32-bit and then 64-bit. We have the mnt point. We have the temp folder. We have var, boot dev home, opt, and then root itself, and then system, and then user. So let's get into the bin folder, cd bin, and then do ls. And these are all the binaries that when we execute a command, they are found here. So we just use cat, right? So let's go and then look for cat. And we can see that cat is up here. All right, so this is where we'll find the commands. Most of our commands that we issue come from this location. Let me go back and let's see if we have sbin. So this is sbin. And that will have system binaries. You can see that this actually has a bit of a limited number of commands here. So we don't even have cat here. So sometimes the bin directory also includes ordinary user binaries, such as the user bin, and then also user local bin, back to the root. And then we get into user. Now we still find additional bin here as well, and sbin. So that was what I was making reference to. So let's type in again tilde and go back to our home. The next directory we want to look into will be the var directory. And you can see that I'm applying the absolute path here. So if I do pwd, I am in a var. So ls will list the subdirectories within the var directory. For instance, if we want to find out where all the logs files are located, we can get into log. And these are all the additional logs on the system. So let's say authentication logs. We want to find out information about successful and failed authentication on the system. Those can be found within the auth.log. So if I use the cat and display the content of the log file, it will show us every instance of the activities we've been doing here on the system. Go back to the root. Let's get into the temp folder. And this is how the temp folder looks like. These do not persist after system reboot. These are reshuffled. And each time we create a file here and then reboot our system, the file will not persist. Next, let's get into the dev directory. So that is right here. So cd dev. This will contain the device nodes, such as the hardware and the software devices on the system. Normally would contain entries which are created by the udev system, which creates and manages device nodes on a Linux system. They would contain the items such as the SDA1, which is the first partition on the first hard disk on the Linux system. So if I was to do ls, we'll see all these. And the one that we'll be interested in will be the SDA1, this one right here. And this would be the first partition on this system. So if I was to do df-h, oh, actually, ours is on here, the SDA3. So this one is mounted on our root. This is our third partition on our first disk. So the next place you want to get into will be the boot. So if I do ls, we have the boot folder or directory. So let's change into boot. And as I mentioned, the boot directory contains the files needed to boot the system. So there are some essential information that you need to understand when it comes to this directory, the boot directory. And that is about the kernel that we talked about. So the kernel installed on a system have 4 files. It has the VM Linux, which we have one here, and we have another here, and these ones as well. Okay. Now that is a compressed Linux kernel, which is required for booting. The next one is init rampfs or init rd. And these are the init rd files. Now this is the initial RAM file system required for booting as well. The third file that the kernel installs on the system is the config. And the config is the kernel configuration file, which is only used for debugging and bookkeeping. The fourth file is system.map. The system.map is a kernel symbol table only used for debugging. Now, there is one particular or unique identification you can see among these 4 files. And that is each of these 4 files has a kernel version appended to its name to show the kernel number. So if you take init rd image, this has the kernel number of 5.15.0-43 and then -46. The same for the VM Linux, same for config, and same for system.map. And that is why, if you recall from the beginning when I talked about the booting process, this is where sometimes a user has an option to select which version of kernel you want to boot your system from. Let's continue with Linux files. Different types of Linux files do exist based on the distributions, but the typical ones are the regular or plain text file, a directory, an executable that can be run as a program, and also a symbolic link that points a file to another file. Now, the ls command, which we have used a lot in some of our demonstrations, is a command which is used to list files or contents of a directory. The ls command just lists the content of the current directory if no options are provided. So if you just type in ls, it will just list the current directory if you don't give any path to it. By default, the ls command may display files and directories using different color schemes, as you have seen that when we use other directories such as the etc or even home, we see some of them in either blue or green or white. Now that is because it's using the alias of color is equal to auto. So automatically, when we use the ls command, it's calling out this complete alias. Remember, we did that previously, right? But if you want to display your output without any colorization, you can always place the backslash before the ls command to display without any colors. So listing hidden files, and I think I briefly touched on that. So by default, the ls command doesn't list any hidden files. Hidden files or directories in a Linux machine begins with a dot. Now, there are several reasons why we have some hidden files on Linux systems. Some of them are sensitive, so we don't want every user to see such files. One of them is your bash rc, which controls some of your features within your Linux. There are also other malicious intent when it comes to hidden files, especially when it comes to attackers or hackers. They would want to maybe hide their code or files within a compromised system, and they may use the hidden feature to hide it. So in Linux, if you want to display all files, including hidden files, you provide the ls with an option A, and that will display all hidden files. If you want to view additional options that come with the ls command, just type the ls space -- help, and that will give us or give you additional options you can use with the ls command. But for now, looking from this this screenshot, we're using the -a, and that is displaying all hidden files. So the dot is a hidden file. All these with a dot are all hidden files on the system. Now, so we continue with the hidden files. So listing the hidden files by default, ls doesn't display that. Now, hidden file would have the character of a dot before it, and we can use the help to get more information. So on the right side, we can see us using the -- help with ls to get more information on what options that we can use with the ls command. And we can see that the -a or -- or do not ignore entries starting with a dot. And then these are all additional options you can place or play around with when you run the ls command. To display or to provide a long display listing, you have seen me using that as well. So to display additional data about a file or directory, such as the owner, the size, the timestamp, or the human readable format, we can use the ls command with the option of a -l to display what we call the metadata about a file. Now, each file contains this information as its metadata. File type, whether it's a directory, it's a link, or it's just a regular file. So these are type of files that we'll see when we use the -l option. Permission of the file, the hard link count on the file, the user type, the group type, the file size, and also the timestamp and the file name. So when we use the ls and then provide the option of L, it gives us all this information about a particular file. So the ls command displays the size of a file in bytes by default. Remember that I told you about human readable format. If we want to see a file in a much more human form, such as whether it's in kilobyte or it's in megabytes or in gigabyte, we can use the -h. Using the ls without the h gave us this file, which is hard for us to understand. But as humans, once you provide the -h, it gave us, rounded up the file, and then gave it to us in kilobyte. So this is 758 kilobyte size of a file for the open SSL file. Also listing directories. So we can use the ls with the option ld to list just directories. And of course, a single period at the end of the second long list indicates that the current directory is being listed and not the content. So in this case, we are listing the current directory and not its content by using the ls-ld. To recursively list a file, we'll use the uppercase -r. So sometimes you want to walk through subdirectories and then get details of each file in the subdirectories. So you can provide a -r to give us the list of each directory and then the subdirectories and all their files. One caution though is to limit the use of recursive listing to only smaller subdirectories. Otherwise, if you run, let's say -r on Etsy or any folder that has a huge amount of files and directories, that is going to give you a whole bunch. So if you list, let's say, from a root directory, that is going to have you waiting for a very long time for that to finish, because the root has every single subdirectory on a Linux system, and you don't want to do recursive, list on that. We can also sort out our list. So the ls command lists files alphabetically by name, but we can sort out file by using the option -S. So an example, look at this command. We're using the ls -l S HT, and we're asking for a full time. So we're listing this entire directory, but we want more information. Especially, we want it in a human readable form, and also the last date it was modified in a full time length. So everything here is going to list all the files and then the last date they were modified. There is another way for us to also sometimes compare files, and there's a reason for that. Sometimes you may have an original file and a backup file, and you may want to find out what has changed from the backup and the original. And one way to do that is using the diff command, which can be used to compare two text files. So the syntax is diff, the options that you want to apply, the first file and the second file. We can use diff3 command to compare 3 files at once. The same format, but just 3 files. So diff3, file 1, file 2, and file 3. We can also use the cmp command to compare 2 binary files. So these are comparing flat files, but if you want to compare binaries, we can use the cmp. In the screenshot here, we're using that to compare the rmt and then just the blah command. So let's proceed with another topic or key concept that you find useful as you are using Linux system, and that is creating, moving, and depleting files. So with this 4th sub-module, we are going to learn how to create, move, delete files and directories under the home directory. And some of the key concepts we are going to be covering will be files and directories again, case sensitivity, and then also simple globbing. So let's get into, first of all, copying files. So command syntax for copying file is a cp, and it will provide a source and a destination. The cp command is used to copy files from one source to a destination, and to produce a verbose output with a cp command, we can use the -v to show the progress of how the files are being copied. Now, if a file is copied into a directory, it will maintain its original name. You can provide a new name for the file when copying to a new location. So in this example, we are copying and using the -v for verbose, the original, to a temp folder, and then renaming that with original.back. If we had not provided a new name, it will keep the original name. So now it's been copied, and if we do ls from the temp folder, we can see that the name has changed to original.back. Now let's still continue with copying files. So to ensure the copied files do not overwrite an existing file, so for instance, you may mistakenly copy a file to a location which does have the same file existing in that. We can provide a -i for interactivity, which will prompt us if we want to overwrite or not overwrite the file. We can use a -n to no rewrite option with a cp command to avoid overwriting a file automatically. So let's look at the screenshot. We have the cp-i, and we are copying the host name to original. And what would happen is it will prompt us if we want to copy this file or not. And by typing n, we'll overwrite and say no, do not overwrite the file. And if we do the ls again against original, that file does exist. So the cp command by default copies only files but not directories. We can use the -r option with the cp command to copy directories as well. So the cp command outputs omitting directory when the default is used to copy a directory. So in this screenshot, we're using the cp-i for interactivity, and then we're copying the entire SSH subfolder and then placing that within the temp folder. And we'll see that without providing the -r, it's telling us that -r not specify omitting directory. So that means it will not copy directories because we did not provide a -r. Now on the next command, if we provide a -r, now we don't see that error anymore because we're now copying, we're telling the command to copy all directory structures. Now the next command is moving files. Sometimes you may see the need for you to move a file and not just copying. So the shortcut that we normally use within Linux is just mv command, which would do two things. It will move a file from one location to another and also rename the file if we want to. It's the same syntax format as a cp. We have the mv, source, and destination. But you need to have a proper permission though to move a file. Otherwise, you receive the permission denied error message. So the mv command uses the same option as a cp command, such as the -i, -n, and then -v, except the -r, because we are moving, we don't need to use the -r. So for this particular example, we are moving the host file from etc to our current directory, but we do not have permission to do that, so we get a permission denied. If moving a file into directory and no new file name is specified, the moved file will keep its original name, just like the cp command. If we are moving a file without providing a new name at the destination, it will maintain its original name. mv command can also be used for just renaming a file. So you can have it in the same location, but just rename it. And the way to rename that is just using the mv command. As an example, we are not moving this to any new destination. We are just changing it from test singular to test plural without providing a new destination. So that is one more function of using the moving command. Now, creating files and directories. So the text editors such as Nano or VI are good for creating a new file. We can use the touch command for two major things. We can use touch to create an empty file, which we can populate later, or we can use the same command to set or update the access, change, and even modify the timestamp of a file. Now, the reason why sometimes touch can be used for that is, let's say an attacker breaks into a system and then they have done everything that they want on a system and they have accessed a file and all that. Well, during forensics, the forensic team may be able to determine when the file was accessed, any modifications to the file, and the timestamp. What the bad guys can use the touch command to reset the file's timestamp, access, and all those things to a different timestamp or date to confuse or hide the time they use to access such file. So to create a new directory, we use the mkdir command to create a new directory. So let's walk through this screenshot here to reinforce these concepts. So the first of all, we are using the touch command to create a text.txt, and then we're using the ls-l to display the information about this text.txt. So now we can see that this was created on March at this particular timestamp, but we can now use the touch command to change this into our own timestamp. So you can see that we have changed this all over to December 31, 2022, even though the original date it was created was on this date. So that is how we can use the touch command to accomplish these two things: create an empty file and even modify the timestamp on the file. To delete a file, we'll use the rm command. We have used this command before in our previous demos. The rm command is remove. It's used to delete files. we can use the rmdir command to delete directory. So these are two different commands. This is for just a regular flat file. This is remove or delete a directory. Now, if the directory has contents in it, the rmdir will fail because you have a content in the directory. In that case, we can use the rm-rf, which will be forcing the deletion of that directory. If we want to use interactivity, we can still use or provide the -i option to avoid accidental deletion. In this example, we have listed our directory. We have these files in here, and we want to remove every file that ends with the .txt. And we're providing the -i for interactivity, and that will prompt us for every single file for us to confirm that we want them to be deleted before they're deleted. So in this case, you provide the y for yes to delete all these files. We do that ls again, and those files are gone. So let's get into demo on how to use some of these concepts. So let's check out our home directory by using the pwd command, and we are in our home directory. So let's try out again with the ls command, and all these are already highlighted. Matter of fact, let's go into etc and shoot a same command. So this will be a good example for us to play around with. We can see that by default, because we are using ls --color is equal to auto, is providing this output in color form. So if we don't want to have this displayed in color form, we can place the / before the ls and hit enter, and that would output everything in just non-color format. If we go back to home, our home, these are all displayed to us. But if we want all hidden files, -a will show us all these files that are hidden from us. Let's say we want the metadata by using the ls-l to get more information about a file. We can see that these are directories. They all begin with a D. They are directories, and these are the permission and the number of links, the user owner, the group owner, and then also the size of the directory and the date for each when they were created. If we want the same output in a more human readable form, we'll just provide a -h, and that will give us the size of the files as in kilobyte. If let's say we create a new file, touch test.txt, and let's call that 1, and that is empty. So let's do the human readable. We can see that is 0, and this is empty. If let's say we want to list recursively here, let's do ls like that. Now, if we want to step through each one of these directories and list inside of each, we can provide the $R like that, and that will recursively list everything for each one of these directories. So what happens is it will step through, it will go into desktop, which is the first directory, and then begin to list all the files in desktop. So we have on the desktop, we have the test.docx, and then it will get into snap, which is the next one in a list you want to get into, and then we'll list everything that is within snap, and then get into other subdirectories in snap, and then list them as well. And then it will also get into other subdirectories within the code. So in this case here, and then list them until it's done. So that is the reason why it is important that you don't do recursive listing from the root directory. Now let's also use sorting. So we can do ls-l and then provide the uppercase S, lowercase h, and then T, and we want the full time, and we want that on user and share. And this is going to list everything in human readable format and according to the last time they were updated. Let's do the same thing for our current directory. And you can see that we're sorting these according to the last time they were updated. And this was the most recent one we just updated. So we have test file, test1.txt. Let's create another text file and let's use nano. So test2.txt. So our test2.txt will have this entry. So Control X, and then let's save it. Let's do ls. We have our test1 and then test2. Let's use the cp command or use the copy command and copy the test1 into temp folder. But in the meantime, let's list the temp folder to confirm that we don't have any file called test1 in it. So we'll use cp and then test1 and then temp folder, and we'll keep the name as it is. So now if we bring back the previous command and then list a temp folder, we should have the test1 here. Now let's repeat the same command, but this time let's change the destination name. Let's change the file name to a new file. So test.back, and let's list the temp folder, and we should now have our new file with a different name. Let's say we want to avoid overriding the test.back. We can provide the -i to prompt us if we want to override or not. So this is how it would look like. And we just want to overwrite. So we just say yes and then go ahead. And that would overwrite that test.back. Okay. What if we want to copy the desktop into the temp folder? So we do copy desktop into temp. And we see that we got in this. So we did not specify the R for the directory copying. So that would throw out an error. But this time, if we write that with a -r and do ls temp folder, we should have the desktop copied over to the temp folder. Let's try out the move command. Let's try to move out the test2 into the temp folder and then rename it. So move the file we want to move, and then temp folder, and then test.mv, like that. And if we do ls temp folder, we should have the one which was moved and at the same time renamed. If we do ls, we no longer have the test2 in our subfolder. What if we want to rename this into test2? So we can just type move test1.txt and then call this test.move actually. Now if we do ls, this file has been renamed into test.mv. Let's use the touch command again. So let's create an empty file, touch, and then let's call the test.txt, and we'll do ls-l, and we can see that the file is here, and the timestamp is December 25 at 12:39, 2022. So let's assume that we want to change the timestamp to future or past date. So we can use touch -t for timestamp, and we'll change this to 2010, December 31 at 12. And we are using that against this test.txt. So if you hit enter, and now if we do ls, we can see the timestamp has changed to 2010. Let's go ahead and remove this file using the remove command. So it's just rm and then test.txt, and that should remove the file for us. If we want to remove a directory from the temp folder, so we'll just do remove dir and then the desktop. And it says it's not empty because we have something in that directory called the desktop. If we do ls temp and then desktop, we can see that we have the test.docx in that directory. And that is what is preventing it from removing that directory. If we want to force remove that, we can just provide the -f rf to remove it. So let's use rm-rf to force remove that. So now if we do ls temp folder, we should not have the desktop any longer here. Fantastic. So in a third module, we are going to look at the power of the command line. And the first sub-module is archiving files. On the command line, we are going to look more into archiving files and also using other techniques to compress files. Now at this point, some of the key points are going to look a bit more redundant, but it's a good thing because the more we repeat most of these topics and points, the more they get stuck up in your head, right? So some of the key points we're going to look at are going to be files and directories, and also archives and compression. So just a brief introduction on this subtopic. Now, as a Linux user, there will come a time when you may not have enough space on your computer, or you may need to transfer file on a network to a destination. Now, due to the fact that we don't have unlimited disk space, or we don't have much of a bandwidth when it comes to transferring files, we may need to have some tools under our sleeves to help resolve these issues or overcome these issues. And that comes in compression and also archiving. File compression is a process whereby we reduce the size of a file or a directory so we can save a space, or even make it smaller for us to transfer the file over the network. Now, this is done by removing, removing and replacing redundant information with smaller ones. Now, these are things which are not naked to the human eye. So there are some things within each file that occupy some spaces which may not be needed, and we can, using compression, remove such redundancy and then replace them with just smaller ones. Archiving, on the other hand, is when we combine multiple files or directories, and they could be any size or different sizes or the same, into just one file. Now, usually we use archiving as a part of system backup, or when we want to move a data from one to another. So let's look into compressing data. Again, like I said, the compression uses an algorithm which reduces the size of the files by removing any duplicate data from a particular file. Now, we have two kinds of compression, and depending on what you're trying to compress, either one of these may have their pros and cons. The first is lossless, and the second one is lossy. So lossless is when the compressed and decompressed data are the same. So in that case, not much of a data is lost here. And this is mostly the most common type of compression that you come across when it comes to using your Linux or even performing any sort of compression. Now, this doesn't, because of the fact that the compressed and decompressed data are the same, it doesn't do much more compression compared to the lossy type of compression. Now, again, like I said, depending on what you're trying to compress, this type of compression is going to be good for documentation or logs or software. And that is true because these are things that you do not want to lose any part of the data. For instance, you don't want to lose any part of your logs, otherwise they may not make sense to you as you review them. Now, the lousy part is where the compression is done much more better. But of course, it comes with its own downside. The decompressed data may lose some information as a result of the compression. This is good for, let's say, images, sounds, or movies. And the reason why it is good for some of these media is because we have what we call white spaces. And we can maybe lose some of these things without impacting the overall media. So for a movie or a sound or an image, we can lose some of the information without completely impacting any of the media's final outcome. So let's continue with the compression. Now, Linux uses a number of command line tools to perform data compression, and these are examples of few that we would go through or focus more in this session. We have the gzip, or the other part of it is gunzip. And this is the most used Linux compression tool, and it's well known for the lossless data compression because it doesn't impact much of the data or information when it comes to compressing a file or directory. The bzip tool or bunzip compresses files significantly smaller than the gzip, and again is best for the lousy data compression. The next one is the xz, and this one achieves the best compression level, and we'll take a look at that and compare each one of these so you can see and compare which one you want to pick up eventually based on what you're trying to compress. We'd use the zip to decompress archives from other operating systems. The gzip is the most used Linux compression utility. A lot of people who get into Linux for the first time normally want to use gzip. It's a lot easier. It compresses very well and is very fast. It doesn't use too much CPU and other resources for your computer. The opposite of gzip is called the gunzip. So the gzip with the option D, that's the same job as a gunzip. So if you want to decompress a file, you have one of two options. You can use the gzip with the -D option to decompress, or you can just use gunzip and that would by default decompress your file for you. So the gzip can take an output from a command as an input to also compress a file. So let's take a look at what we have here from our screenshot. This is an example of we are in the var/log directory on a Linux machine, and we're trying to zip this auth.log file. So instead of just using the zip directly against it, we are using piping, and we'll talk about pipe in the subsequent slides. So first of all, we are using the command cat to cat the auth.org log, and then take that output to feed into gzip, and then gzip that file into auth_backup.gz. Once we're done and we do an ls from the same directory, we can see that we have compressed the auth log into auth_backup.gz. If we use the gzip-l against the compressed file, we are able to get information about the file, indicating how much ratio or how much it was compressed. So this is the file compressed and the size, and this was before it was compressed. So you can see there has been a significant amount of compression here because we have had about 90.4% compression, 90.3% compression from the original file to the compressed file. So these are some additional commands that or options that you can use the gzip command for, or even gunzip. So in the first command, if you recall the wildcard, right? So if we do a gzip and a wildcard, we are compressing all files in the current directory that we are executing this command from. And this is going to have the file extension of .gz. If we use gz space -r against this directory, we are recursively compressing all the files in that particular folder or directory. If we use the gunzip -l against this compressed file, we are showing the file's statistics similar to what we did with the gzip -l. If we do gz test against this particular file, this will by default compress it and then append .gz against it. So you know that it's a gzip file. If we use a gunzip against this particular file, by default, this will decompress this file into test file. This is similar to using the gzip.d. The next tool is the bzip2 or banzip2. The bzip2 has similar syntax to the way the gzip is, and it produces significantly smaller files using more CPU. So that is the downside of it. These tools and techniques have their pros and cons. And at the end of the day, they all do consume CPU or computing resources. But which tool you use will determine how much of a computing resources it will use. So the bzip2 or the banzip2 does use more CPU, leading into better compression for you. So the compressed files would normally end with a bz or bz2. And these are additional commands you can use either banzip or bz2 for. So the first one is bz2, and then asterisk will do the same thing as the previous one and compress all the files in your current directory. If we use the banzip2 and then this asterisk, this would decompress all files that has the extension of bz2 in the current directory. This is similar to bzip2-d. If we use bz2 and then the name of the file, this will also compress a file and then have an extension of bz2. So now we go to the third tool for compression, which is xz. And this is the one that saves the most space because it does much more compression than the previous two tools. Of course, it comes with a cost, and the cost is CPU usage. It will take a lot of your CPU or your computing process to compress files. So the compressed files are stored with extension of .xz. So in this screenshot, we're using the command xz to compress the file test.txt, and that would have the xz as the extension. These are the few additional commands we can use the xz for. So xz, the asterisk or the wildcard will compress all the files in your current directory and then rename it with extension of xz. If we use the xz-dk against this xz file, this will decompress the file, but it will keep the name, it will keep test.xz even if the decompression is successful. So this is used to still keep this file, but also have the decompressed version as well. So you end up having two types of files. The next command is x-z and then wildcard and then .xz. At this point, you're following the rhythm, right? So this is going to decompress every file that has an extension of xz. We continue with the next tool for compression, and that is zip. So by default, the zip command would add files to an archive and also compress at the same time. So this will just kill two birds with one stone. Well, we can also add an option of -r, which will recursively also add in the subdirectories. So again, these are a few additional commands that we can use with zip. Zip archives, and then asterisk will archive all the files in our current directory, and then place the file within the archives.zip, .zip file. If we use the zip -r and then provide this name and the tilde, what happens is it is going to zip all files within our home directory and then recursively zip everything or add everything within that zip file and then name it as archives.zip. If we want to unzip a file, it's as simple as just unzip and then the name of the archive or the name of the file to unzip it. We can also use zip to zip multiple files into just one file. So in this case, we use zip and then provide the name of the final file and then the files we want to compress. And if we want to just list the content or show the contents of a zip file, we can use unzip-l to show the contents of the file. What is so surprising and also funny is the order in which this thing is done. So when it comes to zip, the destination or the final output comes before the input. So you have the syntax of zip the command, and then this is supposed to be the outcome or the output, and then this is supposed to be the input. And that is why you can see all of them have zip, the name, and then the input. So before the advent of this modern technology where we are able to save files and even have them on a cloud and things of that nature, files were physically put onto what we call magnetic tape, right? And then those were used for creating backups. Now, the technique for doing that was what we call tape archive. And the short form for that is TAR, T-A-R. So TAR stands for tape archive, and that was used to archive files on what we call the magnetic tape, so that we can take the tape and then to the offsite somewhere to save it. Of course, nowadays, we don't have to do that with all these technologies. However, it is still useful in most cases when using your Linux machine. So it is used to create or extract files from an archive called a tarball. And you can use that optionally to compress files while also creating the archive and also decompress while extracting the files, content. Creating a tar command requires you to specify mode. So the modes are the create, extract, and list. But the shortcut for those or the short form for those are CTX for creating, showing, or extracting the files. And then we specify the letter F to tell the tool that it should expect a file name as the next argument. So let's run through quickly in this screenshot. When we do the ls from the log directory, we have the list of all these logs here. And then we are using the tar command. And then the mode we're using is -C to create. And then F is we providing the command that the next argument is going to be the file name that we want to create. So talking about the order in which these commands do work, this is going to be the actual output, but the input is a wildcard. So what we're saying is it should use the tar command to create a new tar file or tarball for everything within this directory. And that is what a wildcard is. So once that is done, we can use the ls command to look at this file, and we can see that it does exist or it has been created. So tarballs can be compressed for easier transportation, either by gzipping the archive or by having tar to do it with a Z flag. So you can work with tar to compress file in one of two ways. You can use a gzip to do that, or you can pass an option of Z to also do the compression whilst it's doing the archiving for you. So this command is using the tar, and we're using the C for create, Z for compression, and then the F is the end result of this file, and this is going to be the entire files within our current directory. So once we're done, and then we use an ls against the created file, it will show us that it's been created. All right. And then if we want to see the statistics of this file as to the size before and after compression, we can just use the gzip with the L option, and it will show us that we had about 88% compression ratio. So the file before compression is this size, and after compression came down to this size. And these are additional commands that we can use with the tar command. So let's get into a demo to practice on what we have gone through so far. So in this activity, we are going to explore several different ways of data archiving in Linux. So let's begin with using the tar command to back up all files and subdirectories under our home directory. So first, we're going to confirm we are in our home directory. So we'll use the pwd, and we're in the desktop. So we'll just use tilde and then drop us into our home directory. pwd, we are within the user directory. So first, we're going to archive everything here into an archive name of home.tar, and then have that saved into the temp folder. So we'll begin with the tar command -c for create, v for verbose, and then F for the name of the file we are creating. So it's going to be in temp folder, and we're going to call it home.tar. And we'll provide the asterisk, or we can even use tilde instead. So let's use an asterisk, and this is going to use the tar command to archive all of the information here into a file named home.tar. And then we'll hit enter, and that will proceed to do the archiving, and that is done. So we'll clear the screen. And if we do ls from the temp folder, we should see that we have the home.tar. Let's check out some few additional commands that we can use the tar command for. And the next one is tar, and we're going to use the gunzips Z and then C for create, and then F for the file that we're going to save. And this is going to be home.tar and then .gz, because we are using the Z option for compression. And then we'll hit enter. And we should expect some of these messages coming up, but because we did not provide the V for verbose, we are not seeing any progress. So this will take some time. Well, there you go. So it is done. And if we do ls temp, we should have the home.tar.gz. Next, let's try the same command, but change Z to just J. And because we are using the bzip or bunzip, we're going to have this extension as .bz2. Okay, so because we use the bunzip or bz, that took a bit longer than when we used the original gzip. Next, we are going to use the xz with the same tar, and that should take a lot more longer than the rest. And we'll just change the lowercase j to uppercase J. So that will tell tar that we want this to be compressed using the xz.
3,000 years later.
Now that we have used the tar in combination with the various compression techniques, let's confirm and then look at the sizes of all these files based on the compression that we use. So we can use ls-l and get into the temp folder and then call out home. And let's use asterisk like that and see if that one works. Okay, so we can see that the same files, but all of them have different sizes because of the way that they were compressed. But again, this looks a little bit too foreign. So let's update our command and then add -h for human readable form. So it will make much more sense to us. So we can see that the GZ did way better than all of them because it was able to compress the same file to 43 megabyte. Next was GZ. Next was BZ2, which again, according to our slides, that's better compression than gzip, and that was down to 51 megabyte. And then the gzip or ganzip came third in 56 megabyte. Of course, this is the actual size of the file because there was no compression down here. It was just tar, and the actual size was 116 megabyte. So considering the XZ did much more work by halving the size for us. Let's also figure out how to list the contents of the tar file using the tar command. So tar and then -t, v for verbose, f again, and then temp and home.tar. And that will just list everything from our home directory. Let's attempt to extract the content of the tar.gz. But first, let's switch or change directory into the temp folder. And let's do dir to list the directory. So we have the tar here. If we do ls, we have it. So let's use the tar command and then try to extract this content. So we use tar and then -x for extraction, v for verbose, and then f for the name of the file. And this will be tar.gz. Hit enter. That is done. Now if we do ls, we have the home directory, the home file being extracted. Next, let's use the tar command with the R option to add a new file to the tar.home file. So the command would be tar-rvf and then home.tar, like that. And let's add in the etc host file to this file. So again, talking about some of the nuances in some commands in Linux, we have this is the destination and this is the source. And yes, I know it's a reverse of what we are normally used to. Okay, so once we hit enter, okay, so now let's try to view if this file was added successfully. So we can use a tar and then -tvf and use home.tar. Just pipe that into tail so we can see if this file was appended to this. And we can see that, yes, it is here. It was appended. And we'll get into the tail, the head, and other commands in the subsequent slides. Next, let's use the gzip. So we'll copy another file into a temp folder. So let's copy the user, share, dict, words, and then save it here. So I'm using something new, which you may not have seen me use before. So what we're saying here is because we are already within the temp folder, if I am copying a file, which by the way, this is the full path into my current directory, I don't need to provide the directory itself again. I can just use a dot and this will say use this current directory. So once we do that, that is going to copy the words file into our temp folder. So now we should have it here. Once that is done, let's use the gzip command to zip that. So it's as simple as gzip and then the file's name. Now ls should tell us that by default, because we use a gzip, it appended .gz to the file's name. Now we're going to try to uncompress this file. Let's try to use a ganzip against the word gz, and that should uncompress that for us. Now you can see it is now back to Word. Now let's use the zip command to compress the same file. So zip and then words.zip, the destination, and then now the source itself. And this has been added. If we do ls, the funny thing is it kept the original file and then created our zip file as well. So next, let's use the zip command to recursively zip the etc directory and save that within the temp folder. So we'll do zip -r and then temp folder, and then let's call it etc.zip, and the source is going to be this directory, and that is going to add all those into the etc.zip file. That is done. And if I do ls, we should have the etc.zip file. At this point, we are much more aware that the Linux system comes with a ton of files and directories. And sometimes you may find yourself just lost trying to search for something. So for the second sub-module, we are going to look at searching and extracting data from files. We are going to repeat some of the things that you have seen me use already. We're going to look into command pipelines, input and output redirection, basic regular expressions. So let's get into it. So by default, the command line normally displays an error on a command line. So when you type in something on a command line, which we have seen as me running into some problems with my commands not working or throwing an error. So by default, the errors are displayed in the terminal. Now, there are several ways in Linux that we can manipulate and also redirect such information or output somewhere else to make either our command work a bit neater or also make our script much more nicer. We can use what we call piping character, which would take an output from the first command or from one command and then it become an input for another command. So the syntax usually looks like this. In this case, we have two commands. We have the first command is run, and then the output from this command becomes an input from this particular command. And we don't have any limit as to how many pipes you can use. One benefit in piping is that there is no need for you to save your output into a file before you reuse it. So we just use one command, take an output, and then directly becomes an input for another command. Now, multiple commands can be combined to form what we call the pipeline. So there is no limit on how many to use, but of course, you have to apply some common sense on how many pipes you do for a command, because the longer it is, the much more confusing it becomes. The order in which commands are chained in a pipeline can determine the final results. So you need to understand what are your final results that you're trying to accomplish before you use a pipeline. Otherwise, you may have different outcome based on the order in which your commands are run. So let's compare these two commands for a case study. So for this, we have a file called sample.txt, and we use the command called cat. Now, cat stands for concatenation and is used to display the content of a file. So this first command is just displaying the content from this file. Now, this one has over 50 entries in it, but we use a pipe and then call out another command called sort. We provide the -u to uniquely sort out this input, which is now an output from this cat command. And then once you're done sorting, now pipe it and then use the head command to display only the first 5 lines. So we are chaining 3 commands here, and then that will give us an output such as this. So the next one is the same file, the same number of chains, but the order is different. We use a cat to display the content, but this time we are just using the head to get the first 5 lines from this sample file. And then once you've obtained those 5 lines, now sort them uniquely. And that gave us this outcome. So you can see that we use the same number of pipes, the same commands throughout. The order just changed for only one of them. And then the outcome came out differently. So be very, very careful when you're using the pipe command, because the order you have your commands will determine your final outcome. The next command that you may also find very useful is the less or more command. The less would display the contents of a large file by scrolling up and down page by page. The syntax on using this command is just less and a file's name. Or you can use it with a piping. So again, we can use a cat, the file's name, and then pipe. This becomes an input for the less command to provide just a less. And this, you can scroll through this page by page using the spacebar on your keyboard. You can also search within the less command, either forward using the / or backwards using a question mark from your current position. By pressing the end command, you will either go to the next match found, or you can use the uppercase N to go to the previous match. The head command will display the first 10 lines from the top of a file to the terminal. You can display a specific number of lines with just an option, such as -N. So by default, if you use the head command against a file and it has more than 10 lines, it will display the top 10. But you can also manipulate how much you want to display. Sometimes you want to display just a 5 or 3, 15 or 20. So you can manipulate using the -N to specify the number of lines you want to, or you can even just use the dash number, and that will display the number of lines you want to display. So this is an example of a syntax using the head against the ns_switch.cfg, and these two commands would have the same outcome. Now, to negate a specific number of lines from the bottom of the file, we can use the -N with a negative value. So for this particular command, head -N-5 against this particular file will not display the last 5 lines from the bottom of this file. So the tail is the opposite of the head. So we'll display the last 10 lines from a file. Now, this is useful for troubleshooting any issue using the log files to see the most recent lines of output. You can display a specific number of lines with an option similar to the head. The first one is the same as the previous. We can use the -N for a number or dash with a number. If we want to see a continuous monitoring of an output where the terminal is open, it will keep showing you an update. We can use the tail -F against a particular file such as access.log, and that would give you a progressive or a continuous monitoring of any event that happens. Now, with the -N option, with a positive value, shows the content starting at the specific line and continue all the way to the end. An example is, let's say we want to list the past WD, but we want to start from the 30th line coming all the way down. Let's say we have 50 lines within this file. So the next interesting concept, which if you are somebody who writes a lot of scripts, you may find very useful, or you do a lot of things on a command line, you find very useful, is the input and output redirection from a Linux command line. So we have 3 kinds of the input output redirection, or we call that stream. We have the standard input, stdin, which will be the input provided by user through a keyboard. We have the standard output, the std out, which is a command output with no error. So it's a successful output which is displayed in a terminal. Sometimes when you run a command, you may have an error, such as permission denied or file doesn't exist. Those are standard errors which are showed in the screen or in the terminal. And those are standard error, STDER. To do a redirection of these outputs, we can use the greater than sign and the less than sign. Now let's cover each of these streams a bit detailed so you understand the differences among the three. So the stdin, which is a standard input, also has what we call a stream number or a channel number or a file descriptor 0 assigned to it. This is usually an input received from the keyboard, or in some cases, an input being redirected with the less than symbol. So if we take a look at this image below here, we are using the cat command. Now, typically, you use a cat command to display a content of a file. But if we don't provide any file's name and then just hit the cat command and hit enter, now we are being prompted to now begin to take in an input. So standard input, and each thing that you type in will produce the outcome to the screen. So once we dropped into cat, you type in test, and then it will display the same test back to you. So we type in blah, and that is also displayed on the screen. So that is what the stdin functions. It takes an input or data from the user through a keyboard. So another example of using the stdin is we can use the tr command to capitalize characters by taking an input from a keyboard. So in this screenshot, we're using the tr, and we are saying we are going to convert everything that we type in lower cases into upper cases. So we provide this string and hit enter. And now we have this space to ourselves to input data into the terminal. And then we type in testing this out, testing this thing out. And then once we hit enter, that is displayed back to us in uppercase, calling out this, converting our lowercase into an uppercase. Now, instead of providing an input through a keyboard, we can also provide a file as an input to be executed by this command using the stdin. So we have a text file called test.txt, and this is the content of this file. Using the tr command, the same as the previous, the only thing we're doing right now is we are using this sign, and then we are dumping in, or we're using this as an input coming into the tr command, and then it is going to execute and then convert these lower cases into upper cases for us. We can also take the resulting output from the command and then place it into another file. Yes, things are getting a bit more complicated here, right? Using the tr command, we are trying to convert the input from this file, which was the mycheck1212 in lower cases. So we feed that into this command. Once it is done, we asking that it takes the output from the tr and then save it into test2.txt. So once we run this command, instead of displaying this content on a screen from the tr, as this one looks like, it is not doing that with this particular scenario. It is taking the output and now feeding that into this text file. So once we do the cat, the content is being displayed here. So the standard output, or the stream number 1, is what most of us are used to. This is when the command from the terminal or the command line is displayed to us on a screen. So for instance, the command echo, this is a test, will be executed in a terminal, and then by default, it will display into the screen. Now we can use a greater than sign to redirect the standard output data into a file. So let's look at the screenshot. We do ls, nothing here for us. So now we're using the echo command and then typing this test and then using the greater than sign and then saving that into test.txt. Now we do an ls. This file has been created. If we use a cat command and then display, the content is here. Now, if we are using just a single arrow for the standard output redirection, and we're doing that against an empty file or a new file, there is no problem. However, if we use the same command and then use a single arrow and the file that we're trying to save the new content into has an existing file, message in it, it will overwrite it. The one way for you not to overwrite an existing content in an existing file is to use the double arrows. And that would append the new text to the old text. We have this file called test.txt, and the content is this is a test. So let's say we want to add in an additional content or append it to this file, and we mistakenly use the echo might check 1212 and then use a single arrow. This is going to overwrite this entry. So it will go through all right, but once we do the cat, we will see that we no longer have this is a test, but now we have the new entry here because we use only one arrow and that overwrote the existing content. So let's move forward, and then now we've learned from our mistake and we want to now append the new text to the old one. So we use the echo command and then this time mic testing, and then we're using the double arrow to the same file. And this time, once we do a cat against a test.txt, we can see that our old text still exists and the new one is appended. All right, so the third stream is what is known as the stream number 2. So we had a 0, 1, 2. 0 is standard in, 1 is out, and then 2 is error. So you have seen that over time, we may sometimes have a command which will produce an error. And as much as we may not bother having those strings on the screen, sometimes if you write, let's say, a script, or you're doing some things on a command line and you want to subdue the amount of errors on a screen, you may want to use a standard error stream. And this is going to be an output of a command error. An example is this particular command, which we're trying to cut the content, or we're trying to cut this file called blah within the etc directory. However, this doesn't exist. So we did get this error saying not such file or directory. So we can find a way to subdue this error message. So even though we can use the greater than arrow to take an output into a file, we have to understand some differences between the stderr and an std out when we're using the arrow. The first one is because the standard out is stream number 1, by default, anything that we do using the arrow is going to assume it is standard out. If we want to distinguish between standard out and standard error, we have to use the number 2 before the arrow sign. And that will tell the terminal that this is an error that we're trying to save into a file. So if you remove this number 2, it would assume by default this is standard out and we'll just save it accordingly. Okay, so let's take a look at the screenshots down here. We use a cat command to display the blah, but this time we're trying to save this as an error into a file called error.txt in a temp folder. So once we cut that, it is going to display the content of our error and now not showing that on the screen for us. So there are some cases that sometimes you may not want to even display your error messages in a terminal or even have them saved in a file. So that would actually make your script or your commands a bit much more nicer and neat. So we can use the dev/null to send the output from our error to be discarded. So anything that we use and then pipe it or save it into the dev/null will just completely discard off. So if we look at the screenshot here, we are using the cat command again against an non-existing file, which would have otherwise produced an error on a terminal. But now we are saving that into the dev/null. And then once we try to even cat out the null, it comes out as empty because the error message from this command was completely discarded. The dev null can also be called as the bit bucket. So this is referred as a null device or the dev null. So there are cases that, of course, you can use multiple streams. So we can combine all of these into various ways depending on the outcome we want to. So it is possible for us to combine both the standard output and then the standard error at the same time in some instances. So if you take a look at our example in this screenshot, we can see that we are issuing a command called ls, and ls against two types of files. One of them exists and the other doesn't exist. So we have the blah does not exist, but we have the etc//ssh that does exist. So once we run the command, we do see that we get two outcomes. We get the first error was the fact that this file doesn't exist. So this will be standard error. But the second one does execute successfully because the etc//ssh directory does exist and it lists the content of that directory. So we continue with the multiple streams. Now, sometimes we want to see only the error messages. So from a previous line, both of the standard error and the standard output all were displayed on a screen. But sometimes we just want to see the error and not the successful output. So the standard error output can be isolated from multiple streams output by redirecting the standard output into the null device or the git bucket or the dev null. So let's walk through this screenshot to reinforce this particular concept. So we go back again to the command, but this time we are using the ls, blah, and etc//ssh, and now we are piping the standard output. Remember, we don't have number 2 here. So by default, it is going to assume standard output and then take that and then push it into dev null and then discard it. So what we're saying with this particular command is only display error messages, but discard successful outcome. And that is the reason why it's only showing us the error from the blah file, which doesn't exist. If we go into, again, the next command, and then the same thing, but this time just use the arrow and then decide to save it into an actual output file called stout.txt, we will still get this particular error. We will not get a display for the content of the successful found directory, but it will be saved in this file, and we can use the cat command to display that. So the reverse is true. The standard output can be isolated from multiple streams output by redirecting the standard error into the dev null or the bit bucket using the number 2. So the same scenario, the only thing that changes here is we are now going to specify number 2 here, and that would accordingly only save or discard the standard error message. We still continue with the multiple streams. So we can also use both std, the std out and stderr can be combined and then sent to a file by using the ampersand. This means it's going to execute both the 1 and 2. An example is, in this case, we are even dumping all the results into just all.txt. We do not want to see anything on the screen or in the terminal. We want all the outcome be saved into a file. So we provide the ampersand here. We can do this in two ways. We can specify this individually by using the right arrow, which will be for saving the standard out into one file, and then specifying 2 and then the right arrow to save that for the standard error. Or we can use the ampersand, just one, and then that will save all of them into one file. So the next topic is searching for files in Linux. And some of these may be a repetition from previous demos because we are going to go through or cover some tools or some commands that we have already used previously. And the two most well-known commands for finding or searching for files on Linux are the find command and then also locate command. And these two utilities can be combined with a grep, which will cover that extensively going forward to fine-tune your search criteria or your search results. So the find command is used to recursively search the file system tree from any particular directory to find files that match a specific condition. We can use the find command in combination with different options to fine-tune your results, such as using the name. We can search by just a name. We can use a find with a size of a particular file that you're looking for. We can search by a specific date or even an ownership type. The syntax is the find command and then the directory we want to start our search from, the search options, the search criteria, and then the result option. So we take a look at this example of using the find command in combination with the -name option to find something based on the name that you're providing. So for this screenshot, we're looking for a file from within the etc directory and using the name option and look for everything using asterisk. Look for every file within the etc directory that has a name ending with .conf. So it will go through all that and then combining that with our redirection, we want to just have or discard all errors that come in. One of the errors you see with find command is we may have permission denied because a particular file you may not have permission to list those. So we want to have all those things discarded and then show us only files that we have permission to view. This is a very nice way for you to fine-tune your results and then just remove all garbage when you're using the find command. In this example, we are still continuing with using the file type. So in this case, we have talked about this previously that we can specify a file or a directory. So in this screenshot, we are doing this find from the root directory and we are looking for the file type, a directory. It's a D and the name contains GCC and discard all errors that come back. So this narrows this down to the files, the directories that we have permission to view. We can also search for the file by the size by using the -size option, and the file size can be specified using K for kilobyte, M for megabyte, and then G for gigabyte. Few examples to guide you on how to specify a file size. +1 G means more than 1 gigabyte. -1K means less than 1 kilobyte. So you can specify that you want to find all files that have a size of 1 gigabyte and above or 1 kilobyte and below. So let's take a look at this example and you see an instance of an error which we could have just discarded because all these are standard errors. Okay, so we're using the find command from within the etc directory and then we're specifying the size and looking for all files that are 5 megabytes and above. So let's get into a demo to practice some of these concepts. So let's begin with using the piping command. So let's display the passwd first, so we can see how this file looks like. So this is a content from the passwd file. We have the first occurrence is root, and the last one is fwupd. So let's try again and then do cat etc passwd, and this time let's sort by unique and hit enter. So we can see now it has changed, right? And if we go all the way up, it has now sorted out alphabetically, right? So apt, and then all these are now sorted out. Now let's pipe it, and then let's now display only the top 6 lines. So now we can see these are the top 6 lines, or the first 6 lines within the sorted passwd file. So 1, 2, 3, 4, 5, 6, and you can see they are all sorted out. Let's go back and let's change this slightly, and let's first of all get the top 6 this time and sort out uniquely. And we can see that now this outcome has changed. And it's because the order of your piping will determine the outcome. Next, let's use the less command against the same file. And this will go page by page. So this is the first page from the less command. And if I hit a space bar on my keyboard, that will take me to the next page. And because it's only 2 pages, we hit the end of this file. If we want to search, we can just use the question mark character to search backwards. We can use the / to search forward. So we went backwards, and now we found root in here. Now just hit Q to get out of the less. We can also use a cat and then pipe it using less as well, like that. And then just type in Q, letter Q, and then get out of less. We can also use more. This one shows you the percentage of the page we have covered so far. And if I hit the space bar on my keyboard, that would take me to the end of it and then close out. Let's use the head command for the same file. This will provide us the first 10 lines from the passwd. If we only want to see the first 5, -n 5, like that, and that will show only 5. If we want to show only 3, using just the dash number, and that will show us only 3. Let's try out a negative number. -n, and this will show us the lines, but not including the last 3 lines. So if we do default, if we do cat, so you can see that with using the negative number with a head, it showed us all the way to here, the HP LIP. But the default cat will show us this. So it cut off this last 3 lines without showing us using the negative number with a -n. Let's try the same thing with the tail, which shows us the last 10 lines in a file. So this is the last 10. And let's manipulate by using -n and then number 5. Show us the last 5. And let's do the same thing. Just 5 without the n. And that will be the same outcome. So let's try NL, and then etc passwd. And let's pipe with tail. And let's use -n plus, say, 30. Let's see if we have that. So this one started off from the 30th entry or the 30th line and then gave us the last line from that. So if we were to do the same thing, and let's say, so this is the, we have 48 lines in total from the passwd. So let's cut this back to, let's say, 47, and let's see what happens. So we see that it started off from just the 47. Let's get into the standard input, output, and the error, and let's try some examples. So usually we can use a cat and then provide a path like we've been doing for the past couple of examples. But what if we do that, we type in cat without providing any file as an input? That would drop us into just this blank spot, and anything that we type and hit enter will be displayed back to us. Okay, so now it's behaving with the standard input as a keyboard from us, and it's taking all input from us and then displaying that on the screen or redirecting it on the screen for us. We'll just do Control-C to get out of that. Let's try with the tr command, and then let's take out lower cases and then capitalize that. -Z, hit enter, and let's type in testing this thing out, hit enter, and that will convert our input into our lowercase input into an uppercase output. And then Control-C to get out of here. Let's get into our home directory. Let's do an ls, and yes, we have something here. So we have the test.mv. Let's display that. Oh, that is empty. So let's use echo, and let's save that into the test.mv. So now if we do test.mv, we should have something. All right. So now let's try to use the same command, but this time use the input file from test.mv and then provide that with the tr command. So here it is. And we're using the less than sign and then providing test.mv as an input, and it will convert everything into uppercase for us. If we want to, instead of displaying this on a screen, we want this to rechannel into a different type of file, we can use that and then call that test.txt, like that. So it will take this output and it will not display that on a screen, but save that into text.txt. So now if we cut test.txt, we should have this output all capitalized. Now let's try to assume we're trying to save a new file into the test.mv. Like this. We already have this here, right? So let's assume we wanted to save another file. So test1212. All right, so let's type in appending a new file here. And we use just one arrow and then test.mv. So what would happen is if you try to display the test.mv, this file is gone. That's a very bad thing. So let's assume we wanted to just append this without overriding. So we just double, and then let's say appending another file here. Now, if we cat test.mv, we should not have these two files. Let's try our standard error. Let's do cat esc and then blah, and we do get no file or directory exist error. But what if we don't have this? We don't want to have this displayed to us on the terminal. We'll just use number 2 and then the right arrow, and then have that saved into temp folder and call that error.txt. So now the error, this one is no longer displayed. It's saved here into this file. And if we cat that particular file, this was saved here. If we want this discarded completely, we'll just do dev.null/null, and then that's it. And if we try to cat the dev, that has nothing. So this one completely discarded this error message. Let's try to combine multiple streams. So we do ls etc blah, which will throw an error, and then we still want the etc for SSH, and this will list the SSH one, which this does exist, but this doesn't exist. So we get both the error and then also the successful outcome, all of them displayed on a screen. What if we don't want to see the successful outcome? We only want to see the errors. So we bring it back again. And this time we want to discard off any unsuccessful. Oops, sorry. This is going to discard off of a successful entry. So if you change this and then make this 2, now we have that. So the first command is going to display only error messages that the file doesn't exist, but the one which does exist will be discarded because there is no, by default, the standard output will use the arrow without any number. And the second one is only discarding the non-existent file or any error and displaying the successful display of this directory. If we want to have all of these outcome saved into a file somewhere, so we don't want any display, but want it all saved into, let's say, temp, and then all.txt, we'll change this number to the ampersand like this, and nothing will display on a screen. So if we do cat and then temp and then all.txt, we'll have all the output in this file. Let's use a find command to recap on some things we may have done previously. So we're using the find command and then stepping into the user directory, and we want to search for a name called nc. It doesn't matter whether it's a file or it's a directory. So it was going to go through, stepping through this directory and all the subdirectories, and then look for the nc name. So we're done. It stepped through all the subdirectories under the user. Let's continue. And the same command, but this time we are looking for a file type D. for directory, and the name we're looking for GCC. And we came back with these two directories. If we want to search for files in the current directory, which were modified today. All right, so let's check, confirm that we are in a home directory. Yes, we do. We do ls, and we have some files we did create today. So let's use a find, and we are not going to provide any path. So by default, it will use our current directory, and we want the type to be F for a file, and we want F for a file, and then the time is going to be today. And this will find all files which were updated today, as of today, from our working directory. Okay, let's do the same thing for a file, or for files which were created 3 days ago. So we do find -type F and -c for create, and then time, and then 3 for 3 days ago. And these are files which were created 3 days ago. Let's search for files in the root directory which were accessed or has been read for the past 5 days. So find, and then the root directory, and then type is going to be F for a file, and then A for access, and then time, and 5 days ago. And you can see that we're getting some permission denied here. So let's modify this command and make it a bit more nicer by discarding all errors. So now you can see that it's now being a bit more nicer than just displaying all those garbage. And we didn't have anything that we had access or permission to access. So we can also search for all files in the root directory with a size of 1 GB and above. So find, and then the root, and type is file, and then let's use size plus 1 gig, and let's redirect all errors into bit bucket. So we only found 2 files that are 1 gig plus. So let's continue with searching for files and the many ways we can manipulate our search results to achieve our goal. And another command that we can use in searching for a file is the sort command. And that is used to rearrange the output of a file either in ascending or descending order. By default, files are sorted out in ascending mode, but if you want to have them in a reverse or descending order, we can use that in combination with the sort command. The syntax to use the reverse is going to be the sort -r and the file name. Now, to specify a delimiter, you can use the -t option. The default is just a space, but depending on the file structure, you may have a delimiter of, let's say, semicolon or column, or even just 2 spaces or 2 tabs. So you have to study the file itself to understand what are the delimiters, and then use that in combination with a -t option. We can also use the -n option to sort numerically instead of just a text. So to sort the lines by specific field, you can also use the -k option with a field number. And the syntax is sort -k and then the number you want to sort by and the file name. So this syntax, for instance, is going to sort the lines by the 4th field or the column, on each line instead of the beginning. And this is an example of using the head command to display only the 3 lines from the etc passwd, and then sort, and then using the delimiter, the columns, and then so I'm doing a reverse sorting, and then numerically using the 3rd line or the 3rd column in this outcome or this file. We can also use the sort with the U option, which you have seen me use, and that is equivalent to unique, or to uniquely display a content without repeating any duplicates. The syntax or the various syntax we can use with the sort and the U are just a sort, the file names, and then piping that with unique, and then saving that into, let's say, a 3rd file. So you may have 2 files that you want to combine, but you want them sorted out first, and also remove every single occurrence of duplication, and then save that into 1 file. And the case is, for instance, if you're performing, let's say, any work from a standpoint of pen tester or ethical hacker, and you're performing some tests, and then you come across files from different places, but you need to have all of them into just 1 file, and then also remove all duplication. You can use the sort command and then combine multiple files and then remove all duplication. The same way can be done or accomplished with using just a sort -u and the name of the files, and then the output, the final output you want to save the file into. To count the number of duplicate entries, we can use the -c option with a unique command. And this is the syntax for doing that. So you have seen me using the sort command against the passwd. So this is how you can do that, removing all duplicates and also sorting alphabetically. The WC stands for word count, and we can use that to count the number of lines, words, or characters in a file or list of files. Now, multiple files can be provided to the WC command to display totals of all the files. And we can use that with even piping. So an example, we are listing the var log directory and using the pipe and then word count line by line. The same thing with, we can just use the WC and then provide the actual file. So in this case, we are using this and it's giving us the total lines in this file. Cat is also another command that you may find a lot useful to extract a specific column from a file. In some instances, for me, for instance, being an OffSec professional, there are some cases that I have to do some get out some files or specific column from a file, such as, let's say you have a list of IP addresses from, let's say, your Nmap scan, and you only want to get out port numbers for a specific port number, let's say port 21, right? So you can use cat to manipulate the output and then extract that particular piece of information from that file. So by default, the column spacer or the separator is a tabbed character. And to specify a delimiter, again, talking about different tools and having different options. To use a delimiter with the cat command, we specify the -d. We can use the F option to indicate which files to extract from the file. So an example here is, let's walk through this particular command. We have the cat, and we provide the -d for a delimiter, and this is going to be against the passwd, but because the delimiter in that file is column, we provide that here in quotes. And then we're asking that we want to extract only 3 fields or 3 columns in this file. We want the first column, the second, the third, and the fourth. So these are the 4 columns. So these are going to be the first, second, third, and the fourth. And as you can see here, 1, 2, 3, 4. So we're extracting those information from that file without needing the rest of them. So the grep, is used as a search tool to scan files for specific pattern. So we can use grep to look for a specific pattern from a file to save us time. And you have seen me also using this command already. The syntax, one of the many syntax is grep the pattern that we're looking for, and then also the file we want to get it from. So this is an example of using the grep to look for bash from the passwd file, and it will show us every instance of the bash occurring somewhere here. If we want to, by default, it will show by color, or we can take off the color as well. So we can specify the color, and that would have the same accomplished goal. If we want just a count of it, we can just use the -c to count, and it will tell us how many occurrence of that particular string or pattern that we found from the file. And these are the additional options that we can use with the grep command. We have the V to print lines that do not match a pattern. We have the -c to count the number of lines that were matched. We have the -i for case insensitivity. We have the color to color the matches found. We have the -l to list the matches, the matching files. And then we have the -w to match a pattern as a word. So let's jump into a demo on how to do some sorting and then also grepping. So for this activity, we are going to walk through a typical real world scenario that if you are anyone who are into the InfoSec field and you do any offensive security operations such as red teaming or pen testing or just ethical hacking, you come across when you perform maybe an external pen test or even internal. Now, one of the attacks that we normally carry out when it comes to pen tests gaining initial foothold is an attack called password spray attack. Now, for that particular attack, we need to have a list of users, usernames, and then just spray that against a web portal or any application that accepts user credentials. So we can have, maybe depending on the size of the organization, you may have maybe 100 or even 1,000 users, and then try one password against that user list and then see which one will be using that particular password. Now, there are several ways that you can get the list of these users from your reconnaissance, and one of them is obtaining a list of email addresses for an organization. One place you can get such information is the phonebook.cz. And during this activity, if you want to follow along, you would have to go to this website and you would have to register with this site called intelx.io. It's free. And then once you've been able to log in, you can follow along and then dump the email addresses that I'm about to use for this activity. So for mine, I'm using this particular company as just a test called ibm.com, and I'm pulling out all the email addresses from this website. So now we're going to manipulate this particular email, this particular file, and then just try to extract some information such as usernames using all the techniques we've learned so far from the sorting and searching. So once you have that email, all of them copied and saved, I have mine saved in as emails.txt. So when I do less, this is what I have, the first page I have for this particular text file. And I have a whole bunch of extraneous information which I don't need. So we are going to use the different techniques to go through and then extract information that we want. So if I do tail, for instance, against this file, we can see that this is the last 10 lines I have from this file as well. If I do less again, and then hit tab on my keyboard space, it will go through and then begin to show me, walk through all the email addresses I got from this page. And then Q to get out. We want to use the WC word to count how many lines we have here. And we have over 38,000 possible email addresses here. Well, over 38,000 possible lines, because there are some lines that do not contain email addresses. We can also just use the L, so WC-L. and that will give us the line itself. We can see there's a difference between the outcome from the first default command. So we can use the WC command to display only byte and word count. So let's use a WC, and then we use -CW, and then the emails. And we can see that now we're seeing just the byte and then also the word count. And let's do the tails. Tail, emails, to show us the last 10 lines. You can see that it is also counting spaces as line by line. Let's use the tail command to display the last 40 lines. So we do tail and then -n and then 40 and email. And that will display the last 40 lines. We can repeat that, and instead of using just "n", we'll just use a -40 for the same outcome. Let's use a head again for the email to give us the first 10 lines. Let's use the more command, and we can see the more gives us the percentage of the pages that we have gone through so far on this file, and we are still at 0. So far, this file contains extraneous data that we do not need. So we need to focus on how to extract the important stuff that we need to get from this data. And let's start by using the grep command to combine with the less command to test out our extraction. So we type in grep, and we are interested in, let's say, everything that has at ibm.com in it, which most likely will be all the emails, right? So emails, and we want to page through with the less command. So what we're saying here is go through the emails file and look for all the files, or look for all the entries that have this text at ibm.com. And this is one way for you to extract only text that has an email in it. So we hit enter, and that is going to only show us all the information, or only email addresses, or anything that has a domain IBM in it. And then we can just use a spacebar on a keyboard to go through this. So you can see that this is now weeding out all the first lines which had some additional information which were not needed. So I'll click on the Q to exit out of this. Now we'll combine the grep and the word count to count our new results. So let's use the command again, like this. And let's remove the less and bring in the WC and then count. And now we can see that we move from, I think, 30-something thousand lines to now only 10 lines, because it's now counting only entries that have at ibm.com in it. Let's use the redirection and save this into a new data. Let's call that email. Let's call it email.new. So we can use a less against this new file, email.new. And now you can see that we don't have any of those extra stuff in this file. If we use a tail, now we have all email addresses. So let's say we want to combine the sort and then the less command to display the output in a sorted order. So we can use sort email.new and then less, and this will sort out. You can see now we have a different kind of first line. So this is going to sort out everything for us. Now we can step through like that. So we can also uniquely sort out this email address and then save the new results into a new file, called email.sorted, because this file may have some duplicates. So if we do the count again, we know that is 10,279. So let's try to do cat email.new and sort-u, and then save that into emails.sort. And now let's count that and see if, well, so it looks like there are no duplicates. Good. Let's extract only the usernames from each individual email addresses. If we do less and do emails.sort, and we go through quickly, we can see that these are potentially the username at email address. We want to extract only the usernames and just dump out the at ibm.com. So we'll use the cat, and the delimiter is going to be the at symbol, because this is what combines both the username and a domain name. So we want this delimiter, and we want the first field, which is the username from this file sorted. And then we want to use less to go through page by page. So what we're saying is we're using the cat command, and we're saying go through that email.sort, and the delimiter we want you to use to divide this and then give a first line is the at symbol. So if we do hit enter, we'll see that now we don't have the at ibm.com, but only the usernames before the at domain.com. Let's do that again and then save that into a new file called usernames.txt. So let's get into another scenario, which is also typical in any offensive security operations or penetration test. And that is, let's assume that during an engagement or an operation, you had gained access to a Linux system. And in this activity, we are going to attempt to perform some system intelligence gathering based on the access we have gained on, let's say, a Linux system. So first, we will use the cat command to, let's say, display the content of the past WD, which will show all the users in that particular Linux system. So we have that, and let's try to use the grep command, and let's grep for occurrence of a username by the name user. And you see that it has user here and a user here and here. So it's going to give us every instance where this is present in here. Okay, so let's say we want to find out the services that are running on the system and then only want the SSH from their services. First of all, the services on the Linux systems can be found under the etc and the services. So these are all the services that are typically running on the system, and they have their port numbers and the protocol type. Let's say we don't want to go through all this. We just want to find the occurrence of SSH. So we can use grep SSH, and then the file we want this to look for SSH from. And it will give us this as SSH on port 22, and it's a TP and TCP protocol. We can also find all entries in the same services file for the keyword FTP and fine-tune our results to show those that use a TCP protocol. So we'll do grep FTP and then the etc services, and then we greppin for with pipe, and then grep for TCP. So you can see that we are even using the grep twice, but they're in a different command line. This is a first command, and then we're using the output from this command to become an input for this command using the pipe. So we hit enter, and this shows us every instance where it has FTP in it, and then the protocol is TCP. Let's fine-tune the search for the FTP services that do not use a TCP protocol while printing out the line number. So we call out grep again, and then -n for line, and then FTP services, and then use grep again, and then -v for not, and then TCP. And this will show us only UDP protocols. Let's also get all strings that start with the SH or end with the ST letters from the etc subfolder services. So we do grep and then -e, oops, and then this means start with SH, -e, and ends the $ appending. The ST means ending with ST. And then we're doing this from the services, and we only got one. So the shell begins with SH. We didn't find anything that ends with ST. Another technique that you would also find useful when it comes to searching or extracting data from files in Linux system is regular expression, or regex. So regular expression is a collection of characters used for pattern matching and string parsing. Now, this can be a little bit confusing, because we just finished up with sorting, and then the find, and the tail, and then head, and the grep, right? So you may find some similarities between this and then also grep, but this has its own unique flavor, and some of the pros and cons that it has may be different from using the grep. So regular expressions can contain both normal characters or meta characters, such as the asterisk and then also the $. We have two kinds of regular expression. We have the basic and the extended regular expression. The basic one can be used with other commands, such as the grep, vi, awk, and the like. Now you have to understand that the regular expressions are different from the wildcards we had used previously, or the glob. So that is where sometimes some people find it more challenging the first time you try to use these techniques within Linux. But once you practice more, they'll become very familiar with it. So let's look at some of the characters that you find useful, or combining them in a regular expression. The first one is a period. The period will match any single character. The next one is brackets. The brackets will match any one of the enclosed characters. The backslash will escape special characters. We have seen this previously in some of our demos. So this will become just an iteration or repetition from some of the concept. The asterisk is going to match 0 or more of previous sub-expression characters. The correct string would appear at the beginning of the line, and then also the end of the line is the $. So regular expressions and some of the examples are as follows. So talking about the period. So let's say within our regular expression, we provide a ... That means against that, and when we use this against any particular file, we are looking for everything that begins with an A and then has 2 more characters after that. So if we use this against, let's say, a word such as lazy, it has A in it. So we'll pick up A and then add in the the Z and Y. So it will display the A, Z, Y. If we use the B dot, this pipe, and then J dot, this is just an OR. If you recall, we had done this before. So this is going to match anything that has a B and then one more character, or J and one more character. So if we do this against this particular sentence, it is going to find the BR, which we have is B, and then the dot will represent an R, and then J, U, which will be a J, and then the dot representing a U. The same thing with the appending or the last characters. If we use the dot and then the $ against, let's say, a dog, it is going to have the O for the first dot. It is going to have the O for the first dot and then the G for the second dot. So we'll get the OG out of it. If we use the L dot and then asterisk, this is going to find everything after L. So it's going to have the dot from here. If we use it against the lazy dogs, it will pick up this entire sentence because we are using an asterisk or a wildcard, which will represent everything after the first appearance of this character. If we use the L dot asterisk and then a Y against, let's say, lazy dog, it is going to pick up everything from the L and the first appearance of a character, which in this case is A, and everything else in between all the way to that end with a Y. So this will be lazy, will be something which will come out of this sentence. For this particular one, again, it's similar to the L here. We're just saying that this command will match every sentence that begins with the word the. So the and this would even represent either a space or an actual character. So these are examples of command that we can use with regular expression to fine-tune our output. So let's step through each one of these briefly. So in this particular screenshot, we are using the grep and then making it a color, and they're using the A dot against the pass WD. So we're saying that any word or character that begins with an A and has two more additional characters, display that. And of course, in color. So we can see occurrence of every 3-letter word or string that begins with an A. The next one is the bracket character. This would match one of the characters enclosed within the bracket. This can be a list, such as this one we have here as ABC, or a range of characters, such as A through Z. So this will match any character specified in this range. The same thing with this, it will match any one of the characters in the enclosed bracket. One thing you should be very aware of when using this bracket is the listed characters must be in correct order. So if you put in, let's say, D-A, a range from D through A, that is not correct. So this will not be a valid regular expression character using the brackets. Placing the caret at the beginning of the characters within the brackets will exclude those characters from your search pattern. So if we were to put, let's say, this caret in front of the A, B, C, that means exclude this from our search pattern. Let's continue with this image here. The command matches two characters. The first is either an A or B, while the second command matches either an A, B, C, or D, but excludes the characters X, Y, Z from the grep search against a pass WD file. So this is the command here. We have the grep color, and we're using the brackets. So match either one of these, and then also match A from between A and D. So that would include the A, B, C, D. But exclude these ranges X, Y, Z. So we're using this caret in front of the X through Z, and then against this file called passwd. So any 3-character word that has an A in it will show up here, or B will show up here, and then also exclude anything that is Z will also show up here. And that is what this is displaying. BAS, for instance, is valid. and ADM is valid. All of these are valid. The asterisk matches 0 or more of the previous characters. So in the image below, we can see that we are saying that use a grep and then search for every occurrence of a word or a character that begins with at least NIG. So it will pick up NIG, and then everything that follows is going to meet this particular search from the African country list. So in this case, it picked up Nigeria and Niger. When you want your match to occur at the beginning of the line, place the correct character before the string or the text in question. So an example is, before using that, let's assume that we want to find every occurrence of a text or a string that begins with an R against a pass WD. When we use the grep for that, with this particular command, you can see that it's giving us all this, even anything that contains an R is being shown and not everything that begins with an R. So even though we have the root here, this is displaying the var, which has an R in it, but it's not the beginning. So this has a different outcome. If we want only text that begin with an R, then we will use a caret in front of it and we'll read out all this extra information and only produce information or text that has R as the beginning letter or character. The $ is the opposite of the caret. If we want our match to occur at the end of a file, we place the $ character at the end of the string or text in question. So an example is, if we want something that ends, we want all text that end with a T, we'll just provide a T and a $. So in this output, or from this screenshot, we match all African country names that end with a character A using the $. So all of these end with an A. The / character is when we try to match a text or string that is also a special regular expression character. And we have done this before. This is us trying to escape from a character which is translated as a special character with the regex. So let's look at this example from a file called cache rules everything. Now for this, we're looking for the letter A here, and then this produces that here. And then we're using the same thing, and we want to display everything that has an A in it or begins with an A. And we get this. But the reason why that is happening is because if you take a look at here, we have an A here, we have this character, but it's not highlighting this character, which is not good because we are asking for an A and then everything else that follows. But for some reason, it only stops here without including the $ here, because the $ is a regular expression character. So if we want to escape and then have this display everything that has A as a beginning or A in it, including any special character, we'll just place the / before that particular character so that the terminal or the shell will interpret this as just a regular character and not a regular expression character or special character. And that is the reason why when we place or we escape this, it's now highlighting the $. We can combine so many of these characters and then fine-tune our results. For instance, the $ and then a caret can be combined to match any blank line in a report or in a file. We can combine the characters, this and then the brackets, to list all African countries whose name begin with either G or Z. So in this case, we're combining these two regular expressions to make our outcome a much more appealing to us. So within the regular expression, we have both the basic and also extended regular expression. So to apply an extended regular expression to a search, we can use the egrep command, or we can use a grep command with the dash uppercase E option. If we use a grep dash uppercase E again, and then we provide this particular string, which is a color, and then a question mark in between here against this particular file. If this file has these two letters, color spelled with the C-O-L-O-R or C-O-L-O-U-R, all of them will be matched here. That is why we have the question mark here. So it's going to be either this or that, and then followed by the R, and that should still work. If we use the grep dash uppercase E and then D plus against a file, and this file contains several texts, but all of them or some of them contain double D, triple D, or quadruple D, it would list all of them because it has the plus after that. If we use the grep dash uppercase E and then we provide gray pipe and then gray with the E, it will pick either one of these and then still match them. So this is an example of the extended regular expression. Let's jump into a demo and then put some of these concepts into practice. Let's use the find command to search for the file name SSH within the etc directory. So find, and then the etc directory, name SSH, and we can see some access or permission denied here. Let's try to redirect this error into a different file so we don't see that. So we bring up the command and then to and the greater than sign, and let's save that into temp folder and call that error.txt. Let's call it error2.txt, and that will put all the errors in that file. If we do cat and then temp folder, that should have this error in here without displaying that in our terminal. Now let's redirect both the standard output and the standard error into two separate files and display the contents of these files. So find HC, and the first is going to go into temp folder and then standard out.txt. And then we want to also direct the error into temp folder. And let's call this error3.txt. So with this command, nothing was displayed in our screen. But if we do cat standard out, we get this right one. And then for the third one, error, we get this as well. Let's display the passwd file again so we can see the structure of this file. So we can see that for each of these lines, we have this root, we have the delimiter is column X, column 0, column 0, column this, and you can see the drift. So we have 1, 2, 3, 4, 5, 6, 7. So each one of these would have the same structure. So 1, 2, 3, 4, 5, 6, 7. So we would need this number as we going ahead to try some other commands to extract some pieces of information from this column. So with that said, let's use a cat command and then use a delimiter, which is this. We can either do it this way or put it into brackets and then call out the first line or the first field from the passwd, and that is going to dump out only the usernames from this file. So we use the delimiter, the -d, and then ask the command to cut off those numbers and then produce only the first line, line 1. If we were to change that to, let's say, line 7, because we have 1 through 7, that should give us these from that file. Let's say we want to use that and then combine that with sort. This will sort out our output for us as well, for the usernames. So let's use the find command for the files beginning in our working directory that contain the name hist in it. So we do find and tilde from our home directory, and then dash name. And then let's see if we have anything that has history or hist in it. And that was empty. Let's try with, let's say, doc, and we don't have any. And if we were to change this to, let's say, dash type as D, and we don't have any neither. Now let's add an asterisk to this and see how this changes everything for us. So you see now, because we're using the asterisk, it's not telling us to produce everything or display every directory that begins with a doc or doc in it. Let's find files that were modified or created less than 2 minutes ago in our home directory. So dash M and then minute, dash 3. And yes, we do have these files were created about 3 minutes ago. Okay, let's use the current regular expression character to match only lines that begin with the term syst, which is SYST in the passwd file. So grep, and this is going to start with that, and then st, let's close it, and then etc passwd. So this would show us terms or characters that begin with syst. Let's use the $sign regular expression character to match the pattern no login at the end of the line in the passwd file. So grep no login and the $sign. So produce all the text that have no login at the end. So all these have no login. Let's use a grep command with the dash uppercase E option to find any entry for SSHD, root, or operator terms in the passwd file. SSHD or root or operator. And we got only 2 that contain the user root. Let's use a grep command with a dash uppercase E option to search for a pattern containing a sequence of 5 digits. So grep dash uppercase E, there you go. So this is going to search for a pattern that contains a sequence of digits, 5 digits. And so this is going to go through 0 through 9 and then look for only pattern, anything that contains 5-digit number in it. Let's construct a user name that begins with either A or an S from the usernames we created. So grep dash color usernames. And yep, we do have the users that have either A at the beginning of their names or S at the beginning as well. Now let's construct a regular expression command to match only users that have the username ending with a B. The B and a $sign. And all these are the users that have a username that ends with a letter B. Let's proceed with one of the most well-known concepts within the Linux system and the community, and that is turning commands into a script. So this particular sub module is going to be all about scripting and how we can take things that we keep writing or commands that we keep writing into simple scripts. And some of the key areas we're going to look into are the basic shell scripting and also how we can use text editors or even IDEs in writing scripts. So let's just go through a quick refresher on the shell. Now, everything that we have done so far from the terminal essentially are driven by the shell, which allows us to either interact or non-interactively issue commands to the underlying system. The shell allows us to use commands to talk to the system to perform certain actions such as storing or retrieving data or process information, create directories, look for files, and things of that nature. So an example is a screenshot we have on the right side where we are able to issue commands such as date to display the date, display calendar, issue pwd to show our current directory, ls to list our current directory. So these are some of the key information that when we type on a command line are taken by the shell and then execute on the backend system, and we get a feedback in the screen. Up until this point, everything that we have been doing are all repetition of commands that we do type them once at a time. However, there's a way for us to take all these commands and sometimes the need for us to have some of these repetition put into just one file and then have them executed at a time, one time. And that is where scripting comes in, or bash scripting. So bash scripting allows us to combine multiple commands and save them into a file, which we call the script. Now, the script, because of this, saves us a lot of time. Instead of having multiple commands written all the time individually, we can now have all of them into one file, and then with just one command, this file would execute all these commands in our behalf. So an example here is a screen showing us the content of just a simple script. And the script is test.sh. And all it's doing is echoing back hello world. Now, this might seem just very simple, but it's just baby steps for us to understand what is happening. So once we run that particular script using sh and the name of the script, it just calls out this particular command and then displays hello world to us. So with all these things happening, there's a few concepts you need to understand that makes this possible. And that is, a script would always or most of the time use what we call interpreters. And we talked about this in our previous slides. There are several of these when it comes to Linux systems. An example on how to find which interpreters you have on your system is typing cat, etc, and shells, and that will show you all the available interpreters you have on your system. Interpreters are what determines what type of script you are writing. So let's say you are writing a Python script. An example is you are going to need the interpreter coming from user, bin, and Python. These do change periodically based on a system that you're using. If let's say you're writing a bash script, an example is you are going to use a bin/bash, or Perl will be this particular shell and path. Most scripts are written using text editors such as Nano, Vim, Vi, gedit, and the likes. You can also use other IDEs such as the Visual Studio on how to also write your script. As you're getting to use the bash scripting, there are some few standard language syntax that you need to be aware of, and those are things you need to have them within your script. The first is the hashtag. This would have multiple meanings, but for most of the time, this character is used to add a comment within your script, with the exception that if we add the backslash and then that character, then it would have a different meaning. Or if we use this with that exclamation mark, that would have a different meaning when you have it at the beginning of the script. And we'll take a look at what that stands for and what that means. If let's say you have a long command and you want to cut it off and then continue on a new line, you can use this backslash and then have it at the end of where you want to drop to a new line, hit enter, and then continue your new command on a new line. And what would happen is the shell or the interpreter will be able to understand that this command is a long one and will continue on the next line. And we'll take a look at an example on how that is used. The semicolon is what is used to combine multiple commands. So this means what follows is just going to be a new command to be executed. The same thing with the dollar sign. So what follows is going to be a variable, an environmental variable. We talked about redirectors. So these two would either use for a redirector for an output or to append into an output. If we want to take an input, then we can use this particular sign to take an input as a redirector. Similar to the semicolon, the pipe is also used to take one output from a first command to become a new input for the second command or the subsequent one. So talking about the hashtag and the exclamation mark. In the Linux world, it's called shebang. And that is the default first line that you always have within your scripts. So the hash plus bang stands for shebang. With this particular shebang, what follows is the full path of the interpreter you are going to write for your script. And this is good because once you have the shebang and the path of the script, you are telling the shell that this is what interpreter it should use to execute your commands. So if you put in shebang, user, bin, Ruby, when the person runs your command, the shell will take these commands and then interpret them into Ruby language. The same thing with Bash, Perl, or Python. Once you've written your script and you want to have it executable from your current directory, we need to have this executable first before we can run it. The next command that you would also find useful, which we have used several times, is the echo command. But it also does have additional options you can use based on what you're trying to accomplish in your script. So the echo command is used to display the text or a value of a variable. So the syntax, as you have seen us using, is the echo, and then some options, and then the string or the variables you want to execute, you want to echo out. These are additional options you can work with when it comes to the echo command. If you use the echo with the -n, which we'll use in some of our upcoming demos, that says do not output the trailing new line from the command. If we combine echo with a -e, this is going to enable interpretation of one of these backslashes for escaping a character or for escaping something or a string. So if you use, let's say, echo -e, and then whatever follows, we begin to use either one of these, they will have different interpretation or different outcome. The most well-known one you come across may be the backslash and then n, which will say once you execute your echo command, drop into a new line. The next useful one will be the carriage return and even horizontal tab. If let's say you have an actual backslash within your command and you want to escape that particular backslash, then you need another backslash for that. Yes, it sounds confusing, but that is how it is. So we previously touched on variables, but that was mainly on a command line. And if you remember, I did mention that variables become very, very useful when it comes to writing your script. So let's do a quick recap on what we've covered previously on variables and how they become very important when it comes to writing your script. So most scripts use variables, of course, like I said, to hold values, which can be used within anywhere in your scripts. And variables can be used to hold either a string or integer. Now, variables allow you as a programmer to store a data, even alter the data, and then reuse them throughout your script. So let's take a look at how a variable can be defined, or different ways variables can be defined within a script. So the first one is, let's assume that we want to call out this particular variable most of the time within our script, but each time we call this, it is going to call out hello, or it's going to print out hello. So we define a variable called salute, and then equal sign, and then put this particular string, the value within this, and then assign that to hello, assign that to salute. So let's say within your script, you want to say hello to whoever is writing the script. Each time they run the script, and then we call out the salute, it will print out hello. We can also use expansion. Remember, when we were able to execute command within a command. So in this case, pwd is a command on its own, but we can use a tick mark to the backtick and then assign that this command's output into this particular variable called dir. So in this case, when we run a script and then we call out this particular variable, it is going to execute this particular command and then give us the output. The same way that we can also call variable from another command. So in this case, we have this variable defined as nm, and we are executing hello, but we are calling out the name, which may also have something assigned to it, a value assigned to it. So to use the value of a variable in a script, we assign the $ in front of the variable's name. So when we have, say, pwd as a value assigned to the dir, we don't call out pwd anymore. Each time we want to call out or execute this particular command, we will just call out this variable by assigning a $ in front of it. And the shell will understand that this is a variable and is going to dump or output the content from this command called pwd. The same way with this one, if we use echo against nm, it is not going to run all these commands on its own. It is going to say hello and then execute this particular variable, because the shell will understand that there's a $ in front of this nm. That means this is a variable and it's supposed to execute the value assigned to this particular variable. So we talked about types of variables. Again, we have the environmental variable. These are variables built into the system, and they are maintained by Linux itself. These are defined with uppercase letters, and we have the ones which are defined by us as users, and those are maintained by us, and we can have that in a lower case. So we're calling out a pwd variable using the $, and I'll print out our home directory for that particular user. This is equivalent to just typing the pwd, but in this case, we're calling out the environmental variable. This particular one is also doing the same thing, but in this case, we are doing the expansion again. We are calling out a command from within a command. So we're calling out a variable from within our command. So we issue echo, my current directory, working directory is this one, and we'll issue out this particular environmental variable showing our home directory. The next one is echo, my login username is, and again, the environmental variable for the current user is uppercase and then the user. And then this one will display the username for us. The next one is the same drift, but this time we're calling out the host name environmental variable, which will print out the name of the computer. In this case, it's called Fluffy Wabbit. So the user-defined variable can be used from a terminal or within a script. And this is how we define our own user variable. So we provide the name of the variable. In this case, this is my_var. And then we assign a value to this particular variable. So the my_var is being assigned the temp folder. So when we use the echo and this time calling out the variable, we have to assign the $ before that, before the name of the variable, and that will echo out the value that was assigned to it. Now, I think I had given this previously. There should be no space between the name of the variable, the equal sign, and the variable's name. So this particular example, we are creating two different kinds of variables. The first variable is color 1, and the second one is color 2. The first variable has the value blue assigned to it. The second one has a value red assigned to it. So anytime within the script, if we want to print out something that says blue, we don't have to type blue anymore. If we type in or we call out color 1 with a dollar sign in front of it, the shell would always understand and remember that color 1 has a value of blue and will print it out. So in this example, we use the echo command, my favorite color is, and then we call out the variable using the dollar sign and then the variable's name. If we want to have the red print out, it's just a matter of calling out the red, the color 2, and having the dollar sign in front of it. Now, a variable can also be assigned a value from an output of another command using the backticks, or also enclosed within the dollar sign and the brackets. And you have seen me doing this already from the previous slides. An example here is the hostname variable gets its input from the Linux command called hostname. So we can also use the same thing and put it within this bracket. So this is called hostname.sh. We have our shebang and we're calling this from the bash interpreter. And now we have this as the variable, but hostname itself is also a command. So we want this command to be executed each time we call out the hostname variable. But to do that, we have to put this into backticks, or we could have put this within brackets and a dollar sign in front of it. So when we issue out and say, let's say we run out echo, this server's name is, and then we call out this variable, it is going to issue out the hostname command and then display the content, which is going to be the name of the system. So when we run bash hostname.sh, and then we'll get this echo being issued, and instead of printing out the hostname itself, it is going to print out the outcome from this command, which is the Ubuntu-serve. Sometimes it becomes very useful for you to ask your users to input something based on prompts. One of the many ways to do that is you can use the read command from the echo to take an input from a user. So when a user types in a command, the read command will understand that and then reserve that or take the input and then save it into a variable, and then we can print out that particular variable. So again, let's take a look at this particular script. So we're using echo-n, and then this is the name of, this is what we ask in the user. When the user types in the name of the country, now the read command is going to assign that to this variable called country. And then we're now going to use echo to print out this variable. So the read is using the country variable as a storage to store the user's input temporarily, and then we can use echo to call out the particular country's name from this variable. And as you get more and more into using scripting in Linux, there are some few things that you need to get yourself acquainted with. And one of them is special variables. These are variables that you and I have no control over. They are reserved for certain contents, and those variables range from the $1 through $9. Now, each time you execute a command or a code or anything within Linux, we have what we call an exit code. The exit code determines whether the command was successful or wasn't successful, or there was an error. So all shell scripts will normally generate a return value when the script does execute or complete. This value can be set explicitly within our script, or it is implicit. Now, the code which are generated are between 0 through 255. Anytime that your code successfully execute, it is assigned the code 0. Anything after that is going to be either an error or some sort of message which is not related to be successful. And of course, we can test out and see for ourselves if our command did execute successfully or not. To test for this successful or failure execution command, we can use the ls command to confirm whether a file does exist or not. And the return value is stored in the environmental variable, which is represented by the question mark, the $, and a question mark. So we try to list the etc pass wd, and that gave us an outcome. This was successful because etc pass wd does exist on this system. So to confirm this was a successful execution, we use the echo and then the $, and then the question mark. And we got that exit code 0. So again, going back to the slides, we have between 0 and 255. And anything that returns 0 means successful. However, if we try to list blah from the etc folder or directory, because this doesn't exist, we do get an error that this file or directory doesn't exist. But if we want to still confirm this was the case and what number was assigned to the $, and the question mark variable, we will just do echo and the $, variable, and then we get 2. So anything which is not 0 is some sort of either a failure, an error. The numbers assigned are beyond our control. An error may have a different number. Aside from 2, it could be 3, 5, or whatever. But we have between 0 through 255. So we talked about expansion a brief moment ago. So expansion is when a command expands or changes into something else. And in Bash uses the $, for command expansion. The command names or symbol to be expanded is usually put within the bracket. Let's go through another command or an example to reinforce this concept. So here we are using the echo command, but this time we are using the -e option. We talked about that, right? And we're going to combine that with the \n, which is going to give us or drop us into a new line. And the expansion is right here. So we're using the $, and putting in the command we want to execute, which is ls, into this bracket. So what would happen is it is now expanding this particular command from within this entire command. And that is what the expansion stands for or means. So I know we've covered a lot so far. Let's get into demos to reinforce these key concepts when it comes to Bash scripts. So first, let's start by trying to list or identify interpreters we have on our system. cat /etc and then just shells. So on our Ubuntu system, these are the available interpreters we can use to run a script. Let's check out our current working directory. We are on a desktop. Let's make a directory called scripts where we'll save all of our scripts in. And let's change directory into scripts. And we have nothing here. Let's write our test script by using some variables. We're going to use nano text editor and then call this out, let's say colors.sh. To start with, let's begin with our declaration. So it's going to be hash and then exclamation mark and then bin and then bash. So this is going to be our shebang. Let's assume you want to leave a comment in this script. So we can use the hashtag and type in this is just a comment. So what would happen here is when we run our command, because we have the hashtag in front of this, the shell will understand this is a comment and would not run it. So now let's go ahead and then define some variables. The first is let's define color 1 and then assign a value of, let's say, pink, and go to next. And let's assign another variable 2 and then call this yellow. And let's call out echo command and let's type in what we want the command to produce on the screen. This time we are going to call out this first variable, but if we type in just this means nothing. It is just going to type this out to the screen. So to confirm that, let's save and then run this command. So we'll just do Control X and then save. Remember, this is not executable yet. So if we do // and then try to run this command, it is not going to work. Okay, we need to make this executable, and we'll talk about this in our subsequent slides. But to make this executable, chmod and then +X and then colors like that. Now see that the color has changed now. So now this means it's now executable. And don't worry about this command. We'll do a lot of these in our subsequent slides or demos. So now if we do colors like this, we can now run this script. So if we hit enter, this is going to echo out, or it's going to print out our echo command. But see, this just printed this out literally. This is not what we're trying to accomplish. We want this to run the value we assign to the color variable. So let's go back into our colors script, and let's fix this problem. So we go here and then we add in the $sign like that. So now we are calling this variable now. So if we save and we get back, oops, let me go back. I may have done something wrong here. Oops, yep, I forgot to add 1 to it. Okay. Now my favorite color is pink. It's not calling out this particular variable's value. The next one was, we also talked about expansion, which is when we are able to execute a command from another command. So for instance, if we run the command, or if we type a command hostname, this prints out the name of the computer. If we use echo and then print out the environmental variable for hostname, that would accomplish the same thing. If we type who am I, that will tell you who is logging into the system. So this is also a command. But what if we want to assign this as into a variable and then call that out later from our script? The same also goes with the host name. If we want to expand, if we want our script or our command to expand to execute another command, is that possible? So let's create a new script called hostname.sh, and we start with our shebang. Then let's add in a comment and let's create a new variable name called hostname like this. And we are going to use the backtick and we are going to execute the hostname itself and then close that. Now let's call out echo. And now we're going to call out this variable. And you know how we do that, right? We first of all call out our $sign and then the name of the variable. And then we close that like that. Okay, let's go back and create one more variable called user. And this time, try something different and put this into call this who am I command. And let's use echo. So this can be done in one of two ways. The expansion can be done with a backtick or put them into bracket with a $. X out and save. Since we are using bash, we can just call out bash itself like that, and then the name of the script. And that can also be executed without first making this script executable. So if you hit enter, now these are executed, the commands were executed, and then the output were put into those variables and then disclosed or displayed on a screen, the same way as this one. Let's create a script called welcome.sh. And this time, instead of using the text editor, let's use the Visual Studio. So if you did install this as you were following along, to call that Visual Studio from a command line is code, hit enter, or you can access that from the show application option. So this should give us the Visual Studio. And so in my case, I am here on a desktop. You can always create a new file from here, or you can create a new folder from here, or even for a quick start. So we are within the scripts here, and we have the colors, and then we have host name. To create a new file, I'm going to click on this new file and then call this welcome.sh and hit enter. We'll begin with our shebang, and this is going to be bash. And let's go to new lines, and we're going to create a new variable called greeting and assign that the value of welcome. Now you can begin to see already the benefit of using a tool, a development tool such as the Visual Studio, because by default, it actually did close out this for us. It does auto completion and some nice features for us, which doesn't come with some of these text editors. So that is going to be our first variable. The second one is let's also find the user. So we'll just use user, and then again, you can see that it closed out for us as well. And we are going to call out the who am I command. And don't forget about your $sign here for the expansion. So that is the second variable. The third one is we want today. So we want to also assign day. And then let's bring in a $sign, and then open and close will do automatically for us. And then we have to issue out the date command, and then plus. So we have 3 variables declared. Let's go up and leave a comment here. Okay. So now let's issue echo, and let's put that into bracket. And we're going to call out the greeting variable, and then the name of the user. We call out this particular variable here too. Today is, and we're going to call out the day variable. And then let's call out another variable, and let's print out another echo. Your bash version is, and now we're going to directly call in another environmental variable which wasn't declared here. So it's going to be $sign bash underscore version. Enjoy. Control S as in Sam, and that will save it. And if we do ls, we should be here, and let's change into scripts, which is where we have our scripts saved. So now we have the welcome here. We can use bash and then welcome. And we can see that welcome back, and my username is user. If I do who am I, my name is user, and today is Saturday, right? And your bash version is this particular version. Now let's create another script that is going to check for an existence or do some comparison for an existence of a file or not. So we go back here and then we click on new, and then I'll call this test.sh. And now we are going to do ls does not exist.txt. So it's going to list, it's going to try and see if this file does exist or not from whichever directory we run from. And then we'll just issue out the echo command, and we want the status, check, and we'll print out the status using this environmental variable. So remember, we talked about the fact that the status can be either 0 or any number after that. If it's not 0, that means it was an error or a failure. If it's a 0, then it was a success. So this is going to check and see if when the command lists ls and then this file name does exist or not. And then we'll print out the status. The next one is, let's also try out and then create a new file and check that one as well if it does exist or not. So we'll use a touch command, touch, and then call this does not exist.txt. So this will create an empty does not exist.txt, and then do the ls again, and then dash.txt again. And this time it is going to exist, but we still want to confirm that. So print out a new status code and then tell us if this was a success or not. And then once we're done, just remove this file. So rm and then does not exist.txt. So this should be now a good script to run. So 3 things are happening here. We're going to check and see if this file does exist or not, and then run the exit code for us and see if we get a 0 or any number besides that. And then now create an empty file and then check again and then print out the exit code and then remove the file once the commands are run. So let's save this, Control S to save this file. And now if I do ls, we should have test here. So I'll run bash and then test.sh and then run. And then it will tell us that the status code was 2 because it doesn't exist. We got this error. And then once it was created and then we did run the status code, now we have a 0 and the file was now removed. So as you begin to write more advanced scripts, there will be some times that you would want to accept parameters. So a script can take what we call the command argument or a parameter, such as a file name from a user or a path to something. Now, the parameters or the arguments can be represented with a $sign and a number or a special character. Now, each of the commands has an argument number, which the script always having the first parameter. The first one is a 0. That represents the script itself. Now, every number that follows is going to be the number of the parameters you have or the arguments, with the first one being the first parameter or the argument. So let's assume we have a script that takes a file's name from a user. The file name is going to represent the first parameter, or it's going to be assigned the $1. The second one is going to be $2, and then 3, and then 4 until it hits the number of parameters you accept from your script. If you want to have all the list of parameters within your script, you just use the $sign and then the asterisk. If you want to know the number of arguments you have in your script, you can use the $sign and then the hashtag. So at the top here is a content of a script which breaks down these parameters and they are placed in a command. The first one is a 0, which is going to represent when we run this particular script, which is called parameter.sh, if we run it right here, right, bash doesn't count because that is the interpreter. So this is going to be assigned the parameter number 0. This is going to be assigned the number 1 because this is going to be the third and the second parameter, or the first parameter or argument, number 2, and then 3. So the first one is saying that the name of the script is, and then it will spell out the name of it because it has a parameter assigned is 0. So it's going to call out this variable. The first parameter from a command line is 1. It is going to take this variable and then assign this particular number or string to it. The second one is the same. We'll assign this number or this string to it. And then if we want to print out all of the parameters, that is, we have to use the $sign and then the asterisk. So in this case, all parameters from a command line are, and we have 3 of them, 1, 2, 3. And of course, if we want to, have, say, the name of the parameter again set, it will just get it out here as an echo, the name of the parameter, and then execution complete. So I know it can be a bit confusing, so take your time to brush through this again because parameters or arguments are things that you would have to use a lot in most of your scripts and need to understand the order in which they are being used. So again, a quick refresher on the input and output and error redirections. So we said that programs and commands can produce outputs which require input or thrown out an error. Now, an input and output of a program are referred to the stream, and we talked about 3 of them. We have the stream number 0. We have the stream 0, 1, and 2. The standard input, which takes an input by default from the keyboard. And this is example syntax, which is we take an input from here, and then it becomes an input into this file. The standard output by default display into the terminal, which we can use this arrow file, the arrow, to either add into a new file or append it to a file. The standard error by default arrows out output display to the screen, and that uses number 2 to save all of our error messages into a file, or we can use the get bucket or the def and null to discard any error. So that is a quick refresher on the input and output. Now let's get into some input and output and redirection demos. So in this demo, we are going to create a script that will backup, or will create a backup and also redirect any error messages appropriately. So we go into creating new file, and let's call this backup. So we create a variable called user, which is going to execute the whoami command. And we also create another variable called input, which we have the home and then the user's home assigned to it. And then we have an output, which is going to have the temp folder as a value and then this name of the file assigned to it. We are still using some command expansions, especially calling out the user and then also a date. So we are issuing out and they're using the date and then doing some formatting to it and then adding or appending the .tar.gz to it because we are going to use a tar command to create and also zip a file and then save it to the output using this input. The input is going to be the home of that particular user and then discard any error and then save that or redirect into the def null. And then once we're done, we want to have a message read out to us backup of this input, which is the home, the user's home, is completed, details about the output backup file, and then we want to list out the output, which is this particular variable. So we save it. Let's hope we don't have any error. Oh, we have a syntax error, our first error. All right, now let's stop it. And the good thing with these tools, they'll point you out at where your error is. So in this case, line number 5, we have an error here. So I'm going to investigate and then fix this problem and then rerun it.
3,000 years later.
All right, so I did quick fixes to this and then hopefully it does work. So one important mess up I did was I was supposed to put this into curly brackets for this variable and then also did fix this particular date problem. So hopefully this works out as expected. So now that I have that saved, let's run bash and then let's see, call it backup. And it looks like things are working. We don't have any error. So what is happening here right now is it did create these variables, user, input, and output, and then assign these values to them. It's now running the tar command for dash C is to create, Z is for zipping, F is the fact that we have a file as an input coming in here, and then create or save the output into this and call out this variable and then save it in this format. So it's going to save it with the username underscore home and then the date and time it was saved and then append .tar.gz to it. If it finds any error messages in the course of running this command, it should just save it into the dev null or trash it. And then once it's done, it's going to echo out this for us, calling out all these individual variables to confirm it has been done. So this is now running the ls against this output to confirm that we have this file created. And as you can see, we have the temp, the name of the user, underscore home, and then the date that it was created. So sometimes we may have to perform some comparisons within our script. And the following are some symbols or strings that we can use within our script for various decisions. So this side is what we typically use in most of our scripts. And these are descriptions and also their equivalent comparison on the string side. So the -LT stands for less than, and this is the symbol that you would normally use in a command for comparing. We have the greater than sign here, -GT, and that is a corresponding symbol. The EQ is equal, and of course, that is a symbol. If we are comparing something and we mean to say if it is not equal to this, then it's going to be -NE, not equal, and it's exclamation mark before the equal sign. The less or equal is -L and -LE, and that doesn't have any corresponding string comparison. The same thing with greater than or equal. But if we want to check for the existence of a directory or a file, then we can use -D and then the name of the file that you want to check for, or the name of the directory you want to check for. And then the -F is for a file. So these are some examples that we can walk through. So in these examples, we are declaring two variables. We have the variable A, and we are assigning it a value of 10. And then we have variable B with a value of 20. And we are trying to use the various comparison characters and then see how the exit code looks like, whether it's successful or not, or whether it's true or false. So in this case, we are saying that 10 is less than 20 because the A is variable assigned. The value assigned to the variable A is 10. The value assigned to variable B is 20. And in this case, we're comparing these two. And then once we're done, we want to check and see if the exit code was true or false. So we use echo and then the $, and the question mark, and we get 0. So that means that was a successful execution, or it was a true statement. Let's try out untrue statement. The same thing, but we change and say 10 is greater than 20, which is not true. So we use the same command echo and then check out and see what was the exit code. And it was anything but 0. So we got an exit code of 1. That means false. And then we said the 10 is equal to 20, which again is not true. So we get an exit code 0. And then we say 10 is not equal to 20, which is true. So we get an exit code of 0. Let's continue. So now we can also use strings. So in this case, we are actually putting this without declaring separate variables. So we're comparing apple to bananas. So we say apples is equal to bananas. And then we check out the exit code and it says 1. That means it is false. Now we're declaring variables and then assigning these as well in the same way. So we have the first variable of str1, and then we have apples assigned to that. We have the second variable str2. We have bananas assigned to that. And then now we do the comparison again, but in this case, we are comparing the variables str1 and then str2. And you can clearly see that we actually just identified another way of how Linux can punish us if we don't follow the conventional way. So if you see that, it's telling me or gave me an error that we're missing something here. And the reason why I got this was because I did not put a space between this variable and then the square bracket. So again, talking about sticking to the conventions within Linux. Even if you miss just one, it will punish you for that. So now when I went to the next line and then put a space in between the two, that did execute. But of course, apples and bananas are not the same. So the execution was a false statement. And then the next one was apple is not equal to banana. And that gave us an exit code of 0, which is true. So let's continue with some examples of how we can combine some conditional statements with comparison. So on this side, we are comparing, or we are checking for an existence of a folder. So we are just using the -d to say if this file does exist. All right, so check and see if temp does exist, then do this. If it doesn't, or else, do something else. So this is when we're checking for existence of a folder. If we want to check for the non-existence of it, then we use exclamation mark before the -d. So in this case, we are checking if the folder or the directory does not exist. We can have the same thing done for a file. The only difference here is we're changing the D to an F to check if a file does exist or not. On the other side is true. We're using the D-F is supposed to be an F. So this is just an error here. I forgot to change this to an F, but yes, so -F is checking if a file does exist, if the file does not exist. As you write in your script more often, there will begin to be some cases where a decision has to be made. And that is where the decisions will be based off on some conditions. So a conditional statement allows you, the programmer, to implement a decision making within your script. And the typical examples are the if condition, or elif, or standing for else if condition, or even case statements. So let's get into an example of a syntax structure of how an if condition will look like. So in this case, you specify an if and then square brackets, and then the condition is within in here. So if this condition is met, then do this or execute some commands here. Else, do that. If the condition is not met, then do something else. The same way that we can also test out some condition here. If we test this condition and it works, then execute this condition or this command. Otherwise, do this instead. So in this screenshot, we are using the if command and we are checking if the user is not a root user. The root user is always assigned the number 0 when we run the ID-u. And of course, we're using the comparison statement here. -ne is not equal. So we are saying that if, and this is a condition, if the ID space -u is not 0, then write out this statement, you are not a root. Otherwise, that condition is met and you are root. We can also combine some of these conditions. So what this first condition, combined condition, is doing is it's using the logical AND combination. So both of these, the first condition and the second condition, should all be true before this instruction can be executed. Otherwise, even if the first is true and the second is false, or the other way around, this condition will not be met, and then the second one would actually kick off or fire. The second one is the logical OR. That means either one of these should be true for this to execute. Otherwise, that will execute. So the first condition should be met, or the second, then run this instruction. Otherwise, do this. There are also instances where we can have multiple chains of if statement, or called elif or else if. So the elif or the else if statement can be used to perform more complicated tests and then take appropriate action. So in this case, we have the if, the condition, then do this. Else, if the second condition is true, then do that. Otherwise, run this and then finish it. So this is an example of using the else if or the elif. We do the same thing with the previous example, but in this case, we are asking for more information or giving much more conditions to have this work out. So we have the first if condition, which is still going to check and see if the user is a root. So in this case, we are now using the not equal. We're using equal. So we're saying that if the ID-u is equal to 0, that means this user is a root user. So echo out you are root. Else if the ID-u is equal to 1000, then echo out you are sysadmin, because the ID number for the sysadmin is 1000. Otherwise, just run this echo statement because none of these conditions are met. Of course, you can have so many of the else if statement in one command or in one script. If we run that command as just a regular user as sysadmin, it checked out that the 1000 ID is assigned to the user admin, and then it will print out this. If we switch over and then become root and we run out the script, it is going to kick the first statement, it's going to be met, and it will tell us you are root. Now, there are some cases that if you end up having so many conditions within a script and they are all using the if, then, else, fi block or statement, that can be a little bit too much, and that can make your code not appealing. So one way for you to make your code a little bit much more nicer with multiple conditions is using the case statement or the case condition. So the case statement provides a different way of simplifying the multiple test cases or scenarios that you would have used with the if condition, else if, and then if I block. Of course, the case statement has its own structure and how it's supposed to be written. All case statements also start with a case keyword, and a variable or expression needs to be specified followed by the in keyword as well. Now, each pattern has to end with the closing bracket to indicate the end of a particular pattern. We can also have multiple patterns chained with just a pipe, and we'll go through an example of how this looks like. So a typical syntax with a case condition may look like this. We have the case keyword needs to be specified. We have the expression also specified, and then the in condition. And now we'll begin to run each of the pattern and then have them written out separately. So each one of these ends up with the semicolon. They are all self-contained. So each pattern will have its own line and then the closing. And this is what we meant by having each pattern being closed with the closing bracket, and then execute this command. So this pattern, run this command, end with the two semicolons. Or if the second pattern is met, run this command and then close or end with two semicolons, and the third and the fourth and the likes. We can specify a default command to run with the asterisk and the closing bracket. And then our case may also end with the ESAC as well to close out our entire case statement. Let's get into some demos to reinforce some of the key concepts we have discussed so far. And this is going to be on case statement. So let's take a closer look at an example of how we can write a script using the case statement. So let's walk through step by step. The first one is we are just echoing out what we want to take from the user. So we use the echo -n and then specify a statement to the user to accept an input from this user. Once we get that input from that user, we will use the read from the echo command to read that particular entry and then assign that into a variable called car. So once we have that assigned, we are now going to begin our case statement. Remember the keyword case, and then the expression is now going to be the variable that we have taken something from the user, and then the in keyword as well. So these three needs to be met: the case keyword, the expression, which can be a variable taken from somewhere else, and then the in keyword, and then ending that with the ESAC. Now begins the actual conditions that we want to specify here. The first one is a pattern. If the user types in Tesla, the pattern is specified and then ends with this close bracket. Close bracket. Okay, so once this is specified, we are now going to run this command. So we are saying that if the entry from the user is Tesla, then write out this output. We can also specify multiple patterns with a pipe. If the name is either BMW, Mercedes, Audi, or Porsche, that particular car is manufactured in Germany. Same with Toyota, Mazda, Mitsubishi, and then also Subaru. So these are all the condition or the case statement that we are now having them within here. And you can see this is much more nicer and compact than using multiple if and else statements. Now we end up with a default echo with the asterisk and then the closed bracket. So this is how an example of a case script will look like. So if we were to run bash and then case, we are now being prompted. This first command is run. And let's say we type in Tesla. We hit enter. It's going to take our input and then assign that to this car variable. And now going to do a comparison of all these patterns and then print out the appropriate echo statement. So if I hit enter, we'll see that it is now going to take our input and then place it in here and then print out this statement for us. If we were to run this command again and then just type in anything, blah, it is going to go through all these and would not find any of this pattern, and then execute the default statement we're asking that to execute. Let's walk through another case statement script. We are asking for a user to enter a number 1 through 12, and then we would display the corresponding month name for that. We are taking an input from a user by displaying this statement. So we're asking them to enter in 1 through 12, and you can see that we are actually using the expansion again by issuing out the who am I command using the backtick. Once the user inputs a number, we use the read command and then create a variable called num and then assign that value. Now we are going to do some checkup before we run the case. This is a little bit new, but what we're doing here is we are comparing to make sure that the user has entered a number. Otherwise, if there's no number entered, we'll exit out of this script. Once we have passed through this, the next is the case statement. Again, we begin with the case, the expression, this case being the variable holding the number the user has input in, and then the in keyword. And then we add in with the exec. And we are now adding one additional command, exit out successfully. So let's go back into the declaration of the patterns. So the pattern matches number 1, then write out January. If it's 2, February, all the way through to 12. If the user enters anything which doesn't match any of these patterns, the default statement that should come out should be this statement right here, and then exit with exit 2 that there wasn't a successful or there was an error somewhere. So now if we call out this, if we run this script called month.sh, so bash and then month.sh, the echo is executed from line 3, and then I'll put in, let's say 12. And we should see the corresponding output saying December. And then once we receive that, we get our exit code 0, and then we clean out our code or our script. Let's run again, but this time do nothing because we did not enter anything. This part of the code was executed. We got a red here and we just got out of it. If we run again and I put in, let's say number 13, which is not on here, it will go through and then match the pattern. And because it did not match it, it ran out our default and then exited with code 2, again giving us this red here. Okay, there was a failure. If you can see, it says there was a failure with a code number 2. If we run again and instead of number, let's type in blah. All right, we still do get our regular code exit number 2. So we continue with the conditional statements and some of the key features that you may find useful and also implement in your script. And one of them is list, or creating a list to be used within your script or even from a command line. Once created, we can access the content or the list items or the items from the list. Now, each item within Linux is assigned a number called an index. The numbers start from 0, being the first item from the list. Now, to create a list, we surround that using the curly brackets. And if we want to access the list items, we use the square bracket with the particular index that we want to search for, or we can use the @ symbol to display all of them. So once we use the @ symbol, that will display all the list items in the list. We can also create the list by using the brace expansion. So talking about expansion again, right? So we can use an echo and then provide a range of numbers within the brace bracket to create a list based on this condition. So this will create a list from 0 through 10. Let's look at an example from the command lines on how you can create several types of lists and even access them. So in the first place, we're creating a list name called list underscore alpha. We use it on the bracket to specify the list items. So this is going to have the items containing A, B, C, D, E, F, G. And now if we want to call out either one of these or all of the items within the list, we will use the square bracket and then the index number or the @ symbol to display all of them. So in this case, we are using the echo command and we are issuing the list, calling out this variable and then all the content for this list. Another way is we are now going to specify individual index number to display whatever item we want to display. So in this case, the index number 0 corresponds to the list item A. So once we specify 0, it will print out the first item, which is A. So this will be 0, 1, 2, 3, 4, 5, 6, 7. So once we call out number 4, that is going to print out E. If we call out 7, that will print out H. Let's continue with using a string. We're creating a new list called list underscore days, and we assign Monday, Tuesday, Wednesday, Thursday, and Friday to it. If we want to list all the items, we use the @ symbol within square brackets. If we want to call out any particular item, we use their corresponding value or the index number. Because we don't have 6, this is 0, 1, 2, 3, 4. We have only up to 4. Any number aside from that will produce an empty output. So in this case, number 3 is going to be Thursday, which is the index number 3. Another conditional statement concept is also going to be loops. So with loops, you can execute one or more lines of code repeatedly. So if there's a code that you want to execute so many times until a condition is met, then we can use several ways of loop. We have several of them. We'll just focus on these two, the for loop and then the while loop. The for loop operates on each element of a list, whilst the while loop repeats a set of statements as long as the control command returns true. So let's take a look at the syntax and an example of how it looks like. So we have a syntax of for item in a list. So as long as the items are being, we still have this item, run these commands. So let's go into an example. We have a variable called names. And within names, we have Alice, Bob, and Charlie. So for n, which is just a placeholder for either, each one of these items, as long as we still have these names in the list, do this. Echo out that particular name. So for n in names, echo out that name. So for Alice in names, write Alice name, echo out hello, I'm Alice. For Bob in names, echo out Bob. For Charles in names, echo out Charles. And of course, this is us calling out this variable, which is the names. So once it hits the end, then it will just be done and our code will be completed or will exit out. Let's get into while loop. So the while loop seems to be the opposite of this. Whilst the test is actually true, keep running this command. So let's set out a variable counter is equal to 0. Whilst the variable counter is less than 10, so 0, 1, 2, all the way through to 9, do this. Echo the kernel number, which is this number right here, and then keep adding 1 to it. So it took 0, it will take 0 plus 1, and then write 1. 1 plus 1, 2, until we hit 10, and then it will exit out. So let's take a look at how we can use a for loop. So we define for a file in Etsy. Okay, so here we're looking for all the files here. And then if the file name is equal to resolve.conf, then do this. Create this first variable and then execute this and assign to that. We're using grep, and if you recall, the -c will give us a count. So -c and then name server, and then it's going to count every line that has name server in it. And it will echo out the total of, that is the variable's name here, and then it's found in this file, and then break, finish, and done. Break, instruct the bash command to exit the loop based on some conditions. Continue is also another keyword you may also want to use in your command, because the continue would instruct your bash script to stop running through this iteration of the loop and begin in the next iteration. With this example, if it's not able to read a particular value, let's say for instance, if you want to do a recursive listing of a directory, but it's not readable, we just want to stop and then continue to the next iteration. Sometimes you may want your users to make a selection from a list of options. So the script can take items and then have them in a list and then present that to the user on the screen as a menu so that they can pick and choose whichever command or instruction they want the script to run. It's a way for you to make your users decide on what they want to do. One downside here is the select command doesn't do any error checks. So if the user hits an enter without entering any data, then the list of options will be displayed again on the screen. Of course, we can have this ended by using the break within our command. So this is a syntax. The select item in the list, and then once they have it selected, run these commands based on whatever selection the user selects. So we have the variable defined here, which has Fluffy, Wabbit, Bunny, exit. So this will create a list, and we are using the PS3 select an option. So when the user select, let's say, a name in names, if the name that they have selected is equal to exit, break out of the script. Otherwise, if they select, let's say, Fluffy, Wabbit, or Bunny, just echo out hello and the name that they selected. So let's get into a demo and do some more practice with these new concepts on how to make a decision with our scripts. All right, so let's walk through this script called decisions.sh. And what is happening here in a ballpark is the script is supposed to prompt a user for a name of a directory they want to create, and then the script will create that directory for them. However, we have some checks in it to make sure that the directory doesn't exist already. So what happens is once it creates a directory, it will change to the newly created directory and then print out the directory's path. It would also use the touch command to create 4 empty files and then run the ls command on them to verify they are empty. Now we'll also put some contents into the newly created empty files using the echo and then redirection. Once it's done, it will display the file's content using the cat command and then display the path to the newly created directory or folder to the user. So let's step through step by step quickly. Some of them may be repetitions, so we're not going to take too much time on that on them. The first one is, again, a prompt for the user. And then once the user types in the name of the directory they want to create, we will use the read command to create a variable called new underscore directory and then assign the name of the directory. So to continue, we'll save the user's current working directory in a different variable so we can reuse the variable later. So command expansion will create another variable and then assign the user's current directory to that as a value. Next is we're going to do some health check to make sure that the new directory the user input in the command line does not exist already. If you recall, we will use a -d for a directory check. If it was a file, we'll use a -f. So we're using a -d against the name that the user provided, and if it does exist, we'll issue an echo and the name of the file and say this file does exist already. Choose a new file and then we exit out. If it doesn't exist, we'll use the make dir command and then create this new directory based on the name that the user provided. Once it's created, we'll use a cd command and then change directory into the newly created directory by the user, and then use pwd to display the directory. The next command is going to be the for loop command. So now we're going to use a for, and in 1, 2, 3, 4, create a new empty file for each one of these numbers and append the number to that. So this will be touch file 1, touch file 2, touch file 3, and then touch file 4. And then that will be done because the for loop is going to go through these 4 values. And then once it's done, we'll just use the ls command to confirm these files were created. So once it's done, we'll continue with the for loop again. And then this time, we're going to put in some content into each of these files. All right, so for the file, the 4 names in the file, which is going to be file 1, file 2, file 3, and file 4, add in these contents into each of these files. And then once it's done, again, do cat against each of the files to confirm the contents were created. And then now we can write an echo and display to the user where the file is and where the new directory is located at. So with this done, let's go ahead and run this command and then see how it's supposed to function. So we'll type in bash and decisions, and we are prompted to enter in a new file name. So let's call this wabbit. And all these are executed. First of all, the directory doesn't exist already. So it will pick it up for us. And this is going to be the name of the directory is created. And then it's going to kick in the for loop and create file 1, file 2, file 3, file 4. And then once it's done, it is going to put in some content into each of these files using this second for loop and then display the content of each one. Once we're done, it's going to execute or issue the echo command, the echo statement, and then this will display the name of the directory we just created. Let's run the command again, but this time let's enter in a directory that already exists, and you can see it is on the far left here. If we hit enter, it will do the comparison again here, and then this part of the code is issued and exited. So for our next script, we are going to test out how we can also test how parameters are used within a script. This script is going to take exactly one parameter argument from the user. Now, the script will print back the provided argument name to standard output. The script will generate a usage message if the user runs the script without providing any parameter. So this is how it looks like. We're going to use the if statement to check if the parameter provided is equal to 0 or not. If it is, if they haven't given us any parameter on a command line, we will issue out the usage on how to use the parameter. Otherwise, we'll echo out the name of the parameter, which is going to be this one right here. The $0 is assigned to the script itself. And then every subsequent parameter is assigned 1 through infinity. All right, so the first parameter will be assigned the $1. So if we type in bash, and then the name of the script is param.sh and hit enter, because we did not provide any parameter next after this script, it gave us the usage. So this time, if we bring it back again, and then let's type in Fluffy, this is going to be assigned the value of $1 because it's the first argument from a command line. And we hit enter, and it will echo back this parameter for us because it's the $1. Let's continue with another script on making a decision. And in this particular script, we are asking the user for a number, which should be either 1 or 2 and nothing else. And any other input should create an error and display to the user. Now, what happens is if the user provides either 1 or 2, this will set an environmental variable set to yes if it is 1 or no if it is 2. And it will export the variable and display it on a screen. So again, we're using the echo to take an input from the user and then assign that input 1 or 2 to the variable A and S, which is the answer. All right, and then we're going to set up a return code by using the variable called RC. So once we have this variable set, we are now going to do an if statement and do some comparison. If the answer provided by the user is equal to 1, then use the export command and then create a variable called eval and then set the value to yes. Else, if the answer provided by the user is equal to 2, then create a variable eval and set the value to no. Else, if the value provided or the answer provided by the user is neither 1 nor 2, then create the variable eval and set that to unknown. We use the echo statement to print out the value of the environmental variable that was assigned. And of course, if it's not 1 or 2, exit out with the exit code of number 1, which is a failure. So let's try out and run this command and then ask the user for a prompt. So bash, yes or no. So we enter 1, hit enter. The value of eval is set to yes. So that is expected. If we run again and then type in 2, the value of eval is set to no. If we run the command again and then set that to 3, we'll have an unknown for us. So this is how this works. And of course, because that was provided an unknown number, the exit code kicked in as number 1, and we got this error here of failed. So sometimes as and when you create more and more scripts, your code becomes a little bit too much to handle. You may have tens or even hundreds of lines of code within your script. One way for you to manage this huge amount of code is what we call functions. Functions in a bash script is a way for us to reuse a code because there are certain times that some piece of code may become useful to you to have them used repeatedly or reused within your script. And a good way for you to create a piece of code that can be reused within your script is using functions. So function is essentially just a small chunk of code which you may call multiple times within your script. They are very useful when it comes to certain tasks which need to be run several times within a script. Now, instead of you writing the same code over and over again, you may write it only once and then using a function, call that function multiple times within your code without needing to rewrite each one of these codes several times. A way for you to write a function can be either one of these ways: syntax, the function, term or keyword, and then the name of the function, and then what follows will be the command you want to run. Or you can even forgo the keyword function itself entirely, and then just the name of the function, and then in curly brackets, the commands you want to issue. So this is just a syntax or example of how we can write a script using a function. So we start by defining the function by giving it a name. So on the right side, the function hello will be the function's name. And then within the curly brackets, we may have many commands we want to issue. Once we have all these conditions defined within these curly brackets, if we want to call out this function, it's just a matter of just calling it out in any part of our code by just a function's name. The second way is just, again, just the name of the function without needing the keyword function and having this brackets before it and then the curly brackets, and then have that printed out, call out this function as many times as you want in its own line within the code. So let's get into a demo on how we can create some functions and then audit a system by applying these concepts. So in this script called audit.sh, we are going to use multiple functions to reinforce the concept we have discussed. So this particular script is going to check the system for its current disk usage, CPU usage, and then the memory usage as well. And we'll create function for each of these checks and then create the mother of all functions that would execute all these functions and then call that particular function as well. So let's step through step by step and how we're creating all these multiple functions and how we can call them out individually with a mother function and then call that particular mother function too. So first, we are going to create a variable called server underscore name and then store the host name of that system by calling out or executing this particular command, host name. And then we'll echo out the name of the system by calling out the variable server underscore name. The next is going to be multiple function that we're going to create. The first one is we create a function called mem underscore check, which is going to create this function. And what this is doing is it's going to use the free command to check the memory status of this system. The free command, if you remember, is just a command from Linux. So if you copy that and type it down here, this will show us the memory, the amount of RAM on the system. All right. So the next one is a CPU usage that would also use the uptime to execute the CPU usage. So if I copy that and paste it here, that will give us a CPU usage. And the next function is kernel underscore check to give us a kernel of this machine. So uname -r will give us a kernel of this system. So it's just running the typical Linux commands, but creating and saving all of them within just a function. So each time we want to use any of these functions, we just call them individually and they should be good to go. But another thing we can also do is, since we have multiple functions created, we can also create a function called all_checks that will call out all these functions into one. And then once we're done, we can call that particular function and it will just run all these different functions from all of these created functions. So what is happening here is we are calling these functions under this mother functions. And now once we are done, we'll call only this one and we'll execute everything for us. So we can reuse this function anywhere within our script and it will run all these three separate functions we have created without needing to write all of these at the same time in our script. So clear the screen, and then this time let me run the audit.sh. And what is happening here is it run this particular function. It's not running all this individually. It just run this one because this function is calling all these functions. And each one of these functions are defined standalone here. All right, so this is one way for us to use function in our script. We are going to combine function with other concepts such as case for doing the audit work. So this time we are enhancing the audit code to add in menu for the user to pick and choose which part of the command they want to run or the function they want to run, because sometimes the user may not need to run all the system checks. They may want a particular function to run, and we want to provide them with an option to choose which function they want to run. So the code still looks the same from all this part all the way down to the mother function. And now we begin to do or add in some customizations going forward from there. So the first one is we creating some variables to add color to our selection. We create a color for the function. So we have the green, we have the blue functions, and then we create a new function called the menu. And these are the options we are assigning to this menu. So we put in the read command, and then we assign the variable of A, and then we call out case. So the case keyword, the expression is the variable A, and whether it's 1 through 0, we bring in the in keyword, and now the padding to match. So if the user picks up number 1, it's going to call out the mem check. If the user selects number 2, it's going to call out the CPU_check, and then the rest will follow. If the user does not select either one of, none of these, then we kick in a default action is to provide an echo statement that it was an invalid option, and then clear the screen. And we'll call out this new function which was defined at the top here. So let's run the script. So once we hit enter, we still have the system name is here, which is being called from the top here. Once we select either one of these, the code would now step in and then kickstart the case statement. So if we choose number 1, now the case is going to do a check and then call out the check_mem function and then execute accordingly. So we hit in, and that will kickstart the check mem function. If we select, let's say number 4, that will call out all_checks, which is the mother of all functions, and then run all the checks. And if we want to exit out, we type in 0 and we exit the code nicely. If we run the code again, and instead of selecting either one of these, we just select anything. Let's say we type in blah, 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 like that. it will tell us that was an invalid option, and then it will exit the code out. And I think I had an invalid line 69 here that needs to be fixed.
3,000 years later.
All right, so I had an invalid entry here. So I went ahead and removed that. So now if we type in blah, 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 then we should have this kicking in and then exiting our code as well. Fantastic.